Welcome to Simplilearn's Data Analytics full course. If you're ready to dive into the world of data analytics and learn how to turn raw data into valuable insights, you are in the right place. Data analytics is the process of analyzing data to find patterns, trends, and answers that help businesses make smarter decisions. Every industry, whether it's tech, healthcare, retail, or finance, needs experts to interpret their data. And this demand is only growing. In this course, we'll cover everything you need to succeed, starting with an introduction to data analytics, followed by mastering tools like Power BI and SQL for data analysis. We'll also cover topics like data transformation, how to create Power BI dashboards, and important business analytics and interview questions to prepare you for real-world job opportunities. We'll also learn the key differences between data analyst and business analyst, explore ChatGPT and Excel for data analytics, and even work on hands-on SQL project. And by the end of this course, you will have all the skills to launch a successful career in data analytics. So let's get started. Also, if you're interested in professional certificate course in data analytics, begin your learning journey with Simplilearn and IIT Kanpur's Begin your learning journey with Simplilearn and IIT Kanpur's Data Analytics Certificate course. Explore our learning management system, track your progress, and meet completion requirements. Join the professional certificate course in Data Analytics recognized as a top PG data program by AIM. Learn to understand data and enhance your analytical skills through live sessions with industry experts, hands-on lab and masterclasses by IIT Kanpur. You can check out the link mentioned in the description box and in the pinned comment. So without any further ado, let's get started.
Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large data sets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial.
So what does data analysts do? On a huge dataset, data analysts gather, analyze, and run statistical studies to glean insights and spot trends. They use various methods and tools to transform complicated data into useful insights. They therefore provide insightful data that enables businesses to make informed decisions, and this is the answer of question what data analysts do. So moving forward, let's jump into roles and responsibilities of a data analyst. The roles and responsibilities of a data analyst often consist of the following. The first one is create and manage databases and data system, fixing coding mistakes and other data related problems as necessary. The second one is using both primary and secondary sources for data mining. The third one is rearranging data in a way that both individuals and machine can understand. The fourth one is create documentation that clarifies the data analyst process for stakeholder. So now let's jump into how to become a data analyst with no experience, steps and strategies. So becoming a data analyst without prior experience can be challenging but achievable goal. So here is a detailed guide on how to break into the field of data analysis from scratch. So the first one is master the basics. Data analysts need a mix of technical and soft skills. Start by learning the basics of statistics and mathematics. So key topics are descriptive statistics. Learn measures of central tendency, mean, median, mode, measures of variability, range, variance, and standard deviation, and data distribution like normal distribution and skewness and kurtosis. The second is inferential stat. Understanding hypothesis testing, confidence intervals, p-values, and statistical significance. The third one is probability theory. Basic probability concept, conditional probability, and Bayes theorems, and many more. The fourth point is linear algebra and calculus. fundamental concepts that underpin many statistical algorithms. So you guys can learn these topics from our Simplilearn's YouTube channel, where each topic is explained in depth by our experts. The second point is programming languages and Python. In Python, learn the basic syntax, data types, and control structures like loops and condition. The second one is libraries for data analysis like NumPy, Pandas, and Matplotlib for data manipulation and visualization. The third one is library for statistical analysis like SciPy and stat models for performing statistical tests and modeling. And in R, like basic syntax like data types and structures. Data manipulation like dplyr, tidyr. The third point is statistical analysis, base R function, and package like ggplot2 for data visualization. So you guys can learn these topics from our Simplilearn's YouTube channel, where each topic is explained in depth by our expert. The third point is data visualization and reporting. So in this, we have first Tableau. Creating and customizing various charts and types like bar charts, line graphs, scatter plots. The second is building interactive dashboards and stories. The third one is connecting to different data sources and data blending. The second one, we have Power BI. Data modeling and creating relationship between data sets. The second point is designing reports with visuals, filters, and slicers. The third point is using DAX, data analysis expressions, for advanced calculation. In this category, third, we have Excel. So in this, you can learn advanced formulas like VLOOKUP, HLOOKUP, index, match, and arrays formulas. The second is pivot tables, summarizing, analyzing, and visualizing data. The third is data visualization, creating and formatting charts, sparklines, and conditional formatting. So you guys can learn these topics from our Simplilearn's YouTube channel, where each topic is explained in depth by our expert, or you can go through their official document websites. In Master the Basics, the last point is SQL database and the key concept. The key concept are basic SQL commands, select, from, where, join, group by, having, or order by. Second is database design, understanding tables, relationships, and normalization. The third is advanced SQL, subqueries, window function, and common table expression, CTEs. The fourth one is database management, connecting to a database, writing optimized queries, and understanding the indexes. So you guys can learn these topics from our Simplilearn's YouTube channel, where we have SQL playlists covering each topic that is explained in depth by our expert. The second point is work on your personal project. Applying your new skills to real-world problems is a great way to gain experience. So here are some projects ideas to help you get started. The first one is personal project, public data analysis. Choose a public data set that interests you and perform a comprehensive analysis. For example, analyzing COVID-19 trends over time, predicting house prices, or studying climate change impacts. The second is Kaggle competition. Kaggle is a fantastic platform where you can participate in data science competition. These competitions provide real-world data and problems to solve. For example, predicting customer churn, classifying emails, or creating models to improve sales forecasting. The third one is build a dashboard. Create an interactive dashboard using tools like Tableau or Power BI to visualize data insights. For example, a dashboard tracking global financial market or visualizing crime rates in different cities. The third point is get certified. While certification won't replace real-world experience, they can be valuable additional to your resume. So there are numerous data analyst certifications available online, such as the Google Data Analytics Certificate, the Data Analyst Program by Simplilearn. This Data Analyst course by Simplilearn in collaboration with IBM will transform you into a data analytics expert. In this course, you will learn the latest analytics tools and techniques, how to work with SQL, the languages of R and Python, the art of creating data visualization, and how to apply stat and predictive analytics in the business environment. These certifications not only provide you with the solid foundation, but also show potential employers your commitment to learning and growing in the field. The fourth point is build a portfolio. One of the best way to showcase your skills to potential employers is by building a portfolio. This can include personal projects, data analysis on real-world dataset, or even Kaggle competition. The key here is to demonstrate your ability to apply what you have learned to real-world problems. Don't worry if you don't have access to fancy dataset or tools. There are plenty of publicly available dataset on sites like Kaggle or even government website. You guys can make a portfolio like this. So this is an example of one portfolio. So you can distribute your projects like this, or you can take help from this. Okay. The next point is networking and mentorship. Connect with professionals in the field through LinkedIn, local meetups, or professional association. Look for a mentor who can provide guidance, feedback on your projects, and potentially help you with the job referrals. Networking can be invaluable in learning about unadvertised job openings or internship. The next point is internship. Apply for entry-level position or internship. Look for job titles like junior data analyst, data technicians, or analytics assistant. Look for opportunities in local community, reach out to startups or non-profits, or even consider offering your services for free initially. Even customer service or administrator roles that involves data entry or reporting can serve as stepping stones, giving you practical experience with data. The seventh point is prepare for interviews. Be ready to discuss your projects, how you approach problems, and what you have learned. You should also be prepared for technical interviews that may test your knowledge of stat, programming, and data analysis techniques. You can refer to Simplilearn's video on data analyst interview question and answer on YouTube. So to sum it up, master the basics, build a portfolio, get certified, get experience through internship and freelancing, network like crazy, and never stop learning. And most importantly, believe in yourself and your abilities.
Let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps.
Today, I've got a question for you. What's the difference between a data analyst and a data scientist? Well, in this video, we will give you the answers. From healthcare to ride-hailing apps and online shopping to streaming services, big data has transformed applications and how we interact with them. Two key fields underpinning this transformation are data science and data analytics. Now, I know these concepts can be a bit tricky to grasp at first, so let's use a fun analogy to make it more clearer. Imagine for a moment that a business is like a human body. In this scenario, a data scientist would be a general practitioner, while a data analyst would be more like a specialist consultant. Both play crucial roles in keeping the body, or in our case, the business, healthy and functioning well. Think of the data scientist as the GP who looks at the entire body. They need to understand how all the different parts work together and how external factors affect overall health. This big picture views allows them to ask important questions about the body's well-being that others might miss. On the other hand, the data analyst is like a specialist focusing on a specific part of the body, let's say the heart or the brain. They dive deep into the area of expertise, answering specific questions and solving particular problems. For example, if there's an issue with the heart, the data analyst or heart specialist would be the go-to expert. But remember, while the specialist focuses on the area, the GP will still keep an eye on the overall health. They work together, each bringing the unique skills and keeping the body or the business in top shape. So in a nutshell, data scientists and data analysts both play vital roles in keeping a business healthy. The data scientist looks at the bigger picture while the data analyst dives deep into specific areas. Throughout this video, we will explore these roles in a more detail, looking at the specific tasks, skills they need, and how they contribute to the data-driven world we live in. So let's discuss the differences between data analytics and data science. Imagine a thriving social media app with millions of users sharing photos, videos, and messages every day. At this company, we have two data heroes, Alex, the data analyst, and Chris, the data scientist. They both work with data, but their roles are quite different. Alex is like the app's detective. Their job is to figure out on how many people are using the app right now. Alex looks at two things. Firstly, which features are most popular, when do most people log in, and how long do users spend on this app. Alex digs through user activity logs, engagement metrics, and customer feedback to answer specific questions. This helps the team make the app better today. That's what data analysts do. They solve current puzzles using existing information. Now, Chris, they're more like the app's fortune teller and inventor rolled into one. Chris takes all the data Alex collects, put a whole lot and more, and tries to predict the future. They ask big questions like, what new features will users want next year? How can we use AI to make the app more fun? What if we could predict trending topics before they explode? Chris uses complex mathematics, machine learning, and computer programming to spot trends and create new ideas. That's what data scientists do. They use data to predict the future and innovate. Both Alex and Chris are crucial for the app's success. Alex helps the app run smoothly and keeps user happy day to day. Chris helps the company plan for the future and stay ahead in the competitive tech world. Let's look at the key definitions of how they differ from each other. Comparing data science versus data analytics. Data science and data analytics, while related, serve distinct purposes. Data science is a broad multidisciplinary field encompassing areas like machine learning, artificial intelligence, and computer science. It involves researching vast amounts of unstructured data to ask and answer strategic, long-term questions. Data scientists often build complex models and algorithms focusing on innovation and strategic decision making, and they usually hold senior roles. In contrast, data analytics is a specialized discipline with data science that focuses on analyzing existing structured data to answer specific and immediate questions. Data analysts interpret data, identify trends, and provide actionable insights using tools like SQL and Excel. They often work in specific departments like marketing and sales, While their skill set is narrower than the data scientist, they have a deep understanding of their particular business's area. Essentially, data scientists create a big picture framework while data analysts zoom in specific elements within that framework to optimize current operation. Let's talk about the skill set comparison. Skills for data analyst. Proficiency in business intelligence tools, strong statistical analytical skills, intermediate programming skills in SQL and Python, expertise in data visualization tools like Tableau and Power BI. Next, let's discuss the skills for data scientist. To be a data scientist, you must know advanced knowledge of machine learning and AI. You must have experience with big data platforms such as Hadoop and Apache Spark, strong programming skills in Python and R, proficiency in predictive modeling and data mining techniques. Let's discuss the workflow comparison. Now, let's compare the workflows of data analyst and data scientist. The workflow of data analyst typically begins with data collection, where they gather data from various sources to ensure they have all the necessary information. Next comes data cleaning, a crucial step where they remove any errors and redundancies from the dataset to ensure accuracy. Following this, they perform data analysis, using statistical methods to interpret the data and uncover patterns and trends. To present their findings effectively, data analysts then engage in data visualization, creating charts and graphs that make complex data more understandable. Finally, they provide actionable insights, offering recommendations that can be implemented immediately to improve business operations. In contrast, the workflow of a data scientist starts with identifying the problem, where they define a strategic question or opportunity that needs to be addressed. Then they proceed with data mining, extracting relevant data from large data sets to gather the information needed for the analysis. Similar to data analysts, data scientists also perform data cleaning to prepare the data for analysis. However, they take it a step further with data exploration, conducting exploratory analysis to understand the depth of data. Next, we have feature engineering, where they create new features from raw data to enhance their models. And then they build predictive models to forecast future outcomes based on the data. Once the models are ready, they deploy the model into production and start generating insights in real time. The final step is their workflow to monitor and iterate, continuously improving the model based on the new data and ensure it remains accurate and effective. Let's discuss the tools and techniques. Let's explore the tools and techniques used by data analysts and data scientists. Data analysts like Alex uses a variety of tools to handle and analyze data efficiently. They often use Excel for data organization and basic analysis due to their accessibility and functionality. For querying databases, SQL is the go-to language, enabling them to extract and manipulate data effectively. To visualize data and create insightful dashboards, Tableau is commonly employed using robust data visualization capabilities. Additionally, Python is used for more advanced data manipulation and analysis, making it a versatile tool in data analyst toolkit. On the other hand, data scientists like Chris rely on slightly different set of tools to handle their more complex tasks. Python is a staple for data manipulation, machine learning, and artificial intelligence thanks to the extensive libraries and frameworks. R is also a key tool particularly for statistical analysis and visualization, providing powerful statistical techniques. For processing large data sets, Hadoop is indispensable. Enabling scalable and distributed computing, Apache Spark is used for large-scale data processing, offering speed and ease of use for big data analytics. Lastly, we have the TensorFlow, which is important for building and deploying machine learning models, making it essential for AI-related tasks. Let's discuss the application comparison. Let's see how the work of data analysts and data scientists relies in real-world scenarios. Data analysts like Alex plays a vital role in understanding user behavior. For example, they analyze which app features are most popular among users, providing insights that can enhance user experience and app's functionality. In the realm of sales, they identify trends and optimize marketing strategies, ensuring that the company targets its audience effectively and maximizes revenue. Moreover, by analyzing customer feedback, data analysts help improve product features, ensuring the company meets customer needs and expectations. Conversely, data scientists like Chris engage in more predictive and innovative application. They use predictive analysis to forecast future trends and behaviors, allowing companies to make informed strategic decisions. For instance, they build recommendation systems that suggest products or contents to users based on their past behavior, enhancing user engagement and satisfaction. Additionally, they develop AI innovations to improve user experience, such as chatbots or personalized user interfaces, leveraging advanced machine learning models to stay ahead in the competitive tech landscape. At last, we will talk about the career path comparison. Finally, let's discuss the career paths and opportunities and salaries for data analysts and data scientists in both the United States and India. A career in data analyst often begins with marketing or finance. Over time, they can transition into senior analyst role to specialize further in business intelligence. There are also opportunities to move into management positions, overseeing data analysis team and driving strategic decisions based on data insights. In United States, the average salary for a data analyst is around $65,000 per year, with senior roles potentially earning up to $90,000 annually. In India, the average salary for a data analyst is approximately 6 lakh per year, with senior roles earning up to 10 lakh rupees annually. In contrast, a career as a data scientist typically requires advanced degrees and specialized training in data science. As they gain experience, they can progress to senior data scientist roles or lead data science teams, taking on more responsibility and tackling complex challenges. Data scientists also have opportunities to work in cutting-edge fields like AI, machine learning, and big data, where they can innovate and contribute to significant technological advancements. In United States, the average salary of a data scientist is approximately $1,20,000 per year, with senior positions often earning up to $1,50,000 annually. In India, the average salary of a data scientist is around 10 lakh rupees per year, with senior roles earning up to 20 lakh rupees annually. In summary, both data science and data analytics are crucial in today's data-driven world. Data scientists focus on the bigger picture and long-term strategy, while data analysts hone in on specific questions and provide actionable insights. Choosing between the two depends on your interests, career goals, and desired salary.
Today we will learn about what is DBMS. So let's start with an example. Imagine a library where all the books are meticulously organized, categorized, and catalogued. This library can quickly provide any book you request thanks to its efficient management system. Similarly, a database is like this library, but for data. Whether it's customer information for a bank, patient records for a hospital, or product inventories for an e-commerce site, databases efficiently store and manage data and making it easily accessible and updatable. So now we'll see the different types of databases that cater to various needs, just like different sections in a library cater to different genres of books. Understanding these basics is crucial for appreciating the advanced functionalities of database management systems. So in technical terms, a database is an organized collection of data, generally stored and accessed electronically from a computer system. Databases can store various types of data, such as text, numbers, images, and more. So let's begin with understanding what a DBMS really is. Essentially, a DBMS is software designed to manage databases. It helps in storing, retrieving, and updating data efficiently. Think of a DBMS as a sophisticated library system, where each book is a piece of data, and the DBMS ensures that each book is organized properly and can be easily found and is kept secure. Imagine you walk into a massive library filled with millions of books. Each book represents a piece of data. In this library, there are librarians who know exactly where each book is and can quickly find any book you need and ensure that the books are safe and well organized. This library is like a database, and the librarians are like a DBMS. And in the 1960s, as the amount of data grew exponentially, we needed something more efficient than manual methods. This led to the creation of DBMS, a software specifically designed to manage, retrieve, and secure data efficiently. Today, examples of popular DBMS include MySQL, Oracle, and SQL Server, which power many of the applications we use daily. Now that we have a clear understanding of what a DBMS is and its importance in managing data, let's delve deeper into the heart of these systems. Just like any complex machinery, a DBMS is made up of several key components, each playing a crucial role in ensuring the smooth operation and management of databases. So let's explore these components in detail. So DBMS consists of several key components that work together to manage data efficiently. Let's look at these components. Number one is database engine. This is the core service for assessing and processing data. And then comes the database schema that defines the logical structure of the database. Then comes the query processor that interprets and executes database queries. Additionally, there are other components like the storage manager, which manages the physical storage of data, and the transaction manager, which ensures data consistency and handles transactions. So let's understand this with the help of an example. Imagine a DBMS as a factory that processes raw materials into finished products. The database engine is like the factory floor where all the action happens. The database schema is the blueprint outlining how everything should be organized. The query processor acts like the machinery executing specific tasks based on instructions. And the storage manager is the warehouse ensuring all raw materials and finished products are stored correctly. Lastly, the transaction manager. It's like the quality control team, ensuring everything is consistent and transactions are smoothly handled. Now let's explore the core functions of Database Management System or DBMS. These functions are crucial for efficient data management and ensure that the systems operate smoothly and effectively, from storing and retrieving data to managing transactions and ensuring data integrity and security. Each function plays a vital role in the overall operation of a DBMS. So let's start with the functions of DBMS. So DBMS stores large amounts of data in a structured way and retrieves data efficiently and allows update to be made easily. So let's start with the functions of DBMS. The functions are data storage, retrieval, and update. So DBMS stores large amounts of data in a structured way, retrieves data effectively and efficiently, and allows update to be made easily. Then comes the transaction management that handles multiple operations on the database while ensuring data consistency. It manages transactions to ensure they are processed accurately and securely. Then comes the data integrity and security that ensures that data remains accurate and consistent throughout its life cycle. That implements security measures to protect data from unauthorized access and breaches. Now moving to the advantages of using DBMS. So using a database management system offers numerous advantages that enhance the efficiency, security, and usability of data. So let's explore these benefits in detail, from ensuring data consistency and integrity to improving data sharing and providing robust security measures. DBMS plays a crucial role in modern data management. Additionally, it offers data abstraction and independence, making data handling more flexible and manageable. So imagine you are running a large company with numerous departments with hundreds of employees. Managing data manually would be chaotic and error-prone, but with a DBMS, data consistency and integrity are maintained, ensuring that everyone works with accurate and up-to-date information. The system also promotes improved data sharing, allowing different departments to collaborate seamlessly. Enhanced security features protect sensitive data from unauthorized access, just like having a robust security system for your company's valuable assets. Furthermore, the separation of data from applications, known as data abstraction and independence, allows you to update or change your applications without affecting the underlying data structure, making your data management more flexible and efficient. So now moving to types of DBMS, that is database management system types. Data management systems comes in various types, each designed to handle different kinds of data and use cases. So let's explore the main types of DBMS. Number one is relational DBMS, then comes NoSQL DBMS, then we have object-oriented DBMS, and then we have hierarchical DBMS and network DBMS. Each type has its unique features and applications, making them suitable for different scenarios. So let's start with relational DBMS. It stores data in tables with rows and columns and uses SQL, that is structured query language, for querying and managing data. Examples are MySQL, Oracle SQL Server, and then coming to NoSQL DBMS, that is designed for unstructured data and big data applications. And it supports a variety of data models including document, key value, column family, and graph. Examples for these are MongoDB, Cassandra, Redis, and more. Now coming to object-oriented DBMS that stores data as objects, similar to object-oriented programming. that supports complex data types and relationships. Examples for these are DB40 and ObjectDB. Now moving to hierarchical DBMS, that organize data in a tree-like structure with parent-child relationships, and that is efficient for specific applications like directory services. And the examples are IBM Information Management System, that is IMS. Now moving to the next, that is network DBMS, that uses a graph structure to represent data and its relationships, and it supports many-to-many relationships between data. And the example for these are integrated data store, that is IDS. Now imagine you are managing different types of libraries. A relational DBMS is like a traditional library with books organized in rows and columns, easily searchable with a catalog. Now coming to NoSQL. So NoSQL DBMS is like a digital library that supports various media types and formats, handling massive and unstructured collections efficiently. Then comes object-oriented DBMS. That's like a specialized library for complex collections, where each book is an object with detailed attributes and relationships. Then comes hierarchical DBMS. That is similar to an archive with a tree-like organization, making it easy to navigate through related documents. Finally, a network DBMS. That's like a web of interconnected libraries, supporting many-to-many relationships, making it easier to explore interconnected collections. So with that types of DBMS, now coming to common use cases of DBMS. So database management systems are widely used across various industries to handle massive amounts of data efficiently and securely. So let's look at some of the use cases where DBMS plays a vital role. From banking systems and airline reservation systems to telecommunication networks and financial systems, DBMS ensures data is managed effectively to support critical business operations. So talking about banking systems, it manages customer data, transaction records, and financial statements to ensure accurate and secure banking operations. Now we talk about airline reservation systems. So DBMS handles booking information, flight schedules, and passenger details to streamline the reservation process and improve customer service. Now coming to telecommunication networks, that manages subscriber data, call records, and network performance metrics to ensure reliable and efficient communication services. Now coming to financial systems, that supports trading, risk management, and compliance by managing large volumes of financial data with precision and security. So imagine walking into a bank and being able to access your account details instantly. This is made possible by the DBMS that manages all customer data and transactions seamlessly. When you book a flight, the reservation system quickly retrieves available seats and schedules, thanks to DBMS handling all booking information and flight schedules. In the telecommunication sector, DBMS ensures your call records and subscriber data are managed efficiently, providing you with reliable service. And similarly, in the financial industry, DBMS supports various operations like trading and risk management by securely managing large volumes of data. These are just a few examples of how DBMS support critical operations across different industries. And with that, guys, now we will discuss the future trends in DBMS. So as technology continues to evolve, so do database management systems. So let's explore some of the emerging trends in DBMS that are shaping the future of database management system. These trends include big data and NoSQL databases, distributed databases, cloud databases, and the integration of machine learning. So talking about big data and NoSQL database, that is designed to handle massive volumes of unstructured and semi-structured data that support for various data models like document, key value, column family, and graph. Examples are MongoDB, Cassandra, Hadoop. Now coming to distributed databases. So these databases that run on multiple servers or nodes, providing high availability and scalability. So in this, data is distributed across different locations but appears as a single database to users. Examples are Google Spanner, Apache Cassandra, and Amazon DynamoDB. Now coming to cloud databases. So these databases are hosted and managed on cloud platforms, offering flexibility and scalability that eliminates the need for physical infrastructure and allows for easy scaling and maintenance. Examples are Amazon RDS, Microsoft Azure SQL Database, and Google Cloud Spanner. Now coming to machine learning integration. So incorporating machine learning algorithms into DBMS for advanced data analytics and predictive modeling that helps in automating data management tasks and extracting valuable insights from data. Examples are Google's BigQuery, Amazon Redshift ML, and Oracle Autonomous Database. Ever wondered what those people with fancy charts on their computers are doing? They are probably business analysts. So what's a business analyst? Think of them as the Sherlock Holmes of the business world. They look at lots of information and figure out how to make companies run better. And guess what? It's a pretty cool job right now. Lots of companies are trying to hire these folks. Want to know how much they make? On average, about $85,000 per year. Some of them even make over $120,000. Not bad, right? But here's the thing. To be really good at this job, you need to know some special words. It's like learning the secret code of business. And in today's video, we are going to look at the 10 important words every business analyst should know. And by the time we are done, you will be talking like a pro. So let's start with a little story. Meet John. John works at a company and is always overwhelmed by all the data terms his colleagues use during meetings. So words like KPIs, data warehouse, and analytics were thrown around, and John often felt lost. He knew understanding these terms was crucial for his career growth, so he decided to dive into learning about business intelligence. John started by learning what business intelligence actually means. He discovered that BI involves strategies and technologies that help companies analyze and manage their data. For example, if he worked at Spotify, BI could tell him which songs are getting the most plays, when people listen the most, and even predict the next big hit. This realization made John see how powerful BI could be for making informed business decisions. Alright, so let's dive in and let's understand what business intelligence actually is. Imagine you're running a popular ice cream shop, and business intelligence is like having a super smart helper that tells you everything about your business. Cool, right? So what exactly is business intelligence? It's all the tricks and tools companies use to understand their data better. It helps them make smart choices based on facts, not just guesses. For example, let's say you use a tool like Power BI in your ice cream shop. It might show you which flavors sell the most on hot days, what time your shop is busiest, and which toppings are most popular with kids. This info helps you make smart decisions like stocking up on popular flavors or hiring extra staff for busy times. Business intelligence is super important because it turns boring numbers into useful information that helps businesses grow and succeed. It's like having X-ray vision for your company. Next, let's talk about data visualization. So data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. For example, a bar chart showing the most popular pizza toppings in a delivery app. This is crucial for presenting data in an easy to understand format. Moving on, we have analytics. So analytics involves the systematic computational analysis of data. For example, using analytics to understand which times of day are busiest for a pizza delivery app. This term is important because it helps in making sense of large amounts of data and aids in decision making. Next up is KPI, that is key performance indicator. So a KPI is a measurable value that demonstrates how effectively a company is achieving key business objectives. For example, tracking the number of pizzas sold each month as a KPI to measure business performance. KPIs are essential for measuring performance and progress towards strategic goals. Now let's discuss data warehouse. So a data warehouse is a centralized repository for storing large volumes of structured data from multiple sources. For example, storing customer data from different gym branches in one place for analysis. It is used for reporting and data analysis and is a core component of business intelligence. Data warehouses are important for consolidating data from different sources and making it available for analysis. Next, we have database. So database is an organized collection of data generally stored and accessed electronically from a computer system. For example, a database storing member records for a gym. Databases are foundational for storing and managing data efficiently and are critical for any business intelligence processes. Moving forward, let's introduce data mining. So data mining is the process of discovering patterns and knowledge from large amounts of data. For example, a gym analyzing member attendance to identify the most popular class times. Data mining is important for extracting useful information from large data sets. Next, let's talk about dashboard. So dashboard is a business intelligence tool that allows users to track key metrics and KPIs. For example, a dashboard for a gym showing daily attendance most used equipment, and membership growth. It provides a visual representation of data and helps in monitoring performance at a glance. Dashboards are crucial for real-time data monitoring and decision making. Next up is reporting. Reporting refers to the process of organizing data into informational summaries to monitor how different areas of a business are performing. For example, a monthly financial report summarizing income and expenses for a gym. Reports are essential for tracking progress, identifying trends, and making informed decisions. Finally, let's discuss SQL, that is, Structured Query Language. So, SQL is a standard programming language for managing and manipulating databases. For example, writing an SQL query to retrieve all gym members who joined last month. It is used to query, insert, update, and modify data. SQL is fundamental for anyone working with databases and business intelligence tools. Remember, whether you are running a multi-million dollar corporation or a neighborhood lemonade stand, these BI tools and concepts can help you make smarter decisions and grow your business. They turn raw data into valuable insights, helping you understand your customer better, optimize your operations, and stay ahead of the competition. So with that guys, we have come to the end of this session. I hope this video has helped demystify some key business intelligence terms for you. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more business and tech insights. If you have questions about BI or want to share your opinion, you can comment down in the comment section below.
With today's topic, which is about how to create Power BI dashboard in a few minutes. Yes, you heard me right. You can create a complete Power BI dashboard, or also known as a report, in just a few clicks and a few minutes. Now, in this particular video, we are minimizing the time in creating dashboard, because sometimes data cleaning process, you already know, if you're an expert or if you're a beginner in data analytics, you already know there are steps in data report or a dashboard, right? First, you load the data from a source. It can be cloud, PDF, Excel workbook, CSV, or anything. And after that, you do some data cleaning, right? You split the columns, or you eliminate some blank rows, blank columns, and some irrelevant data which does not fit, or some for more reference on data cleaning, you can also refer to the video, which is linked in the description box below. And so, right, that's the process. So basically, you import the data from the source, clean it, transform it, and then load it, and then create a dashboard, right? So in this particular video, we have the completely cleaned data set, which is really available for creating a report, which will be also linked in the description box below if you want to follow us along. So with that, let's get started, right? So that's how it goes. Now let's have a look at our data. So our data has some row ID, order date, ship date. So basically, you can totally understand this particular data set is about sales report, right? Let's say I'm working with XYZ company, which is based on data analytics, and I get an email from my client that he or she wants to know how exactly the sales are performing, in what exact states or countries, and what exact regions, and what category of products or subcategory of products, and what's the sales quantity, order, profit, right? So let's say you have a one category or subcategory or a product which is giving you high number of sales and profit, right? You want to improve more, you can increase the price. Or let's say you have some product which is not performing so well, right? So you can offer some discounts, let's say like 50% off, so that you can move out the product from your store, right? So some basically, if you analyze the data and you come up to a decision where which product is performing in which region or state or country, and which product is performing in not performing in which region, state or country, right? You can come up with a strategy for sales and improve your revenue. So that's the entire process, right? So with that said, so this is the data we have, and let's quickly jump onto Power BI and get going with creating a report or dashboard within a few minutes, right? So here we are on the Power BI desktop. So here, absolutely, you can see you can import data from Excel, you can import data from SQL Server, you can import data from a blank table, or use some sample data. Apart from that, you can also get data from a different sources as well, right? See, we will be trying to do some automation, right? So regarding the automation, we can also go through another video from Simplilearn, which will help you understand how to automate the process of data transformation, cleaning, and uploading. So you can just give the file location here, the folder. So I'm going with the folder here. So it will give me a new window. You can go to browse, and I think I have my folder in downloads and Excel datasets. Excel. I think I'll be having that named as sales report. Yes, just click OK, and you have the sales report here. You can have a quick preview of the data. So here you have the options: combine, load, transform data, right? You can just directly load, because I've said you that this particular data set is completely clean and is ready for reports, right? So you can just select the data you want and just load, right? I'm doing it this way because let's say we have the data here in a form, in such a form that the data is from last 3 to 4 years, right? So let me select it this way. So in this case as well, it will take the Excel file, and even if you add some more data to it, it will apply the changes to it, right? So let's say we have the data for the last 4 years, 2020, 2019, 2021, 2, and 3. And since 2024 is not completed yet, we are not taking that data. Let's say we enter into 2025, then the new data for 2024 gets updated and loaded onto the same data table. And you don't have to process the data once again, clean it, transform it, load it. No, that's not gonna happen. You can just load the data, you can just drop the data on the Excel spreadsheet, and your dashboard or report will reflect the new changes automatically just by refreshing your dashboard, right? That's the automation you can do. So what exactly automation is? The process where human effort is not involved, and the computer or your any tool does the job for you is called as automation, which reduces a lot of time of yours, and you can use that valuable time to plan on the strategies to improve your revenue, right? That's the overall motto of data analytics. Now that's the preview of the data. I'm just going to directly load it. I'm not going to transform it because it's completely clean and transformed data and ready for reports. So here you go, and you can close. If there are minute errors, you can just close it. And if you want to check your data, you can go to your data here, and you can have the sample data right here, right? If you check the order date, not ship date, sorry, ship date can enter into 2023 as well, right? So here you have 2020 and the other dates, right? So you will have, okay, let's go to the data filter. So you basically have 4 years, not 2024, right? So that's the way. If you just add the 2024 data, it will automatically reflect in the visualization. Now, all that we need is create a dashboard or report which will help us analyze some data, right? So let's get started. Just double click on the report section, and here you'll have icon or wizard which will ask you what exactly you're looking for. Preparing Q&A. So I want region-wise sales, and I want it in a bar graph. There you go. You have the region-wise sales in bar graph. Press on OK, and you have it. And you can place it somewhere in the corner. Then if you want another one, double click, and you want category-wise category sales, and let's take that in pie chart. Category sales pie, and here you have it. Press on agree and accept, and you have it over here. And year-on-year sales in a line graph, sales by date, or sales by date line graph. Here you have it. Accept that, so that you can identify which is the peak performance year or peak performance date for us, which gave us the highest number of sales in a certain region, right? So here we have it. You can place it, you can customize it, right? And now let's go for subcategory. Double click and subcategory. I think we have a hyphen or space there. Sales. The type of chart you want, you can go with the donut one. Select that and agree. So you have a subcategory wise sale, and now let's go with region wise. I mean the country wise, right? So let's go to the data again here. So here we have segment city, state, country. Okay, let's go with country now, right? Country sales map chart. So whenever you have a region or state or a country involved, go with map charts. It's the best way to represent, right? So we have considered European nations over here. So for that reason, we have the European states here. And now we can let's go with the data once again and have a look what else we can do. And shipment mode, right? So you have the shipment mode as well. So you can identify what type of shipment mode customers are majorly preferring. Shipment mode, bar graph, agree. So basically, I think we have 3 types of shipment mode. Let's check the column name of shipment mode properly. Ship mode. It's not shipment mode, it's ship mode, right? So let's type again. Ship mode, bar graph. Okay, shipment mode sales, bar graph. There you go. So agree, accept it. So you have standard shipment is the most preferred one. Now we have this, so let's add some KPIs here. So KPI of sales, you will adjust that, agree, there you go. And let's add a KPI for profit, and you have it, agree. KPI for revenue, double click. Let's check if we have a column called revenue. Quantity, discount, profit, right? So let's go with quantity and discount. So revenue is not added, so it's okay. So you can identify which product or subcategory is highly selling in number of quantities. So you'll have the sum of profit, sum of sales, sum of quantity, and what else we left? The last one, discount and rate. Sales, discount, profit. So let's identify if we have offered any. Okay. So let's add a KPI of rate as well. If we are completely focusing on a single product, a single category, we must be having a KPI for rate as well. Double click somewhere, KPI on rate. There you go. Accept it. And you have the completely formatted dashboard or sales report ready for a meeting. Let's close all these so that we have a better visualization, and you can just go to the slideshare mode or fit to the page mode where you can have it. That's good. So this is how you create a completely fully functional sales report or sales dashboard just within a few clicks and just within a few minutes. Let's say I want the sales report only for central region. Click that and it's completely interactive. And let's say we don't want that, click outside and you will have everything back to the normal, right? And let's say I wanted to focus on a particular category, technology category alone. I have the sales happening and the subcategory of sales and what are the products over here, right? You'll have that, and which is the country happening to ship the most of them, and what's the shipment more preferred by them, and highest performing date or year. So here you can see 2022, June was the highest performance for sales, and the lowest one is somewhere here in March 2020 or something, right? So that's how you can create a fully interactive dashboard or report based on sales data in a few minutes and in a few clicks. And that brings us to the end of this tutorial on the topic how to create a completely functional sales report or sales dashboard in a few clicks and in a few minutes.
Who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real-world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualization tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability. We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one's mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and NumPy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. PowerBI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or PowerBI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum. Such is the demand for data analyst. Now that we have covered every important skill, it's time for you to start working on it.
So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many cells per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up and the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future. Gear up for how many employees we need, how much money we're going to make. And prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change.
Hello everyone, we welcome you all to this video by Simplilearn. In today's session, we will learn a really interesting topic, that is the top 10 skills to become a data analyst in 2022. In today's digital world, data is being generated by companies and individuals every second, so the role of a data analyst holds supreme importance. So if you're looking for a career in data analytics, this video will help you learn what a data analyst does and the various skills you need to possess to become a data analyst in 2022. Before we get started, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. Let's look at the agenda for this video. First, we will understand who a data analyst is. Then we will understand the top 10 data analyst skills for 2022. Moving on, we will look at the salary of a data analyst. And finally, we will look at the companies hiring data analysts. So now let's understand who is a data analyst. A data analyst is a professional who collects business data from various sources, interprets it, and uses various statistical tools and techniques to extract insights and useful information from it. They acquire data from primary or secondary data sources and maintain databases. They also recognize and understand the organization's goal and collaborate with different team members such as programmers, business analysts, and data scientists to build an effective solution to a business problem. Now, with this basic understanding of who a data analyst is, let's learn the top 10 data analyst skills for 2022. At number 1, we have Structured Query Language or SQL. SQL is a top skill that every data analyst should have. Data analysts use SQL commands and functions to store, process, analyze, and manipulate structured data using relational and NoSQL databases. They also build data models and write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. Some of the popular databases a data analyst should be familiar with are Microsoft SQL Server, MySQL, PostgreSQL, and IBM DB2. The second important skill for a data analyst is Microsoft Excel. Microsoft Excel is one of the most popular and oldest spreadsheet applications for creating reports, performing calculations, and analyzing data. Data analysts need to know how to handle tabular data in Excel. So, they should be aware of features like sorting, filtering, conditional formatting, pivot tables, what-if analysis, and functions such as sum-ifs and count-ifs. The third crucial data analyst skill for 2022 is data cleaning and wrangling. Usually, the data collected by analysts from various heterogeneous sources is often messy and contains a lot of missing values. So, it is always crucial to clean the data and remove noise, missing, or erroneous elements. It is also important to format data using tools and methods before using it for analysis. They are responsible for data mining as well. The data mined from various sources are organized in order to obtain new information from it. Some of the tools you need to know for data cleaning and wrangling are Excel Power Query and OpenRefine. The fourth skill on our list is mathematics and statistics. Data analysts often work on data for higher dimensions that are greater than 3. In order to interpret such data, they need to be good at linear algebra and calculus. They also build predictive models and statistical models such as linear regression, logistic regression, naive Bayes, and k-means clustering. In order to understand the working of these algorithms, they must have knowledge about statistics and probability. Coming to the fifth important skill for a data analyst in 2022, we have programming. Data analysts need to master at least one programming language, preferably Python or R. In order to work with complex business problems, analysts need to write scripts and user-defined functions to automate tedious tasks. Python and R language provide a collection of different libraries and packages such as NumPy, Pandas, dplyr, matplotlib, ggplot, which data analysts can use to discover trends and patterns from complex data sets. After this, we have data visualization as our sixth skill. Another data analyst job role is to visualize large volumes of data and prepare summary reports and dashboards for the leadership team and clients so that they can make timely business decisions. To do this, data analysts use various data visualization tools such as PowerBI, Tableau, and ClickView. Using these tools, data analysts can integrate various data sets, apply join conditions, sort and filter data, as well create different visualizations using charts and graphs. The seventh skill for a data analyst is industry knowledge. Data analysts should have good knowledge and understanding of the industry or domain they are working in. For example, if you're working in a healthcare domain, you need to know how healthcare analytics can be applied to improve patient care. You should have knowledge about the challenges faced in healthcare and how you can leverage data and analytics to solve the issues. Only if you have strong industry knowledge can you try to improve the business. The eighth skill that is important for a data analyst in 2022 is problem solving. A business deals with several problems on a daily basis. Data analysts should be ready to face those challenges. Data analysts are expected to use their problem-solving skills, work with the team, troubleshoot what went wrong, and provide an effective solution via data analysis. A data analyst with good problem-solving skills can help a business identify current and potential issues and determine a viable solution based on the data it collects. The ninth skill on our list is analytical thinking. Data analysts need analytical thinking ability to break down a complex problem into simple components and resolve these components one by one. It is a must-have skill for data analysts. Analytical thinking includes deciding the parameters that need to be considered for defining data sets, analyzing them from different perspectives, and determining variable dependencies. Coming to the 10th skill among the top 10 skills for a data analyst in 2022, we have communication. Data analysts don't just interact with computers and programs, they also interact with team members, stakeholders, and data suppliers. So, good communication skills are essential. Data analysts also present their findings in front of an audience who might not be familiar with the analytical methods and processes, so they need to clearly translate their findings and insights into non-technical terms. So, those were the top 10 skills a data analyst needs to possess in 2022. Do you think we missed out on any skills? Then please put your answers in the comment section below. Now, let's look at the salary of a data analyst. According to Glassdoor, the average annual salary for a data analyst in the United States is $69,517, while in India, you can earn nearly 7 lakh rupees per annum. Finally, let's look at the top companies that are hiring data analysts in 2022. Here we have the consultancy and Big Four giant Deloitte and the pharmaceutical company Cerner Corporation. Then we have the tech giant IBM, retail company Walmart, and the e-commerce leader Amazon. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with The Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner on KNIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. KNIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. KNIME Server automates workflow execution and supports team-based collaboration. KNIME integrates various other open-source projects such as machine learning algorithms from Becker, H2O, Keras, Spark, and our project. KNIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for KNIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have KNIME. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to zero. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is ClickView. ClickView software is a product of Qlik for business intelligence and data visualization. ClickView is a business discovery platform that provides self-service BI for all business users and organizations. With ClickView, you can analyze data and use your data discoveries to support decision-making. ClickView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of ClickView looks like. Now talking about its features. ClickView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the ClickView software helps the user by suggesting possible interpretations. ClickView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have PowerBI. PowerBI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. PowerBI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. PowerBI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called PowerBI Desktop and online software as a service called PowerBI Service, mobile PowerBI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the PowerBI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of PowerBI, it has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. PowerBI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now, coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple data sets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools.
R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows, and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode, and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, R language is significantly slower. R packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial, and Python has some incredible visualization tools. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community-related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. A recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic, which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language.
So the number of reasons. One, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark into the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves and get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm is really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our notebook. These are identical. Jupyter Lab is an upgrade to the notebooks with multiple tabs. That's all it is. And we'll be using the notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy. The least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1. And it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array 1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running. It's still in the kernel. So it still has the numpy imported as np, and it still has our variable arr1 for array 1 equal to np array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want, what is the type of array 1? And let's go ahead and run that. And it says class numpy nd array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a 1-dimensional array. That's all that is. And with the numpy array, we can easily access, we'll stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array 1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2. And we have 0, 1, 2. 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a numpy array. And in the numpy array, we need our first dimension. We'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this. We'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array 2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. 2-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3, comma, nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2, comma, 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1, comma, 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1, comma, 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as go back up here. Whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0, 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do np lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all of these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integers 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random.random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go. You have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. And we put our array in there. And this will of course print it out because it returns it as a variable. And you can see here, here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that, and you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which should generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's the cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1. and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645 and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go, you can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is the column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows. And if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go. There's our slice. Run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2, and we run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning because that's how it registers as 0, just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1, and when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice, and we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind when you're messing with adding lines and deleting lines, you have to be really careful because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create two arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge two arrays that have, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that your whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1 or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up in my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. the process is identical in the background. This is like a legacy setup, your VStack and your HStack. Most people just use concatenate and then put the axes in there because it's has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing NP unique. But we're going to add a little bit more into there, and it's just part of the arguments in this, and we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have NP intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D, and then set XOR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this pandas and pyplot. So pandas pyplot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with pandas, so a lot of times you just import them by default. Seaborn sits on top of the matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have matplot library as pyplot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, you'll have a pop-up when it goes to display the matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd.read_CSV. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytics, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top 2. We can run that. There's our top 2 BMWs. Another thing we can do is instead of head, we can do tail. And look at the last 3 values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the pandas automatically truncates it and just does head plus tail, so you can see the 2. So we really don't want to look at the whole thing. We'll go ahead and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in .values, it converts it from a pandas list to a numpy array. And that's true of any of these. So then you end up in a numpy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a numpy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again, we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or our SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn, it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process, but right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. You know, we were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark, across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, Pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because Pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a Pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there? So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others, depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we've removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function.sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the two thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. We'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet. It's going against, what was it? It's figuration, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that. So that wraps up our demo part for today.
Let's learn about data manipulation in R. And here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function. And this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable and then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use AND or we can use OR operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights. And in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA and you look at the value. So in this way I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights, overall delay. The computation remains same, but at this time, if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on 2 variables or 2 columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. Let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights, average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this. And that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all 3 of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower, and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped. based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column. And then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this. And let's look at the value of this one, where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping. But earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it, where I am saying within this particular data set, I would want to get the sum, or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set, or you're looking at the data which was already grouped, and then you can look at the values. Now here, what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column. You can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on DF. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in our random sample. So that's why when you did a view, it shows your 5 values, and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use DF, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say B, which is going to get a sample out of A, and I just want 5 random values. So let's look at that. So we have B, which is going to get a set of 5 values from A. Now I will create a result variable which will arrange B, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default ascending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns. And you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data. Let's look at this one, and if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name. I can say Control Shift M, which is for piping. And then basically what you can do is you can do a select and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder, and here what I'm doing is I'm using a select where I can look at the new data frame. So let's do this, and I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4 or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it.
Imagine you are trying to figure out what most people in your neighborhood love to eat for dessert. You could ask everyone, right? But how do you make sense of all of these answers? That's where statistics comes in. It's like your personal data detective, helping you gather, organize, and analyze all the information to spot patterns and trends. With statistics, you can easily discover if most people love ice cream or if brownies are the hidden favorite. All about turning numbers and facts into useful insights, helping you make smarter decisions and understand the bigger picture. Hello guys, welcome back to Simplilearn's YouTube channel. And today I will walk you through the basic understanding of descriptive statistics, inferential statistics, frequency statistics, and kurtosis statistics, and more. Then I will take you through the differences among the various types. By the end of the video, you will know all you want to know about statistics and its types. Without any further delay, let's get into the video. First things first, let us understand what statistics actually is. Statistics is a branch of mathematics that help us collect, organize, and analyze data, understand patterns, trends, and make decisions. It's like having a big group of information and breaking it down to learn something useful. For example, if we survey 100 people about their favorite fruit, statistics help us figure out what most people like, what fruit is least liked, and how confident we are about these results here. After we have a basic idea of statistics, let us get into the various types of statistics. The first one is descriptive statistics. Descriptive statistics is a branch of statistics that focuses on summarizing and describing the main features of a dataset. This is further divided into measures of central tendency, measures of spread, and data distribution. Let's start with measures of central tendency, and this is further divided into three types. The first one is mean, the average of all data points. The second one is median, the middle value when data is arranged in order. The third one is mode, the most frequently occurring value. Let's break down the measures of central tendency, mean, median, and mode with an example. Imagine you have the following scores from a maths test taken by 7 students: 72, 85, 91, 89, 85, 76, and 90. Now you want to calculate the mean. Now to calculate the mean, you have to add up all the scores and divide by the number of students. Therefore, the mean is 84. It means the average scores of the students is 84. Now moving on to find the median. To find the median, we need to take the same example and we have to arrange the scores in ascending order. The median is the middle value, so in this case, the middle value is 85, since it is the fourth number in a list of 7. So, half of the students scored above 85 and half scored below 85. Now moving on, the next is to calculate the mode. The mode is a score that appears most often. So we take the same example and we see that 85 occurs twice more than any other score. So the most common score in the test is 85. Now moving on to the next, that is the measures of spread. Unlike central tendency, which tells you whether the data is centered, spread tells you how scattered the data is. It has three components: range, variance, and standard deviation. Range, it is the difference between the highest and the lowest values in the set. And variance, it measures how much each score deviates from the mean. And standard deviation, it is the square root of variance. Let's use an example to understand measures of spread, range, variance, and standard deviation, which help us understand how spread out or dispersed the data is. Consider the test scores of 5 students. Now, we want to find the range. Therefore, the range is the difference between the highest and the lowest values in the dataset. That is, 85 minus 65 is equal to 20. The scores span a range of 20 points from 65 to 85. Now moving on, we want to find the variance for the same example. The variance measures how much each score deviates from the mean on average squared. First, we calculate the mean. So to calculate the mean, we take the total of the scores divided by the total number of scores, and that is equal to 75. Next, we find the square differences from the mean for each score. And here it is. 65 minus 75 whole square is equal to minus 10 whole square, and that is equal to 100. And in this way, we perform the same for each score. Now the sum of these square differences divided by the number of data points is the variance. And that is taking the total of the squared differences divided by 5, that is equal to 50. The variance is 50, meaning that on average the square differences from the mean are 50. Now moving on to find the standard deviation. The standard deviation is the square root of the variance. It tells us how spread out the data is in the same units as the original data. The standard deviation is the root over of 50, that is approximately equal to 7.07. Now moving on, the third major subdivision is data distribution. Let us use an example to explain data distribution, which tells us how data points are spread or organized across a range of values. Imagine you have the following test scores for 20 students. One way to understand data distribution is by creating a histogram. The histogram groups the scores into ranges or beans and shows how many scores fall into each range. For this dataset, we could create bins like 50 to 60, there are 3 students. 61 to 70, there are 7 students. And 71 to 80, we have 5 students. And in this way, 81 to 90, we have 3 students. And 91 to 100, we have 2 students. Now moving on to the normal distribution, the second one under the data distribution. In some cases, data follows a normal distribution which forms a bell-shaped curve. And this means most data points are around the mean with fewer data points as you move away from the mean in either direction. And normal distribution curve, it means most data points are around the mean with fewer data points as you move away from the mean in either direction. In a normal distribution, the mean, median, and mode are the same. Data is symmetrically spread around the center. Now moving on, in our example, the scores are somewhat concentrated around 70 to 80, but the distribution is not perfectly normal because there are more students scoring higher, that is the right skew. Therefore, skewed distribution, if a data set is not symmetrical, we have skewed distribution. And that is further divided into two: the right skew, that is the positive skew, and the left skew, that is the negative skew. In right skew, more data points are on the lower side with fewer higher values. And in the left skew, more data points are on the higher side with fewer low values. Moving on, in our test score example, we have a slightly right skew distribution because there are more students with lower scores, that is to 55 to 70, compared to higher scores, that is 90 to 100. And this is known as right skewed distribution. Now, moving on to the second type of statistics, that is inferential statistics. It uses sample data to make predictions and generalizations about a larger population, allowing researchers to draw conclusions beyond the immediate dataset. Inferential statistics comprises several techniques for drawing conclusions. Here are some common types: hypothesis testing, second one is confidence intervals, and the third one is regression analysis. Now moving on to hypothesis testing. Hypothesis testing is a statistical method used to determine whether there is enough evidence in a sample of data to support a specific claim about a population. Let's work through the process of testing whether a new teaching method improves student test scores, breaking it down step by step with some explanations to make it easier to follow. Step number 1 is hypothesis. We always start by stating what we want to test. In this case, we want to see if the new teaching method helps students score better compared to the traditional one. To do this, we set up two hypotheses. H0, that is the null hypothesis, and that is the average test score with the new method is equal to 75. This means that the new method has no impact and there is no improvement in the test scores. H1, that is the alternative hypothesis. The average test score with the new method is greater than 75. This suggests that the new method does improve test scores. In simple terms, we are trying to figure out if the new method makes any difference compared to what we normally expect, which is a score of 75. Now moving on to the next step, that is significance level. Next, we need to decide how confident we want to be in our conclusion. The significance level helps us measure this. It tells us the probability of mistakenly rejecting the null hypothesis when it's actually true. Type 1 error. A common choice for this significance level is 0.05 or 5%. This means we are willing to accept a 5% chance of making a mistake by rejecting the null hypothesis when it is true. So we said alpha is equal to 0.05. Step 3. Collect data. Now we need some actual data to test. Let's say we taught 30 students using the new method and their average test score came out to be 78. This is our sample data and we will compare it to the population mean, which is 75, the traditional method score. Now moving on to the next step, that is perform statistical test, the t-test. With the data in hand, we need to perform a statistical test. For this test, we will use a t-test which will help us compare the sample mean 78 to the population mean 75. The t-test checks if the difference between the two means is significant or if it could just be due to random chance. Moving on to the next step, that is the p-value. The p-value from the t-test is the number that tells us the probability of getting the sample data if the null hypothesis is true. Let's say the t-test gives us a p-value of 0.03. This means there is 3% chance of seeing this level of improvement if the new method doesn't actually improve scores. Now moving on to the last step, that is decision. Now we compare the p-value to our significant level alpha. If the p-value is smaller than 0.05, it means the results are statistically significant and we can reject the null hypothesis. In our case, the p-value is 0.03, which is less than 0.05. So we reject the null hypothesis. Now moving on to the second part, that is confidence interval. A confidence interval is a range that tells us how sure we are about an estimate from sample data. It gives a range of values whether the true member likely false. For example, suppose you survey 100 men in a city to estimate the average height. The average height from your sample is 175 centimeter and the standard deviation is 10 centimeter. You want to calculate 95% confidence interval to estimate the true average height of all men in the city. Now let's move on to the steps. Sample mean. The sample average is 175 centimeter. The standard error is calculated as 10 by root over of 100, that is equal to 1. Now, the confidence interval formula for a 95% confidence level use the critical value 1.96. The confidence interval is 175 plus minus 1.96 into 1. That is equal to 175 plus minus 1.96. The result, the 95% confidence interval is 173.04, 176.96. You can be 95% confident that the true average height of all men in the city is 173.04 centimeter and 176.96 centimeter. Now moving on to the third one, that is regression analysis. Regression analysis is a way to understand how one thing affects another. For example, if you own a shop and want to know if spending more on advertising increases your sales, you can use regression analysis. In this case, Advertising spending is a thing you control, that is the independent variable, and sales is what you want to predict. By analyzing the past data, regression helps finding a pattern or relationship. For example, you might discover that for every $100 you spend on advertising, your sales increase by $200. This means you are positive relationship between advertising and sales. Now, if you plan to spend $500 on advertising, you can predict an increase in the sales by applying that relationship. Regression analysis gives you a formula or model to make such predictions based on the pattern you identified. In short, regression helps you logically predict how changes in one factor affect another. Next, I will be talking about is frequency statistics. In statistics, frequency refers to how often something occurs in a dataset. It simply counts how many times each value or event appears. Frequency is useful for understanding the distribution or pattern of data. Let's say you surveyed 10 people about their favorite food and the results were 4 people chose apples, 3 people chose bananas, 2 people chose oranges, and 1 person chose grapes. Here's how frequency works. Apples have a frequency of 4 as 4% chose it. Bananas have a frequency of 3, oranges have a frequency of 2, and grape has a frequency of 1. In this simple example, frequency helps you see that apples were the most popular fruit choice, while grapes were the least popular. Last but not the least, let's talk about kurtosis statistics. Kurtosis is a statistical term that describes the shape of the distribution of data, especially how the data is concentrated in the tables. It helps us understand if the data has more or fewer extreme values compared to a normal distribution. It is further divided into high kurtosis and low kurtosis. High kurtosis has more extreme values, and in low kurtosis, the data has fewer extreme values. In short, high kurtosis means more extreme heights, while low kurtosis means more consistent, evenly spread heights. By now, you be curious to know about the differences among all the types of statistics. So here we go. Differentiating them on the basis of purpose. Descriptive statistics summarizes the main features of a dataset, for example, mean, median, and standard deviation. Inferential statistics makes predictions or generalizations about a population based on sample data. Frequency statistics counts when specific values or events occur in the dataset. Kurtosis describes the shape of the distribution, focusing on the tails and extreme values, differentiating them on the basis of data focus. Descriptive statistics deals with the entire dataset at hand. Inferential statistics uses a sample to infer conclusions about a larger population. Statistics focuses on the frequency of individual values or categories. Kurtosis focuses on whether the data has many or few extreme values. Now differentiating them on the basis of common metrics. In descriptive statistics is the mean, median, mode, and standard deviation and range. In inferential statistics, it is hypothesis testing, confidential intervals, regression analysis. In statistics, it is frequency counts, frequency tables, histograms, bars, and charts. In kurtosis value, high kurtosis is equal to more extreme values and low kurtosis is equal to fewer extremes. Now, differentiating on the basis of complexity. Complexity in descriptive statistics is simple and straightforward, summarizes the observed data, and in inferential statistics it is more complex, and in statistics it is simple counting and displaying of occurrences. Kurtosis requires statistical analysis to determine the distribution's tailedness. Now finally, differentiating them on the basis of visualization. Descriptive statistics, it is the box plots, pie charts, and summary tables. Inferential statistics, it is confidence intervals, regression lines, p-values, and more. And in statistics, it is bar charts, histograms, frequency tables. And kurtosis, it is histograms, distribution plots to visualize outliers. So here is a question for you guys. I hope everyone will comment your answers in the chat section, and let's see how many of you really understood the topic. So the question is, which of the following is not a measure of central tendency? And the options are mean, median, mode, and standard deviation. Participate in the quiz, and I hope to see your answers in the comment section. We will reply to whoever provides the correct answer, and the wrong answers will be corrected for sure. I will provide you 1 minute to write your answers in the comment section.
Imagine having the power to transform chaos into clarity in today's data-driven world. That's exactly what ETL, which is extract, transform, load, let you do. Picture this data pouring in from all the direction. Databases, apps, cloud systems, and just with few smart moves, you can transform it into clean, organized insights ready to fuel big businesses' decisions. Learning ETL is like becoming a data wizard, pulling together scattered pieces and making them work like magic. And here's the exciting part. ETL is an in-demand skill that can open doors to endless opportunities in some of the fastest growing fields out there. Today, I'll walk you through what ETL is and why is it such a game changer in today's data-driven world. I'll break down a real-world scenario to show you how things work with and without ETL, explore popular ETL tools, and wrap up with the common challenges businesses face when implementing ETL. So buckle up, by the end you will have a solid grasp of ETL and why it matters a lot. Without causing any further delay, let's get into the video. First things first, let us understand what ETL is. ETL basically stands for extract, transform, and load. It is a process which is used in data management to help businesses collect data from various sources, clean and organize it, and then store it in a central location like a database or data warehouse. First, data is extracted from different systems or files, then it is transformed by cleaning, filtering, and formatting it to ensure it's consistent and ready for use. Finally, the data is loaded into a system where it can be easily accessed for analysis or reporting. ETL is essential for companies to turn raw data into useful insights that support better decision making. So after we have basic ideas on ETL, let us now understand why is it so important to understand ETL in today's world. So understanding ETL is necessary in today's world because businesses rely more than ever on data to make informed decisions, improve operations, and stay competitive. With data coming from so many different sources, websites, apps, social media, and many more, ETL provides a way to gather, clean, and organize all this information efficiently. Without ETL, data would remain messy, inconsistent, and difficult to use, making it harder for businesses to extract valuable insights. In a data-driven world where quick and accurate decisions are critical, knowing how ETL works helps companies unlock the full potential of their data for growth, innovation, and success. To make sure you understand better about ETL, let us understand it with the help of a real-world example. Let's imagine you're running an online store that sells clothes. You have data coming from multiple sources: sales data from your website, customer reviews from social media, and inventory details from your warehouse system. Now you want to analyze this data to figure out what products are selling the most, which customers are returning, and what items need restocking. Here's what happens with and without ETL. With the help of ETL, you collect and extract all the sales data from your website, customer feedback from social media, and inventory information from the warehouse system. The data is cleaned and organized, duplicate entries are removed, different formats are standardized, and any missing or incorrect data is fixed. You also combine all this data into a single format that's easy to work with. The cleaned, ready-to-use data is loaded into a central system like a data warehouse. Now you can analyze everything in one place. Whether you want to know which products are trending, who your most loyal customers are, or what inventory needs to be restocked, you can quickly generate reports and gain insights in real time. Thanks to ETL, you can now have a clear, organized view of your entire business. You can make informed decisions, spot trends, and act fast. Now imagine the same scenario but without ETL. Your sales data is in one system, customer reviews are in another, and inventory details are stored separately. The data is messy, some formats don't match, and there is duplicate entries. Combining all this data manually is time-consuming and error-prone. Every time you need a report or insight, you have to spend hours or even days pulling the data from different sources, cleaning it up and organizing it by yourself. By the time you figure which products are selling the most, the trend might already be over. Without ETL, you're just stuck doing manual work, and important insights are delayed or missed. Decision making becomes slower, and you lose out on opportunities to optimize your business. In short, ETL saves times, reduces errors, and gives you the power to make faster, smarter decisions, some things that's crucial for any businesses in today's fast-paced world. By now, you're probably wondering which ETL tools are trending and what companies are using to manage their massive data workloads. Well, the wait is over. ETL tool can be grouped into two main types. First, we have traditional ETL tools, and second, we have cloud-based ETL tools. Each serves a unique purpose in handling and transforming data, depending on the needs of their business. Let's dive into what makes each business stand out. Let's talk about the first, old traditional ETL tools. These tools have been around for a while and are widely used in on-premise systems. They are trusted by enterprises for handling large-scale complex data transformation and integration tasks. Some of the common tools used are Informatica Power Center, which is a strong ETL tool for big companies known for handling large data efficiently. Then we have Microsoft SSIS, a popular ETL tool that works well with Microsoft SQL Server for data tasks. Then we have Talon, which is an easy-to-use open-source ETL tool, which is great for cloud and big data projects. Next, we have Pentaho, with a simple ETL tool with a drag-and-drop interface for transforming data. IBM InfoSphere Data Stage is a powerful tool for integrating large data systems into big organizations. Talking about Oracle Data Integrator, which is fast, reliable ETL tool made for working with Oracle databases. Now that we have discussed the old traditional ETL tools, let's now move on to the cloud-based ETL tools. Unlike traditional tools, they are designed for cloud-based environments, offering scalability, flexibility, and integration with cloud data warehouses. They are perfect for businesses transitioning to or already operating in the cloud. Some of the common tools used are AWS Glue, which is a serverless ETL tool by Amazon that makes it easy to prepare and load data for analysis. Then we have Google Cloud Data Flow, which is a real-time ETL tool for processing large data sets on Google Cloud. Fivetran is a simple automated ETL tool that quickly sets up data pipelines with minimal effort. Next, we have Matillion, which is a cloud-native ETL tool that integrates easily with platforms like AWS, Azure, and Google Cloud. Stitch is a straightforward ETL tool that helps move data to your data warehouse quickly. Hevodata is a no-code ETL tool which is designed for automating data integration across cloud platforms. Let us now see some common challenges businesses face while implementing ETL processes. At first, we have data quality. It's hard to make sure that the data collected from different sources is clean, accurate, and consistent. Bad data can lead to wrong decisions. Then we have scalability. As businesses grow and collect more data, it becomes tough to manage larger amounts of data without slowing things down. Real-time processing. Many ETL systems work with batches of data, but today businesses often need data processed instantly, which makes things more complicated. The next challenge is integration with different systems. Getting data from many different platforms like databases, apps, or files and making it work together can cause compatibility issues. Error handling. While something goes wrong in the ETL process, like a failed data load, it can be tricky to detect and fix those errors quickly. Then we have data security. Keeping sensitive information safe during the ETL process and following legal requirements like GDPR can be challenging, especially when using cloud services. ETL can throw a few curveballs your way, but don't let that freak you out. Think of those challenges as stepping stones to turn your raw data into absolute gold. Once you have nailed down a smooth ETL process, the payoff is incredible. Faster decisions, sharper insights, and a major data-driven advantage over your competitors. And yes, it takes a bit of effort, but once you have conquered the ETL game, your data will become one of the most powerful business's assets.
Hey everyone, welcome to Simplilearn's YouTube channel. Today we will learn about data transformation in PowerBI. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. So what exactly you mean by data transformation in PowerBI? So data transformation can be a little similar to data cleaning. So before any kind of data analytics, you might be receiving raw data from a website source, a SQL database, or an Excel file, or multiple sources, right? once after you receive the data, whether it is batch mode data or streaming data, you are supposed to clean it, right? You might have to clean up the discrepancies like the blank rows or the blank cells or any irregularities in data, such as wrong data type, right? Such discrepancies from the data should be eliminated in the first stage of data analytics. So that's exactly where data cleaning and data transformation comes into the picture. So you have various tools for data cleaning and data transformation like Excel, SQL, but if you are a Power BI user, then good news for you. Power Query in Power BI can assist you in terms of data transformations. So in this tutorial, we will be discussing the most important day-to-day data transformations which a data analyst takes care of in the process of data analysis is what we are going to discuss today. So let's quickly switch to Power BI. But before that, let's have an overview of what kind of data we are exactly dealing with today. So we are dealing with Superstore dataset, and that's in Excel format. So this is our Superstore dataset, and we have 4 tabs here. The first one is Orders tab, where we have Customer ID, Order ID, Date, Ship mode, and Customer name. And in the second tab, we have Stores dataset, which has the details about the customer, from where he or she is, the state, city, postal code, and which category or subcategory did they purchase, and order, sales, discount, profit, everything, right? And here we have some information about any of the orders which were returned and some people over here. So these are the 4 tabs that we are dealing with today. Now that we have an overview on the data that we're dealing with, let's quickly now switch to Power BI. So now we are on the Power BI window. You can just discuss changes. There you go. Let's quickly import the data from our downloads. This is the data set that we want to deal with today. Now, it might take a little while to connect to that particular data set and load the data onto Power BI. Just a couple of minutes, since the data set is a little too heavy. It's about 10,000 rows. So let's wait. Shouldn't take long. There you go. The data got successfully loaded. So you have the option of loading what kind of data you want. You have 4 tabs as we just discussed. You can load the Orders tab and you can load the Stores tab. And in case if you want the Returns tab, you can also load that. And if you want all of those, just load all of those, right? Now, I just want the 2 tabs, Orders and Stores. Now here I can just directly load to get started working on this. But in case I don't want any kind of discrepancies, in case if I have a doubt that this data might not be cleaned, I shall go with data transformation. So ideally you should go with data transformation. Check your data first before any kind of analytical processes. So let's go with that. Transform data. And shortly we should be having the Power Query window open on our desktop screens. So there you go. You can see the complete dataset has been successfully uploaded, both the Stores and Orders datasets. Now let's quickly check the data from our dataset. So here you can see we have orders date, right? But I can see 42682 and 42533. This is not in the form of date, correct? So this is the simple step that we discussed, changing the wrong data type. So you can just click on the lower arrow button over here, and or you can right click, and here you have an option to change the type, correct? So it is considering it as a whole number, which is wrong. So you can change it to date. Replace current. So now we are trying to change the order date from a data type of whole number to date data type. So there is some error. If you click on error, or if you just navigate onto it, Power BI should be able to show you what error was it. And just in case if it's not working, okay, we are unable to parse the value provided, so you can just remove that and try it in a different way. Change type to date and time zone. Date. I think this should be helpful. Or if it's not working here, let's quickly check what could be the error. Date time. And now let's try to refresh the data. It is taking a little while. We also have another information that to deal with. We have the first row as row headers. So we should be declaring Power BI that we also have a row header over here. It's taking a little while to refresh. Meanwhile, let's quickly check into the stores data, and here we have customer name. So let's try to apply second type of data transformation, which will be like, let's say, split column. We have the complete name of the customer. Let's try to split it into first name and second name. So by delimiter, and we can give multiple options over here. Leftmost delimiter, let's say a person has three parts of his name: first name, middle name, and second name, or the last name. So, but we just wanted to split into first and second name, so we would go with the first leftmost delimiter and split the data set. Press OK, and it should help us to split the data first name and second name, and we can also name the columns separately as first name and second name instead of customer name. It's taking a little while than the ideal time, but it's completely alright, since considering the 10,000 rows of stores data and 10,000 rows of orders data, it is alright, not a problem. Now let's try to take a look at the orders data set if it has successfully changed it. No, it is still showing us an error. I don't know what's wrong here. It's maybe incomplete. Let's quickly refresh all instead of preview and check if it can help us. So there you go. After refreshing, the first order date is changed to date data type. So what we missed is when you change the type, you're supposed to add a step. So what exactly I mean by that? Now we are trying to change the second one as well. So just wait for a while and it will give us a choice if we want to add a new step or not. That's when we select the option yes, please add a new step. So what do I mean by steps? So applied steps, you can see something over here, right? So every alteration, every change, or every modification that you're doing, every transformation you're including onto your data will be recorded as a macro. So that can be implemented if you are loading a similar data set for the next batch. Let's say this is 2022 data, and if you're trying to analyze the 2023 data, and every column is similar, and you can just follow these applied steps and the same implementation will be automated. You don't have to spend time in doing the same process once again. There you go. So this time it has recorded this step and it automatically has taken a new step over here. Change type step 1, change type step 2. If you don't want the step to be added, you can just select the red X mark over here. It will remove it. And similarly, when you go back to the stores data set, here you have the first name and second name split successfully. And now let's say you want to have unique customer data, right? In that scenario, you can just even remove duplicates from this particular column. Just remove duplicates and you'll just have unique data. It's possible that one customer might have come here to buy the same product, buy the same product on different dates, or one customer might have done a repeated purchase. So it's possible, but again, if you just wanted to know if there is a way to eliminate duplicate entries, then you can do that. So for now, let's not delete the customer IDs here, because one customer might have visited the same store for multiple times and might have purchased a different product, or might have made the same order with multiple products, right? So there is a possibility for that. Let's not disturb the dataset. So I just wanted you to know if there is a way to eliminate the duplicates from the dataset. Yes, it is. Now let's also check another possibility of data transformation. So let's say you wanted to add a new column and identify or include some mathematical operations. For now, let's say I have sales, quantity, discount, and profit, but I don't know what's the rate, right? So here the sale is for $261 and quantity is 2, but I don't know what's the rate of one product. So I can include that. You can just select the last column, or where you want a new column, just go to the add new column here, and here you can just choose the custom column. Should be somewhere over here. Yeah, this is the custom column. And now if you click on the custom column, you can rename the custom column to rate of product, and here you can choose the mathematical operations to be applied on the columns. So sales column, insert or double click, divided by quantity. Okay, now it should give you the rate of each product, individual product. It is taking some sizable time. It shouldn't take so long. So there you go, you have the rate of product. And now let's say you want to combine multiple data sets. For example, here I have stores data set, but my stores data set doesn't have any data related to orders, and orders does not have any data related to customers. Now I want to combine these two. Is there a way? Yes, you can do that. Now let's get back to stores, and here go to home option, and here you have something called merge queries. So now the stores dataset has been selected in the first dataset. Here, just select the drop down and select the second data type, which is orders. So here you can see stores with the current one, which is in the first place. Now select based on which primary key you want to combine both. So I want to go with customer ID because both of my datasets do have customer IDs. So I'll go with customer ID, and both datasets will be combined. At the end, at the last column, Power BI will show me a new table, not a new column. It will give me a table combined with all the columns in one column. You just have to expand the column and select which columns from the second dataset you want to include in your overall dataset. So let's do that practically. So here you can see I just have tables. If I select the expand column option over here, you can see I have a lot of columns here. So just deselect everything. I do have row ID, I do have a customer ID. What I need is order ID, order date, shipment mode, and customer name. I do have it. So that's all I need. So just press on OK, and I should have them included in my new dataset altogether. It might take a little while. So there you go, we have the new orders ID, order date, ship date, and ship mode added to our dataset. Now just click on close and apply. And your dataset is all ready for data analysis. Apply changes, but it is taking a little time. So at the end, you just have to click on the apply changes and your data will be ready for analysis. So that's exactly how you can perform data transformation in Power BI desktop version. So there you go, the dataset got successfully loaded all over here, and you can just drag and drop them onto the visualizations part and you can work on your data.
Now this comes with mainly 4 functions. So you have gather, which makes your data wide, or it makes wide data longer. So that is basically used to stack up multiple columns. You have spread function, which makes long data wider, that is stacking the data together, or stack if you would want to unstack the data to data. and you are talking about data which has same attributes, and then your spread can spread the data across multiple columns. You have separate, which is function which splits single column into multiple columns, and to complement that you have one more function which is unite, and that combines multiple columns into single columns. So these are four main functions which are used in your tidyr package. So let's look how we work with this. So let me bring up my R Studio here. Now for this, first is, let me just clean up my screen here, doing a Control L. So I will install the package. It is already installed, but we can just do a Control Enter, and then I can say, do you want to restart R prior to reinstall? So install, I'll say okay, and it is basically going to get the package. Now it says package TIDYR, that is tidyrs, has been successfully unpacked. Let's use that package using our library function, and that was built under R version 3.6. Now I can basically start using these functions. So for example, here we are creating a data frame. So let's say n is 10, and then we basically would say we will call it wide. Now that's the variable name. I'm using the data.frame function. I'm saying ID, which will be 1 to n. So that will take the values from 1 to 10. And then these are the values which have 10 entries. So this is a vector, phase 1, phase 2, phase 3. Let's create a data frame out of it. Now that's done. We can have a look at our data frame by just doing a view wide, and that shows me the ID column, and it has phase.1, phase.2, and phase.3. Now we can use our function. So for example, we can work with gather, that is reshaping the data from wide format to long format. And basically you can say stacking up multiple columns. So let's see how we do that. Here I'll call it long. I'm working on wide. I'm using the piping functionality, and then I'm using gather. So this one, I will say what will be the data which I will use. So we are using wide as a data frame. Then I'm saying response time. So that will be basically one more column. And then you have your columns which you would want to basically stack. So I'm saying from phase 1 to phase 3. So let's do this. And once this is done, let's have a look at our variable long. So this one shows me that I have an ID column, I have the response time column, and I have the phase column, which we mentioned. And that basically has all the values stacked in. So you have phase.1, phase.2, and phase.3. So all the columns are being stacked here. So all my data, so now I have totally 30 entries in this one. So this is basically using your gather function. Now sometimes we may want to use a separate function. Now separate function is basically splitting a single column into multiple columns. So which we would want to use when multiple variables are captured in a single variable column. Okay, so let's look at an example of this one. So let's say long separate, that's what we will call. We will work on this long, which has all the data stacked in as the columns we selected. Then I'm saying separate, I want the phase column, and then I would say when I separate the columns, what are my column names. Now I could also give a separator by giving a comma and then mentioning the separator if that is required. So let's do this. Now once this is done, let's have a look at our long separate. So what we see here is the column which we used. So we were doing a phase column, and that was to be split, and we wanted to split it into target and number. So that's what we see here. So you have phase being split into target and number, and then you have the response time. So this is how you use the separate function. Now there is also something called as unite function, which is basically a complementing of separate function. So it takes multiple columns and combines the elements to a single column. So for example, here we will call it long unite, and we will take long separate, which was separating the data. We want to unite, so we will take phase, target, number, and we want to have a separator between them. So let's basically do this. And now let's look at the result of this unite. So you see, you have the face and target merged together. So you have face dot one, the separator is dot, as we have mentioned, and we have united multiple columns. So this is one more function of your tidyr, which helps you basically tidy up your data or put it in a particular way. Now, then you have your spread function, and this is basically for unstacking. So that is, if you would want to convert a stack to data, or if you would want to unstack the data which is of same attributes, spread can be used so that you can spread the data across multiple columns. So it will take two columns, say key and value, and spread it into multiple columns. So it makes long data wider. So we can look at this one. We will say long unite. I'm using the piping. I will use the spread function. I'll work on the face column and response time. And let's do this. And then let's do a view on this. So it tells me our data is back in the shape as it was in the beginning. So these are four functions which are very helpful when we work with tidyr package.
So let's learn about visualization. And here we will learn about R, which can be used for your visualization. Now, one thing which we need to understand is because of our ability to see patterns, which is highly developed, we can understand the data better if we can visualize it. So the efficient way or effective way to understand what is in our data or what we have understood in our data, we should or we can use graphical displays, that is your data visualization. So there are actually two types of data visualizations. So you have exploratory data visualization, which helps us to understand the data. And then you have explanatory visualization, which helps us to share our understanding with others. So when you talk about R provides various tools and packages to create data visualizations, and which can be used for both kind of data analysis or both kind of visualizations. So when you talk about exploratory data visualization, the key is to keep all the potentially relevant details together. Now, the objective when we talk about exploratory data analysis is to help you see what is in your data. And the main question is how much details can we interpret? Now, when you talk about different functions which we see here, such as plot, which is more for a generic plotting. You have bar plot, which is used to plot data using rectangular bars, or you can say creating bar charts. You have histogram or hist function to create histograms, where you look at the frequency of the data, or basically used to look at the central tendency of the data. You have box plot, which is used to represent data in the form of quartiles. You have ggplot, which is a package which enables the user to create sophisticated visualizations with the little code using the grammar of graphics. And then you have plotly or plotly. It creates interactive web-based graphs via the open source JavaScript graphing library. Now, before we see some examples here, let's also talk about, when you talk about plotting, let's also try to understand what kind of plots you can have and what kind of techniques you have. So let me open up my RStudio here. Now, for example, I can pull out a particular data set, and let's look at this one. So here I can look at all the panes, and that shows me the information. Now what I can do is I can install and get the inbuilt data sets, and then I can simply do a plot wherein I am doing a plot on chick-weight data set. So let's see what does that show. It summarizes the relationship between four variables in chick-weight data frame, which is in R's built-in dataset package. Now from these plots, we can see, for example, weight varies systematically over time. You can also see that chicks were assigned to 4 different diets. Now, when we talk about explanatory data analysis, or visualization that shows others what we found in the data. This means we need to make some editorial decisions, what features we would want to highlight for emphasis, what features are distracting or confusing and you want them to be eliminated, right? So there are different ways of doing it. Now, when you talk about your graphics or visualizations, you have, I would say, three different types, or you can say four. So you have the base graphics, which is easiest to learn. Now here we are having an example of base graphics where I can use the base graphics. I can get a data set using library. Then I can simply create using plot function to generate a simple scatter plot of calories with sugar from US serial data frame in the mass package, and then I can give it a title. So this is basically a simple example of base graphics. Now you also have what we call as grid graphics, which is powerful set of modules for building other tools. Now you also have lattice graphics, which is general purpose system based on grid graphics. And then you have your ggplot2, which implements grammar of graphics and is based on grid graphics. So you have different ways. Now here, since I already have used library and I have the data set, I can just do a X. So I can assign the sugar related values to X and calories related value to Y. Then I can use one more, which is library function and calling in grid. Now I can basically use functions such as push viewport if I would want to create a plot using your grid graphics to create the similar kind of plot which we created using base graphics, but this will give you much more power than base graphics. It will have a steep learning curve, but it is usually useful. So I can do this where I'm saying push viewport. Then I can basically say I would want to have a data viewport. I would say different functions of your grid package. So I'm saying rectangle, you have x-axis, y-axis, given some points here. And then basically you can add details to the graph by giving the names to the columns, and you can basically create a simple grid graphics based plot here. Now, there are different other options which we can use to create plots. Now, before we go into understanding how you create plots, let me just give you a brief on what are the different kind of plots and how they can be used. So here we will look at these different plots. Now, for example, we have a bar chart, which is a graph which shows comparisons across discrete categories. So you have x-axis, which will show the categories being compared, and y-axis, which represents a measured value, and height of the bars are proportional to measured values. Now, to create different kind of charts, you can use ggplot, which is a package for creating graphs in R. It is basically a method of thinking about and decomposing complex graphs into logical subunits, and that is a part of tidyverse ecosystem. So it takes each component of graph axes, you can give scales, you can give colors, you can give the objects, and you can build graphs on particular data. You can modify each of those components in a way that's more flexible and user friendly. You can, if you are not providing details for the components, then ggplot will use sensible defaults, and this basically makes it a powerful and a flexible tool. Now here are different options when you use your ggplot, such as you can use geom, or what we call as geometry objects, to form the basis of different type of graphs. For bar charts, you have for line graphs, you have scatter plots, that is underscore point, you have underscore box plot for box plots, you have quartile for continuous x, violin for richer display of distribution, and jitter for small data. So here is some simple example where I would not go into too many details here, but you can just have a look at this one where we are using library function to get the ggplot2 package. Then basically we would want to look into the mileage data. We would want to look at the structure of it. And then we can basically get the tidyverse package. Finally, we can create a bar chart using geom underscore bar. And we can basically also mention what would be in x-axis. Now you can also give different colors to basically add more meaning to your data. You could also go for stacked bar charts. So here we are actually telling ggplot to map the data in the drive column to fill the aesthetic. So here I am giving aesthetic access class, and I'm saying what is the data we need to have, and then we are using geom_bar. So you can also have dodged bar in your ggplot, that is not bar charts which are stacked but next to each other, and you can create that by using your position as position_dodge. Okay, now you can obviously use your different packages which are inbuilt, and you can create your bar charts. And you have other kind of graphs such as line graph, which is basically a type of graph that displays information as a series of data points connected by straight line segments, such as this one. And for this one we are using, if you see, geom_line. Now you can also create a scatter plot, which is a two-dimensional data visualization that uses points to graph the values of two different variables, one on an x-axis, one on y-axis, like what we saw in base graphics example. And they are mainly used if you would want to assess the relationship or lack of relationship between two variables. And you also have histogram, which I mentioned is mainly to look at the distribution of a data, to look at the central tendency of the data, basically looking at your large amount of data or for a single variable. You would be interested in saying where is more data found in terms of frequency, where is lesser data found in the graph, how close the data is towards its midpoint, or what we call as mean, median, mode. So you can use histogram, where you can categorize the data in what we call as bins. So these are some basics on different kind of graphs. Now we can look at some examples and see how that works. So what we were seeing is some quick examples of base graphics or grid graphics. Now here, let's do an example of pie chart for different products and units sold. So you want to create a graph for this. First, let's create a vector and pass in the value here. Now I can also create labels which I would want to assign to these values. And then basically I can plot the chart by saying pie. So that's the kind of chart which I would want to create. And I would say the data would be X and labels. So let's do this, and that shows me a simple pie chart. Now I can also give main details here. So instead of just doing a pie X comma labels, I can say what is the main and then what kind of coloring it should follow. So this is the way you can create a simple plot. Now I can also find out what is the percentage, and then basically I would be interested in plotting the pie chart, which takes X, which takes the labels, which will be the percentage, which we are calculating here by doing a round function. And then you can basically give details to your graph. You can say what color it follows. You can basically look at the legend where it needs to be in your chart. What are the values? And then basically fill up the colors. So let's run this one, and that shows me the percentage which was calculated, and it gives me the details, and we can always have a look at our plot. Now if you would want to go for a 3D pie chart, then you can get the package which is Plotrix. Let's use that by calling in the library function. Let's pass in some data to X, and let's give some values or labels which will make more meaning to the data. And then let's plot the 3D graph. So I'm saying pie 3D here, where I'm using X and labels. Then I'm basically doing an explode, which will basically control how your graph looks like and basically give the values. So it also takes the title when you say main and pie chart of countries. Now let's create data for graph. So again, we are having a variable here. We are using the C function, creating a vector, and then let's create a histogram for this one, where I would say X lab, what would be your data around x-axis, what is the color, what is the border, and here I'm creating a simple histogram, which, as I discussed earlier, will always show your values on the x-axis, and y-axis is more of frequency. And then you can look at the set of values and what is their frequency. And we can basically use this histogram for exploratory data analysis, look at the data, try to understand what is the central tendency of your data values. Now we can also give some limits by using the x-lim and y-lim, and then I can also specify what is the limit. So we have given some values here wherein we have said your x limit is 0 to 40 and y limit is 0 to 5. Now if you compare this with the previous one which we had created, this one based on the frequency had taken the limits, but we can assign limits explicitly by giving this and then create a histogram which makes more meaning. Now let's take another data set, that is air quality. Let's view this to see what does that data contain. So you have ozone, solar, wind, temperature, month, and the day. So this is the kind of information we have in the air quality. Now let's use the plot function to draw a scatter plot, where, as I mentioned, you would be interested in analyzing variables and see what is the relationship between them. So to plot a graph between ozone and wind values, so we will say plot, we will say the data which is air quality. From that I would be interested in the ozone column or ozone field and the wind field. I can create a plot based on this. Now I can also be saying what should be the color, what is the type of the data which you would want to create, and you can look at the information. So you can create a histogram, you can create a scatter plot to basically understand the data better and then infer some information from that data. So let's take the air quality data set itself without specifying any particular column, and you can create a plot which shows me all the different values which you have in the data, and it basically shows you the difference. This is more of an example like what we did for chick weight, where we did a base graphics. Now you can assign labels to the plot. So that is when you are creating a plot, you can say air quality, you will say ozone, and then that's your ozone concentration. You have your YLab, which is the number of instances. You have what is the title, ozone levels in New York City, what is the color. So these are the details what we have given with our plot function. And let's look at the data. So it just tells me that this is the ozone concentration, the number of instances what you have, and you are looking at the data. Now we could also create a histogram by picking up a particular column, that is such as solar, from your air quality, and that basically shows me the frequency of solar values, and we can then try to find out what is the mid, what is the mean, what is the standard deviation, and so on. You can also look at your histogram and try to understand if it is left skewed and right skewed. So we can do that. Now here, let's get the temperature out from this particular data set. Let's create a histogram on temperature, and that basically shows me the frequency of the temperature values and what values have the most frequency or most occurrence. Now you can create a histogram with labels. So let's do that with the limit, and then let's also use text to basically give in the values, which also takes the values, and for each set of frequency or each set of values it gives me the labels. Now you can have a histogram with non-uniform width, so you could do that by doing a hist function and then passing in your temperature. You can say what will be the main, what is the title, what will be your X lab. It will tell you a limit around x-axis, what is the color, what is the border, what are the breaks you would want to have for your bars, and you can simply create a histogram using this. So this basically takes the breaks which we have given, such as 55 to 60, 60 to 70, 70 to 75, and so on. So this is basically creating a histogram with non-uniform width. And it purely depends on the kind of values what you have. Now you can also create a box plot, which sometimes helps us in understanding the data quartiles, also understanding our outliers. So you can create multiple box plots based on the data from air quality. So we'll select all the data and then we'll do some slicing on the data. So let's create a box plot which tells me the values. And if you look at these points here, like single dots, these are basically your outliers. We can learn about that more in later sections. So you can use your ggplot2 library to analyze a particular data set. So for that, we will first use the install.packages and get ggplot2. So it says, do you want to restart R? And I can say yes. So let it get the package. I think the package was already there. And now let's look at using ggplot2. So for that, I have the library function. And let's do a attach where I'm getting a data set which is empty cars. Now then I will create a variable p1. I will use ggplot. I will pass in my data. I'll give the aesthetics. What is the columns which you would be interested in? And then you are using geom_boxplot to basically create a plot which gives me the box plot for the values here. And this is based on the cylinders which is there in your data. So we can always look at what does our data contain and what kind of values or features are available in the data. Now let's create a box plot. We will also use the coordinate function, and that basically gives me based on the data. So I've changed the coordinates. Now if you look at the previous one where we created a plot, we had mileage on the y-axis and cylinders on the x-axis. Now I did a coordinate flip, and that's like your transpose function. So you have created the box plot, but you have just flipped the coordinates. You can create a box plot and then say fill, which is the factor of cylinder. So that can be used to fill up the values in your box plot. Now what we can also do is we can create factors. So we have learned about factors earlier, which is usually used to work on categorical variables. So here let's create a factor which is empty cars gear. You have AM, you have cylinder. And if you look at the factors which we have created, we have passed our data. What is the field or the column we are interested in? What is the level of values there? And what are the labels for those values, right? So we have learned about factors. You can always look into the previous section and learn more about factors. Now let's create a scatter plot by using the ggplot function. Again, we will use the data as empty cars. I will go for mapping option, and then I will give my aesthetics. That is what would be X, what would be your Y, and you also would want to use what kind of function you are using. So let's go for geom point, and that basically helps me in creating a scatter plot. Now you can create a scatter plot by factors. So here we will say ggplot. So notice in all of these cases, depending on the kind of data you have, depending on the kind of plot you are interested in, you will use the ggplot and then basically a function with that or the inbuilt package. So here I'm saying data is empty cars. I'm going for mapping, which basically will take the values for your X and Y. What is the color? And the coloring will be done based on the factor values. Now, if you remember, factors will obviously have some levels, and those levels will basically help you in differentiating between your categorical variables. So I'm saying as.factor on cylinder, and then I'm using geom point to basically create this scatter plot. So let's do this, and I can look at the values of this one. So it says must be, there is an error which says must at least one color from the hue palette. So let's look at that one. So the error which we were facing when we gave color as the factor values was because when you look at these factors which were created with some labels, if we look at the values of these, it tells me there are NA values in that particular column. Similarly, your gear, or similarly, you can completely look at the complete data set. It tells me cylinder, you have AM, you have gear. Now these have some, we have created some labels, but these have NA values. So what we can do is we can create a scatter plot as we did earlier by giving the aesthetics, and that's a simple scatter plot wherein I'm also using geom point so that I can have these points by defaults or with defaults. You can also give a color specific, basically if you would want to have different kind of data in the same plot, or I can create scatter plots by different sizes by giving a size, or I can give a color and size, and that's again one way in which you can create your scatter plots. Now let's also see how you can visualize one more data set, which is MPG. So I can also do it in this way where I set ggplot2 and then pass in, look at the data set what we have here. You can just do a view on this to see what my data contains, if the fields have any NA values, if that's going to affect your plotting. So now what we can do is we can create a bar plot or a bar chart. So I'm saying ggplot, the data would be as we have given in previous lines, that is ggplot2 mpg. Then I will say what should be in my aesthetics and what kind of chart are you going to create. So I'm saying geom underscore bar. So that's my bar chart, and that has basically your class and count. Now you can create a stacked bar chart where your information is stacked in the same bars, and we are still using the same data. We are going for aesthetics, which is class, and then when you say geom bar, which creates your stacked bar, we will use fill, which is drive. And we can always go back and look at our data. For example, you can always look into this. So you have the drive column here, and you are also working on this complete data set. So let's go ahead and create a stacked bar chart. And that basically gives me the information where you have the drive information, which is stacked here. Now you can do a dodge by giving the position as dodge. So we are still going to go for a stack chart, but this time the bars will be next to each other, and that can also be done, which is very useful. You can use this by using geom point where you are mapping and you are specifying what are your aesthetics. So we were creating a scatter plot. Now you can also use or give more details where you can say color can be based on the class, and we have different classes, and based on that my points have been colored. Now you can also use a plot ly or plotly library. So let's install this one. I will say yes, for example. Let it basically restart so that all my packages are updated. Then I can access that package using library function, and then create a variable to which you are assigning your plot underscore ly plot. So data is empty cars. What will be your x-axis, what will be your y-axis, and details on your marker, which we have given, wherein I will give a list which is size, color, which is a combination, and then you have your line, what kind of color it will have, and what will be the width. So this is where I'm going to use plot ly, and let's look at this plot. So it basically gives me some information. Now we see some warnings which are getting generated, but you don't need to worry about that. So you can look at the packages, what you have, and what options you are using. So similarly, we can create one more plot using plot ly and look at the values of those. So that's a plot with a trend which explains me about my data. So this is a simple small tutorial on understanding or how you can have your graphics or visualization used to understand your data. Obviously, there are much more examples, much more ways in which you can pass into your plot functions or your ggplot and the inbuilt packages which are available in R for your visualization. Now that could be for exploratory data analysis or explanatory data analysis. So try these graphs and see if you can change these options and try or create new visualizations. Good morning and good evening, everyone. So welcome to this session where we will learn on time series analysis using R programming language. So this is basically a mini project where we will look at time series data and how we can analyze it, visualize it to basically find some important information or gather insights from the data. Now, when you talk about time series analysis, time series is basically any data set where your values are measured at different points in time. So when you talk about time series data, data is usually uniformly spaced at a specific frequency. For example, hourly weather measurements, you have daily counts of website visits, monthly sales total, and so on. So when you talk about time series, that can also be irregularly spaced and sporadic. For example, timestamp data in computer systems, event log, or history of 9/11 emergency calls. Now, when we work with time series data, for example, here I'm taking a energy data set, we can see how techniques such as time-based indexing, resampling, rolling windows can help us explore variations in electricity demand and renewable energy supply over time. Now, here we will look at some aspects of this data set which I am considering. So this is open power systems data set, and here is the data set I have. We can look at the data set. Now this is in a simple format. It has time. It basically has values for consumption, and then you have data for wind and solar and wind plus solar. So in certain cases you have only the date and the consumption. But then if we scroll down, we will also find data for wind, solar, wind plus solar, and so on. So this is a time series data set which we would want to work on. Sometimes you may also have the data collected which just does not have the time, but it may also have timestamp. That is, it would have, say, hour, minutes, and seconds, and that can also be worked upon. So let's consider this data set and let's work on this project where we will analyze this time series data set. Now here we can work on this time series data. We can basically create some data structures out of it, such as data frames. We can do some time-based indexing. We can visualize the data. We can look at the seasonality in the data, look at some frequencies, and also do some trend detection. Now, when you talk about this data set, it has electricity production and consumption, which is reported as daily totals in gigawatt hours. And here are the columns of the data, which I was just showing you. So you have data, you have consumption, you have wind, you have solar, and wind plus solar. So this is the data we have, and we will basically explore, say, electricity consumption and production in Germany, which has varied over time. So some of the questions which we can answer here is, when is electricity consumption typically highest and lowest? How do wind and solar power production vary with seasons of the year? What are the long-term trends in electricity consumption, solar power, and wind power? How do wind and solar power production compare with electricity consumption, and how has this ratio changed over time? We can also do wrangling or cleaning of this data or pre-processing of data and create a data frame, and then we can visualize this. Now let's see how do we do that. So I will open up my R Studio and let's look at the data set. So here is the data set. Now I'm picking it up from my machine. You can also pick it up from GitHub. So all the data sets or similar data sets can be found in my GitHub repository. And here I can look in the data sets. You will find a lot of different data sets here. There are some time series data sets such as power. I can search for power, or you have basically coal, or you have this OPSD Germany daily data set, and there are many other data sets which you can work on. Now, to get the documentation on this project, you can also look in my GitHub repository and you can search for repositories, and then basically you can look in data science and R, and here there is a project folder where I've given the documentation, sample data set, and also your time series analysis related document. This is also the code which you can directly import in your RStudio, and you can practice or work on this project. So let's see how does that work. So first thing is we will create a data frame from this data set. Now here, if you see, I am using header as true so that it understands the heading of each column. I'm also giving row.names and I'm specifying date. So there is this date column in the data set as I showed you earlier. Let's look at it again. So you have date, consumption, wind, solar, wind plus solar. So you can suggest that date should become the index column, which can be useful. So you can do this. Now let's just create this. Let's look at what does this data frame contain. And here, if you see, it shows me some data which has been now as a part of this data frame structure. It starts with consumption, wind, solar, wind plus solar. And if you see, this one is becoming my index column. So I can always do a head and look at part of the data frame using head or tail. So look at the first records. So let's see this. Now that shows me the head data. I can also do a tail and look at the ending values. So if you closely see here, we have wind, solar, wind, dot solar, and that basically has NA values. So there are missing values, but let's look at the tail, and that tells me that there is some data available for wind and solar and wind solar. Now we can always look in a tabular format using view, and we can look at the data. So this shows me that there are values in these columns. We see NA values, but if I really scroll down, I can see some values which would be available for wind and solar and wind solar. So I can just use view. Now I can look at the dimensions of this particular object, and that tells me there are 4,384 rows and 4 columns. You can always look at the structure, that is check the data type of each column, which can be very useful. So if I see here, I don't see the date column because date column was considered as an index, which can be useful. But I also look at my other columns, so they are of the num types. So that's the data type for each attribute or each column here. Now we would be interested in looking at this date column. So let's look at the data type of this date column. Now if I try to do this, this will show me that this is null because date as a column does not exist because we created it as an index. So if I look at row names and then I search for my data, show me the index column or row dot names, it tells me these are the values, that's the date column, which we are seeing here. Now we can access a specific row by just doing a my data and give the index value or row name value. So let's look at that, and that shows me based on this index you're looking at the value. You can obviously search for a different date, something like this. You can also pass in a vector and you can give range of values. So that is 0, 1, 2006 to 4 of January. And we can look at this one. So it shows me these are the values. So here actually I'm not giving a range, but I'm just selecting multiple values from row dot names. Now we already know that in R you have a summary function. So you can always do a summary, and that gives you for each column, it gives you minimum, first quartile, median, mean, third quartile, and maximum values. So we are looking at consumption, we are looking at wind, solar, and wind dot solar. Now this is good, but then if I would want to really visualize the data, access the data, do some analysis, then it would be good to take all the columns, and then we can later decide to change the data type of say date column if we want to use it. So earlier I was using date as row dot names or the name of the rows or index, what you call in any other programming language. So here I will just use my data set and I'll say header as true. I'm calling it my data 2. Let's look at the data, and this one shows me 5 columns, wherein my first column is the date, consumption, wind, solar, and so on. Now looking at the structure, so let's look at the data type. So it tells me that if now I'm interested in looking at the date column from my data to data frame, it tells me it is a factor with 4384 levels, and these are the values. So it is not in a date time format, it's a factor. Now what we can do is we can convert this into a date format. How do we do that? So let's have a variable x, and I'm going to use as.date function, and I'm going to pass in my date column. So that's assigned to x. Now let's look at the head of x, and it shows me the values. We will also see what kind of class it is, and we will look at the structure of x. So class already says it is date type, and look at the structure, so it shows me the format. Now we have converted this column or column related value into x. Now how do I basically extract values out of it or make it a part of data frame? So first I will use, so all once it has been converted in date format, I will go for as.numeric, and here I will create a variable called year, and I will just do a format on x, which is basically of date type, and then I'm saying %y, so that will get me the year component out of this. Let's look at the values. That shows me year component. Now similarly, we can get the month out of this, and then basically look at the month values. We can get the day out of it, and we can get the day component. Now if I look at my data 2, which we had created earlier, this basically had date, consumption, wind, solar, wind, solar. So what I can do is I can add these extracted columns such as year, month, day to my data frame using a cbind, that is column bind, and I will assign it to my data 2 again. So let's do this. And now if you look at head, it shows me date, so that should be date format, consumption. Now this one might not be date format, but we'll see. You have consumption, wind, solar, and we have extracted the year, month, and day, which can help us for group by. We can do some aggregations, we can do a plotting, and we can do various things by these additional columns. Now let's look at first 3 rows here. So I'll say 1:3 for my data 2, and that shows me some data here. You can always do a head and look at the sample of data. So that basically shows me month, day, your columns, and then you have your date. Now what we can do is we would want to visualize this data. We would want to basically understand the consumption. Now as I said, if we want to visualize the data, say for example I want this, which is consumption of data over years, and this one is in terms of gigawatts per hour, as we were mentioning here, gigawatt hours. So if I would want to create this visual to basically understand the pattern of the data, how do we do it? So we can create a line plot of full time series of Germany's electricity consumption using the plot method. Now how do we do that? So here one of the option is I can straight away use the plot method. I can then say what would be in my x-axis, what would be on my y-axis, what would be the type of graph I would want to plot, what is my name on x-axis, y-axis, and this is the simplest way. So I'm saying my data 2, I'm extracting the year column, and here I'm taking the consumption. So let's create a plot. And here, if you see, we are looking at a plot. We do see some tick times, and we see that the data has been divided with every 2 years. So from 2006 onwards to 2016. But then really this data does not give me a very useful way of looking at the data or understanding it. Might be what I can do is I can use the same way, but I can give, apart from x-axis and y-axis, I can say the limits, that is x limit is 2006 to 2018 and y limit is from 800 to 1700. So we can do this, and let's look at this again. This is a plot, but it really does not help me in visualizing and understanding the data. So what are the better options? I can go for multiple plots in a window. As of now, we are just sticking to one plot in window. So if you would want to have multiple plots, you can always change the value here and make it 2 or 3. That will say how many rows and how many columns. So as of now, we will just keep it as it is, par mf row. Now, if I would want to plot, I can straight away give the column name. So I'm interested in getting the consumption. Now I can just do a plot. I'll say my data 2, and I will choose the second column, which is consumption, which we saw here from our data. So consumption was the second column. So I can just do a plot in a straightaway way without mentioning your x-axis, y-axis, limits, and so on. And if you look at this one is giving me a pattern. Now here I am looking at x-axis, y-axis, which is not really named. We do not have a name to this graph, and we are looking at the data. It does show me some kind of pattern, but might be we can make it more meaningful. So I can do it this way, where I say my data second column, let's give axis as year, x-axis, y-axis is consumption. Now that has changed, the x-axis and y-axis. Now I can also give some more details. I can say type should be line. I have the line width. I'm saying color is blue. And let's do this. So this looks more meaningful, might be shows a wavering pattern of consumption over years. I can also give a limit of X, that is 0 to 2018, and that basically shows me the range. Now we can change that and we can be more specific and saying X limit should be 2006 to 2018. And let's look at this. Now this one, once you have given a proper limit, it shows the line graph and it shows what was the consumption in 2006 and over a period till 2018. I can then use any of these options are fine, but it depends on what and whom you are presenting the data or what kind of analysis you're doing. So I can do a plot. I can choose column second, X lab, which is x-axis, y-axis, type is line, width, giving a X limit, Y limit, and then I'm giving a title to this, which is consumption graph. And then basically you are looking at the line graph. Now, those are the options which you can do. Either you could be very specific, or you could just give your column which you want to plot, or obviously make it more meaningful by giving all the details. Now, what we can do is, if we would want to look at this data and understand it better, rather than just looking at a simple line, I can take the log values. So here I'm saying log of my data 2 second column. So I'm taking log values of consumption and I'm taking the difference of logs. So I can say difference, and then you can basically increase or decrease this by multiplying it by some number. So rest remains the same. I'm changing the color, and let's look at this plot. And you see, this basically is giving me a better pattern, which makes meaning. Here we see the log values. So this is, you are using a simple plot function. In R, you can also use ggplot. Now for that, we can install the ggplot package. It's already there in my machine, so I'll say no. I will access this by using the library ggplot2. And now I can use ggplot to plot. So the way you specify here, you can say my data 2, that's the data frame. I'm saying type as O, and when I'm saying line, I am basically going to use x-axis, which is year, y is consumption. And let's look at this plot. So again, we are back to the one which we were doing earlier. Really does not make any sense. It gives us some data, but then really does not give me enough information. I can, in my aesthetics, I can say X as year, Y as consumption. I can do a grouping, and then I can give line and plot. So again, we have some information, but really does not help me, right? Now let's look at other example. So I'm just doing the same thing here, and I'm looking at line type being dashed. I'm using the ggplots other methods such as geom_line and geom_point to give me more information. And if I look at the plot, it does give me data. It tells me what are the different values. It gives me some kind of pattern, but I would still prefer the way we were doing with plot. Now, We can change the color and obviously add details to it. So what we see is when you use the plot method, which I did earlier, it was choosing pretty good tick locations, that is every 2 years, and labels the years for the x-axis, which was helpful, right? But with these data points, which we were seeing here, or say, for example, this one, or say this one, or say this one, we are looking at some data, but then that really is quite crowded and it is hard to read. You can look at the values, but then it really does not give you enough information. So we can go for plot method, but then we will see how we can consider different data. Now, if I would want to plot the solar and wind time series, so let's see how do we do that. So wind column is what I'm interested in. So first thing is, it was always good to find out the minimum and the maximum values in every column. So I'm saying minimum, I'm saying let's put in here my data 2, and then let's look at the values. So we are looking at the columns. We know consumption is the second column, wind is the third column, and you have solar as the fourth, and this one is the fifth. So let's say, let's find out the minimum of each of these columns which we would want to plot. So let's say minimum of data third column. And here I'm also saying remove the NA values because we do not want to consider the NA values. So let's look at the minimum. That shows me 5.7757. What is the maximum value? It is 826. So that also helps me in giving a limit. If I want to plot wind on y-axis, I can give a y limit from 5 to 850. Consumption wise, let's find out the minimum from second column and maximum. And similarly for solar, find the minimum and maximum, and wind plus solar, minimum and maximum. So this will be helpful when you would want to plot multiple graphs or give some limits. So that's fine. Now for multiple plots, as I said, instead of having one plot, let's plot consumption and wind and solar and try to see a pattern. So I can say par function, and I will say 3 rows and 1 column. So now when I start plotting, you will see you will have multiple plots in one single window. So let's see how we do it. So here, let's look at plot 1. So this one is consumption as we did earlier. And let's look at the data. So that gives me some data. You can always do a zoom and you can look at the data. You can basically expand this graph or you can reduce this graph to see what kind of pattern we have in consumption. Similarly, we can basically choose date being x-axis, my consumption being y-axis, right? So this is being more specific because here we have a range, but it really does not give me enough information. So I will basically give x-axis, y-axis. I will give the name, that is daily totals, and then I will basically give consumption, color, and y limit based on my minimum and maximum limits. So let's do this. And now we can look at the data here. So let's see, this data makes a little more meaning because we are looking at the dates. And let me do a zoom. So it shows me all the dates. It shows me the data points. It shows me how the data pattern is changing for consumption. Now, this is for consumption. So what we can do is we can also extract specific data. So if you see here, I have done some testing where I'm saying, okay, I would want to get a date specifically. I would want to extract some value. So we are looking at the date column, but if you remember, we did not change the data type. We just changed the data type of date column. We extracted year, month out of it. It would be good if we can convert a column into date time format and put that in our data frame. Now, let's look at the plot 2. This is mainly for your column, which should be consumption and wind and solar. So here I see it is solar data, and I can plot this one to see how it looks like. And that tells me from 2006 onwards, we have some pattern. I can be more specific where I say I would be giving date and then the column for solar, x-axis, y-axis, what is the type, what is the y limit, and what is the color. It is always good to specify your x and y axis, give a name rather than let it automatically pick up. Now this makes more meaning because it shows me some dates. Similarly, we can do for wind. So either you do it just by giving the column or you give your x and y axis. So let's look at this one. And this shows me the data. So we can choose plot 3. This one we can choose plot 2. We can choose plot 1, and we can put all that data in one graph. So that's when you are putting in multi plots in one particular graph. You can always do a zoom. You can always look at the data, right? And this is usually useful to look at the pattern, what kind of pattern we see, what data we have, and so on. Now, moving forward, so we have seen how you are creating these plots all in one window. Let me reset this back to one plot per window. And let's basically plot time series in a single year. So what we have seen is that when you look at the plot method, it was quite crowded. Then we looked at solar and wind. And if you compare that, you will see your consumption pattern, your solar pattern, your wind pattern, and basically we can see from this particular data some kind of pattern. So electricity consumption is highest in the winter, where we will see what is the consumption. Is it highest in winter or is it in summer? We can see that by breaking a year further into months. We can see that, but we see a pattern which goes for every year or every 2 years being highest at a particular point of time, and then it drops down. So electricity consumption is highest in winter, and that might be due to electrical heating and increased lighting usage, and lowest in summer. Now, when you look at electricity consumption, appears to split into two clusters. We can always look at the consumption, one with oscillation centered roundly around 1400 gigawatts. So you can always look at 1400 gigawatts and you see all the values here, which are in that particular consumption. Another with fewer and more scattered data points, centrally roughed around 1150. So if you really expand this, you can see you will have a lot of data points at this point. Now, we might guess that these clusters correspond with weekdays and weekends, which we can see if you break that data into yearly, monthly, weekly, and so on. Now, if you look at solar production, that is highest in summer when sunlight is most abundant and lowest in winter. So obviously when you're making or gathering some insights, when you're looking at the data, you are also using your domain knowledge, your business knowledge, your knowledge of business to understand how this goes. If you look at wind power production, that's again highest in winters and drops down in summer. So due to stronger winds and more frequent storms, and lowest in summer. So there is some kind of increasing trend in wind power production over years, which we can see here over the years. And all the time series data what we are looking at is referring or showing us some kind of seasonality. That is, we are looking at seasonality in which a pattern is repeating again and again at regular times, at regular intervals. So if you look at consumption, solar, and wind time series, that oscillates between high and low values on a yearly time scale, which we can break down and see. I'll show you that. It corresponds with the seasonal changes in weather over the year. So seasonality does not have to correspond with meteorological reasons. For example, if you look at retail sales data, that will show you yearly seasonality with increased sales in particular months. So seasonality, when we say, can occur on other time scales. So the plots what we are seeing here, they are fine, but if you look at those plots, they might show some kind of weekly seasonality also. So in your consumption corresponding to weekdays and weekends. So let's plot for one single year. Now, how do I do that? So first is I will look at my data 2. That shows me the structure. It shows me date, which is factor, other columns, which are all numerics. Now like we did earlier, I'll repeat this step where I'm going to convert the date column into date type, look at head of it, look at class of it, look at the structure of it, right? And then what I want to do is I want to add this to my data frame. So I will create a variable called mod data, and this one will have as data, and I'm formatting the value of X, which is date time, into month, day, and year. So let's do that. And now you look at the mod data, which I created, like modified data. So this is the format I have. It is in date type, if you carefully see here. And then I can look at the head of it. So it says me mod data. Now what we did here is when I said my data 3. So my data 3, we did a cbind and I did a mod data, which is going to add this column to my other columns of my data 2. So my new data frame is my data 3. Let's look at the structure of it. And you see there is this date column. I can delete it, I can remove it, I can let it be, right? So that depends on our choice. Might be we want to, once our analysis is done, we want to remove the mod data, right? So we can keep both of them. Now let's basically extract data for a particular year. Now how do you do that? So this is some wrangling. So I will say my data 4, let's call it my data 4, and I will use subset function. So subset will work on my data 3, that's the data. And what I'll do is I will do a subset. How is the subset found? So I'll say take the mod data column, the value should be greater than or equal to 2017 and should be less than 2017 December 31st. So I'm getting data for 1 year and I'm storing it as my data 4. Let's get the head of it, and you see we are specifically looking at 2017 related data. Now let's do a plotting of this where I will only create a plot for 1 year. So I'm saying my data 4, that's my new data what we got. So here I am going to take the first column, which is mod data. I'm going to take the third column, which is consumption. So I'm looking at the date format for 1 year, consumption values for it, and then rest of the things as we have done earlier. Let's look at the plot, and this makes more meaning, right? So when you look at this plot, it tells me Jan to Jan. It shows me some kind of pattern where I have divided the year into months, right? And it is broken down into say 2 months, so Jan and March and May and July and so on, but we still see a pattern, and that gives me good understanding of pattern where I've broken it down into months. So this is where you have taken time series in a single year to investigate further, and this is what we see, right? Now we can clearly see there are some weekly oscillations. What one more interesting feature is that at this level of granularity, that is when you're looking at yearly data, there is a drastic decrease in electricity consumption in early January and late December during the holidays, or probably we can assume that this is holidays. Now I can zoom in further and look at just Jan and Feb data. Let's see how we do that, and let's see how we work by zooming in the data further. So to zoom in the data further, let's see how we do it. Now here we have this my data 4, which is basically having a subset, right? So let's work on this one. So I will say my data 4, which earlier I was taking data 3, I was doing a subset and I was giving the date, but this time I will make it more narrower. So I'll say my data 4, I will say subset from my data 3, and I will choose mod data column, which we have modified with the date format. I will choose the starting date as 1701, that is Jan, and then let's go till Feb and let's create this. Now let's look at the head of this. So it shows me we have the data which is Jan, and then you can basically look at more on this. Now Again, as I said earlier, let's find out the minimum of this from the first column. So that is basically your mod data. So let's look into this one, and that basically will give me minimum and maximum. Let's look at the values. So this one tells me Jan 17, January 1, and maximum is your Feb 28th, second month 2017. So we are actually looking at 2 months data here. Let's look at the Y minimum. So this is, I will look at column 3. Now what is column 3? Consumption. So let's look at the minimum value for consumption, maximum value of consumption. Let's look at the values which can be given as our limits. Now this is the minimum and maximum. Now let's do a plotting for this data which has been narrowed down for consumption based on my data. So I'm saying my first column, which is mod data, and then third column, which is consumption. I'm giving some naming convention for, namings for your x-axis, y-axis, what is my consumption, or what is my title here, what is the color, and then you see I'm using X limit to give the minimum and maximum limit and Y limit. So let's look at this data. And if you look at this data, it is specifically for 2 months. And again, I can look at the pattern here. What I can also do is I can add some grid here. So I can basically look at this data and make more meaning out of it. So it is bi-weekly data, you can see. Now I can add a line here using ab line, and then I can basically choose what lines I would want to add horizontally. So that basically allows me to dissect the data and look at data in a more meaningful way. I can also add vertical lines. So vertical lines is, I'm saying sequence will be minimum, maximum, and I'm saying an interval of 7. So let's do this. And this basically has added some lines every week. And you can see at the end of week, it is dropping, and then it is starting again. It peaks somewhere in the mid of the week, and again, it drops down. So this is, you're looking at your consumption data, right? Now, what we can also do is we can create some box plots. So when we looked at zooming in data for Jan and Feb, you can add some data points like this. So consumption is highest on the weekdays, as I showed you here, and lowest on the weekends. So this is what we are seeing when we are breaking the data or zooming it further for a couple of months. So we have vertical grid lines, and we have nicely formatted tick labels, that is Jan 1st, Jan 15th, Feb 1st, and so on. So we can easily tell which days are weekdays and weekends with use of these grid lines and basically breaking it down. So there are many other ways to actually visualize your time series data, depending on what patterns you're trying to explore. You can use scatter plots, you can use heat maps, you can use histograms, and so on. Now, moving further, we would want to explore the seasonality, right? So when you further explore the seasonality of our data, we can use box plots basically to group the data by different time periods and display the distribution for each group. Now, how do we do that? Let's come here and let's see how box plot works. So I can just do a simple box plot, and I can choose my consumption column, and that gives me just the consumption data, but this really does not give me any meaning. I can look at solar data, I can look at the wind data, and we can also see some outliers here. So we can create box plots, but if we would want to do a box plot, what is box plot? It is basically a visual display of your 5-number summary. That is, you want to look at your mean, median, you want to look at your 25th percentile, 50 percentile, or 75th percentile. So we can use a quantile function, use the consumption column, and then you basically give a vector which shows you 5-number summary. So that's your quantile. And then let's do a box plot. So if you are looking at quantile, it tells me what is the minimum, what is 25th percentile, 50, 75th, and 100. That's from my consumption column. So let's create a box plot for consumption. Let's give it a name as consumption. Let's give y-axis as consumption and a limit for y-axis. Now that's my consumption graph. So I can look at yearly data. Now that will make more meaning rather than just looking at the complete consumption data. So how do we do it yearly? So we will say consumption, and then I will say the year column. So it is consumption, but grouped based on year. So here I can give x-axis, y-axis, and I can give y limit. So let's create this, and this makes more meaning. We can give some coloring scheme here, but now I'm looking at 2006, 2007, 8, 9, and so on. And we can look at the data. What is the range, right? It gives me 5 percentile, or sorry, 5 number summary of the data per year, and it basically allows me to look at the seasonality of this. Similarly, we can create box plot by just giving consumption, yearly grouped, and here I'm giving the title as consumption, y-axis, x-axis, and y limit, wherein I can also use las. So this is one more feature which you can do, and that basically will give me the tick points. If you compare this one to the previous graph, so when I created this previous graph, I had 2006, 2008, and I had from 600 to 1800. And if I go for the next one, I am basically seeing more useful information. Now let's look at monthly data. So I would want to group it based on months, and let's create that. So this gives me the monthly data where I'm looking at months, and I could select a particular year, or I can just do a grouping based on months. So I can have multiple plots to see a difference here. So let's do this. Now let's create a box plot for consumption, which is monthly data, and let's give it a color. Let's look at the wind data, which is again grouped monthly, and let's look at the solar data, which is grouped monthly. Now, if I zoom in, it basically gives me the seasonality of the data for your wind, for your consumption, for your solar. So what we are doing is we are creating these box plots which are giving us values. Now what I can also do is I could look at the day wise also. But before we look into this, how do I infer some information from these box plots which are being created? So this is what we have done, where we are looking at the data for month, and these box plots give me year seasonality, which we were seeing in earlier plots, but give some additional insights. So if I look at the data here, it tells me the electricity consumption is generally higher in winter. Now this is based on months, so we can see consumption is higher in winters and lower in summer. So we can obviously look at our plot, we can see where it is lower, where it is higher, and then we can look at the median and lower two quartiles are lower in December and January compared to November and February. So that is, you look at the quartiles and you will see that the median and lower two quartiles are lower in December and January. Here Jan and December, so you can look at from my plot. Now this is giving you some idea on seasonality. Now that might be due to business being closed over holidays. Now this one we were also seeing when we looked at time series for 2017 only, and box plot basically confirms that there is this consistent pattern throughout the years. Now when you look at your solar and wind power production, both will give you a year seasonality, what we are seeing here. And if basically I look at the data, so it depends on what parameters you are choosing, but if you look at solar, it will reflect the effect of occasional extreme wind speeds associated with storms and other transient. And since we are grouping it based on months, we can see this pattern is quite evident every year. Now, what we can do is we can group the data day wise. So here, let me again reset this to one plot per graph. Now I'll say box plot. I'll say consumption, which is grouped based on day. Now we know that there is a day column, and let's give a y limit and let's look at the data. So this is where I'm grouping the data day wise. So you look at 31 days and you look at the box plot. So this is where you are plotting it on a daily basis. So you can look at the data, you can break it down to a particular week. So here I have given day and I have chosen all the 31 days, but I can break it down to a week and I can look at the data. So if we look at the data per week or per day, we can basically infer that electricity consumption, where I'm doing a consumption group by day, is higher on weekdays than on weekends. So time series with strong seasonality can often be represented with models that can decompose signal into seasonality and long trend. Now this is an easy way. Now how do we look at the frequency of the data? That could be interesting to see. So let me look at, say, the yearly data which we were seeing here. Now let's go further, and here we have looked at data. So what we will do is we look at the frequency. Now when you look at the frequency, when you talk about frequency in your data, so we have the modified date column which gives me a frequency, and if we really look into the data, that will tell me that the data is on a daily basis. So for that, let's look at my data 3 again, which gives me data, and you can just see all the data or dates are in sequence. So your 22, 23, 24, 25, 26, and so on. I can access a dplyr package that is basically allowing me to work in a better way. Now I can look at the summary of this, and for all my columns, I'm seeing what is the minimum 5-number summary, date, and consumption. So date does not show me anything because this is not in a date format, it is just a factor, but other things have the 5-number summary. So we are looking at wind plus solar, we are looking at year and month and day and all these columns. Now what we will do is we will want to find out the sum of each column, how many entries does it have, and we will say the value should, NA value should not be considered. So let's look at this one. So it tells me for my particular columns. So let me run this again, and that shows me for each column how many values you have, and these counts do not include the NA values. Now similarly, I can find out specifically for consumption. I can find out, is there any NA value? So I'm saying is.NA, and let's find out if there is any NA value or missing value in consumption. It says 0. Okay, that's good. If you look in wind, it tells me there are 1463 entries which are NA. Similarly solar, similarly wind dot solar or wind plus solar. So it gives me a count of NA values, that is missing values, and also values which are not missing. So to understand frequency, what we can do is we can find out the minimum on the date, that is the first column, and I'm saying RM NA.RM is true, that is get rid of NA values and find out the minimum. And let's look at the minimum value. This is the minimum from my modified date. Now if I would want to get the frequency, I can basically use sequence function. So I can say from X minimum, that is the minimum value, I want to look at the frequency, that is day wise, and let's just look at 5 entries and see if there is a day by day frequency. So let's look at the value of this, and obviously it tells me there is day wise frequency. So that allows me to look at the frequency, look at the type of it. It is an integer, class is a date. So similarly, we can say from X minimum, we can basically look at the frequency month wise, and I can again look at 5 records. So that shows me monthly data, right? So I can extract the data for frequency, similarly yearly data, and that's also very useful. Now we can select data which has NA values for wind. So how do I do it? I would want to find out the wind column, and I want to find out where the values are NA. So I will create a variable, and here I will say my data 3, and then I give a conditional where I say is NA in the column. So let's do this. Now once I've done this, I have said that my selected win data from my data 3 where we said NA values, and I will give the names to this. So names should be in my data 3. I'm interested in mod data, consumption, wind, and solar. So these are the 4 columns I'm interested in. Let's look at first 10 records here, or first 10 rows. So that tells me these are the values where wind has NA or missing values. I can always do a view, and that gives me the complete data. So it basically shows me 1,463 entries, and here it shows me all NA values. So you can look at all the way to the end, and it shows me wind has NA. Solar does have some value here in the last row, but then also if you see, the numbers have a difference. So you have 1461 and then you have 2174. So there is a difference. So there is some data in between where wind has some values. So we have found out NA values. Now what we will do is we will select data which does not have NA values. So I will call it cell selected wind 2. I'll again use my data 3. I will say which, but now I'm saying not NA from this column, and I will select the data for the columns. So I'm interested in looking at 10 records, and this shows me not NA values, so no more missing values. So if I really look at this data as I saw earlier, which has NA, and if I look at these values which are not NA for the wind column, so looking at these two results, we will know that in year 2011 wind column has some missing values. So let's focus on year 2011. So how do I do that? Let's call it a different variable. I'll say my data 3. I will say here, when I say which, where we were saying NA, here I will say the year should have a value of 2011, and I want all these columns. Let's look at the data here, and this is showing me 2011, but we are not seeing all the values. So there are some values, but then there are some missing values also for 2011 based on whatever analysis we have done. So let's look at the class of this. It is basically a data frame, do a view, and this one will help me in finding out where are the NA values. So if you just scroll down, looking at all the data, let's search if wind column has a NA or a missing value, and I will see if there is any missing value, in which column or which row it is for the wind column. So we have all the values which are existing. I could select and search for one specific value, and I'll show you how we can do that. So here, let's scroll all the way down. So it's like you're exploring your data and seeing is wind column having NA or missing value for a particular row. And let's scroll here, and here you see there is a missing value for one particular row. So 13th December 2011 has wind value, 15th December has wind value, but your 14th December does not have, right? Similarly, we can search. So there was only one entry which was missing. Now that could be for some reason, might be it was not calculated, might be it was not tabulated. So we have a missing value, and that can affect my plotting, that can affect my analysis. So let's look at the number of rows in this, which will tell me how many rows we have for 2011. So it tells me 365. So that is basically the number of days in a year. Now we will find out if there were NA values. So we earlier checked total number of NA values per column. That is in your row number 265 to 269. We can see here 265 to 269. So this is where we were seeing, are there any NA values, right? So let's go back here, and we want to find out the number of NA values for a particular year. How do I do it? So I can just do a sum. I will say is NA. Now I'm interested in my data 3 wind column, and I'm saying my year has to be 2011, but I'm finding out the NA values. So let's do this, and it tells me 1, and that's right. That's what we saw when we did a view. Let's see how many non-NA values you have, and that is 364. So that basically satisfies my logic. So it's 364 plus 1 missing, so there are 365. Let's look at the structure of this. It tells me you have modified date and date format, you have consumption, wind, and solar. Now let's create a variable. Selected wind 4. I will say wind 3, that is, which was having all my NA and non-NA values for 2011. I will say let's find out the NA value, because I'm interested in finding out that particular row. So I'm saying find out where the value is NA, and I want all the columns. Let's look at this one, and this is my specific row which has a NA value. Now we know that data follows a day-wise frequency, which we have clearly seen. Now let's select data which has NA and non-NA values. So let's call it test 1. I will use wind 3, which has NA and non-NA values. But now I will say I want the modified date, which should be greater than 12/12/2001. Now remember, we had, when we were doing a view, we saw that one particular day, or what we see here, 14th of December, there is no date. So I will select a subset of data which includes this NA and non-NA. That is, might be I can take 13th of December and 15th of December. So let's start from 12/12. So the date should be greater than 12/12, that means 13th, and it should be less than 16, so that is 15th, and the columns, right? So now we have some data. Let's look at this. So I've selected a subset of data. I could have done this using subset also. So I have NA and non-NA values. Now, why are we doing this? So sometimes you might have some data for a particular column, and you may want to find out if there are any missing values. Might be you want to fill them up or replace them with something. So that is usually useful when you are doing a trend detection. So say, for example, you have data for every month, and might be in one of the months you have missed, or might be you have data for every year collected monthly, and then in one of the years for a couple of months you don't have the data. Like I can say 2016, I have data for all 12 months, 2017, all 12 months, 2018, might be I don't have data for March and June, 2019, I don't have data for same months. So I can forward fill or backward fill them using the previous year's same month data. So we can do that. So here I have test data where I've extracted a subset of data. I can look at the class of this. It is a data frame. Structure of this, it has the columns. Now let's use the library and function and use the tidy R package. And what we will do is we will fill it up. So I will use test 1. I will fill the wind column, which has a missing value. Now, once you do this, if you notice, it has done a forward fill. So it has taken the previous value and it has just filled up that. So you can fill up the data using different directions, such as up and down, left and right, and so on. So we can take care of missing values in our frequency data, which allows us to basically analyze the data in a better way. Now, here we will want to also look at some more data. So this is to deal with frequencies of fill column, wherein you can take care of missing values forward filled. So filling values can be done in different directions, as I said, and you may want to first convert your time series to specified frequency if your data does not have a frequency, but we had. Now, if you do not have a frequency, might be you can convert it into a frequency such as weekly, daily, monthly, as I showed you, and then basically you can do a forward fill for the values. So for example, if I have my data, I can break it down into weekly and then look at the values. And if there are any values missing for weekly data, I can use a forward fill. So that can take care of my frequency data. Then let's look at the trends of the data, which is the last part of this project. So basically, let's look at the trend. So when you say trend, what does that mean? So in time series data, you always have some kind of trend. So that will exhibit some slow, gradual variability in addition to higher frequency variability, such as seasonality and noise. Now, to visualize these trends, what we do is we use what we call as rolling means. So we know how our data is spread over year or month or day. But how about looking at a rolling average and see what is the difference? So a rolling mean will tend to smooth a time series by averaging out the variations and frequencies. So this can be higher than the window size. So there is something called as windowing, where you can choose a set of time frame. You can also average out any seasonality on a time scale equal to window size. So this will allow you to look at lower frequency variation in the data. So when we are looking at electricity consumption time series, we already saw there is a weekly pattern, there is a yearly seasonality, which we saw using box plots. So we can also look at the rolling means of the time scales. How do we do that? So for this, you can use some package like Zoo, and then you can basically use a rolling mean using the Zoo package, and you can say what is the frequency with which you want to calculate the rolling mean. Now, how do we do this? Let's look at this data. So here I'm going to look at my data 3, which we have been using so far. Now let's call it a 3-day test. You can give it any name. I'm going to use my data 3. I'm using the pipe in function. Now I will use dplyr and I will arrange the data descending in year. Now you can always break it down step by step and you can see the result of this. So I'm going to arrange this data in descending order of year. So obviously my last one, 2017 or 2018, will be on the top. You want to group the data by year. So it depends on how many years we have, we'll see. So you can group the data by year. Now this data is then used to basically mutate. So mutate function is going to allow me to use this rolling mean. So I'll call it as says 03 day. So I'm going to calculate a rolling mean every 3 days for my consumption column. And basically let's ungroup this. So let's see how this works. Sorry. Yeah, let's look at this. And here, when I'm doing a 3-day test, let's look at the result of this and then I'll explain this. So if you see here, we have the test 3-day column. Now this has the rolling average. Now what does that mean? So first value here, what we see is 1367 is the average consumption in 2017 from the first date with a data point on either side of it. That is, you can look at this date, so 1130, then you look at you're looking at the value 1367 here. So you look at 1130, 1441, 1530. If I take a mean of these, so for example, if I would just do this part, and that is giving me mean, okay, because I have a comment. So let's basically add anything as comment, and then let's do this. So it says me 1367. That's what we are seeing here, right? So you're getting a rolling average every 3 days. Similarly, if you want every 5 days, it takes the 5 values and it gets the mid value, right? So you can always find out the mean, rolling mean for a particular frequency. Now, let's do that for 7 days, that is weekly data, and yearly data, that is 365 days. So how do I do it? Same logic, my data test. Now I'm using my data 3, I'm arranging it in a descending order, I'm grouping by year. So when you do a group by year, so earlier when we did a grouping by and when we looked at the data, it was telling me how many rows we had, right? So let's do a grouping by year and let's say test 07. So that's a rolling average every 7 days. And I'm also saying take care of the NA values. Similarly, I'm getting rolling average every 365 days. Might be you can do quarterly, might be you can do half yearly. And let's do this. So let's create this, my data test. And let's look at the result of this. So I will use my data test. I will say arrange based on modified date. Now we know there is a column called modified date. I want to just look at 2017 data. So I'm doing a filter, right? And then I will choose what are the columns I'm interested in. So I will look at the 7 and 365 day, and let's look at, say, first 7 records. So let's do this, and that basically gives me the consumption value, modified date, year, and my rolling 7-day average or the 7-day mean, which is for first 7 days. And then 365, you will not see the data here, but if I do a view on this, I can basically see the values. So you can always select a particular column to see the values. These are the values for every 7-day rolling average. This is for 365 days, every 365 days. So you see all the values are missing, but every 365 entry, you will have basically some data. Now, let's do a plotting of this and basically visualize this data which we are seeing rolling average. So let me first do a plotting, one plot per graph, and let's do a plotting. I will take consumption data, x-axis, y-axis, color, and give a title to this. So let's create this, and that's my consumption data, which is spread over a period of time, and that's fair enough. But now let's add some more plot to this. So I will add the 7-day rolling average to this. So for second plot to be added in the same one, in R you can use points. So I will say points. I will choose 7 data column. Type is line, width, X limit, Y limit, and color. So let's do this. And that's my pattern 7-day rolling average, which basically gives me some kind of trend. Similarly, I can add one more here, and this time I will choose the 365 day and look at the pattern lines. So now you see some dots here. Well, you could do it in a different way. So I can just add legend to this, and I can say legend will be where in x-axis and y-axis. So I'm saying it will be 2500 and y is 1800. So my legend will come in somewhere here. I'm saying my legend will have consumption, test, and this one I can give some names. I can give what is the color. I can say what kind of legend. It explains what is for each color, and then basically a vector. So let's add a legend to this, and I've added a legend. Now you can do a zoom and look at the data, and here I see that my x-axis is fine, but y-axis is going a little out of my plotting area. So I can actually change that. So here I have 1800. How about making it 1600? And let's look at this one. So we can basically go for this one and start again here, plot and points and line, and then add a legend, right? And you can basically place your legend anywhere in the plot. So this basically is giving me the trend, what I'm looking at, my rolling average. So similarly, you can look at the trend for wind and solar data. So what we are seeing here is when you look at trend, this is one more way of looking at it. You can always create plots in different ways. So 7-day rolling mean has smoothed out all weekly seasonality, which we were seeing here in my graph, where you look at every 7-day, preserving the yearly seasonality. So 7-day will tell that electricity consumption is typically higher in winter and lower in summer. So better is you break it down yearly. So here, if you look at every year, you can see when is winter, when is summer, what is the seasonality, what your trend, what you're seeing here, and if there is a decrease or increase for few weeks every winter. So similarly, if you look at 365, now as I said, rolling average basically reduces the variation. So if I look at 365 rolling mean, we can see long-term trend in electricity consumption is pretty flat. Now that's what we are seeing. It's kind of pretty flat. There is not much variation over years if you really join these dots. So we can basically see some highs and lows, and that gives me a trend. Now this is how you can do a trend detection, and similarly we can do plotting for wind and solar. So this is a small project which I demonstrated using R. Now all this code which you have here in the form of a project.r file, you can find here in my GitHub page. This is the document which explains some things. Feel free to download this and you can add details to it. This is the sample data set, which you can also find in my repository in the datasets folder. So continue learning and continue practicing R.
Want to be a certified data expert? Then here we have postgraduate program in data analytics by Simplilearn. Take a glance at the notable features and skills offered in this course. You will benefit from exclusive IBM hackathons and Ask Me Anything sessions, 8 times more interaction in live online classes with industry experts, capstone projects across 3 domains, and over 14 data analytics projects using real data sets from Google Play Store, Lyft, World Bank, and more. Masterclasses from Purdue faculty and IBM experts, along with Simplilearn's Job Assist for better job prospects. Acquire skills in data analytics, statistical analysis using Excel, data analysis using Python and R, and data visualization using Tableau and PowerBI. Enroll now using the course link in the description box.
Excel is a really powerful tool for data analytics and reporting, and pivot tables are one of the features that Excel offers for creating tabular reports to summarize our data. Let's begin by understanding what is a pivot table. A pivot table is a tool that summarizes and reorganizes selected columns and rows of data in a spreadsheet to obtain a desired report. It does not actually change the spreadsheet data, it simply pivots or turns the data to view it in different perspectives. Pivot tables are especially useful with large amounts of data that would be time consuming to calculate manually. Now, let's understand the different components of a pivot table. So there are 4 main components. First we have rows. When a field is chosen for the row area, it populates as the first column in the pivot table. Similar to the columns, all row labels are unique values and duplicates are removed. Columns is the second component. When a field is chosen for the column area, only the unique values of the field are listed across the top. Then we have values. Each value is kept in a pivot table cell and displays the summarized information. The most common values are sum, average, minimum, and maximum. Finally, we have filters. Filters apply a calculation or restriction to the entire table. So let's jump over to Microsoft Excel and let me show you the dataset that we will use in this demo. So with India being ready for its 16th census in 2021, that is next year, it is a good time for us to analyze India's last census data from 2011 and see where different states and cities across India stood in terms of population, literacy, and other socio-economic factors. We will analyze this data by creating different pivot tables in Excel and explore some of its features. So let's begin. First, I'll show you one of the features that Excel offers us. So suppose I click on any cell and hit Ctrl plus Q, you can see our entire table is selected, and at the right bottom there's an option of quick analysis. Now you can see by default Excel has prompted certain features such as formatting, we have charts, totals, and there's one more called tables. Now Excel by default has created some pivot tables for us. Now the first one you see is sum of district code by state names. Next we have sum of sex ratio by state name. Then we have sum of child sex ratio, sum of male graduates, and sum of female graduates by state name, and there are others. Before creating our pivot table, so let's have a final look at our data set. So first column you see is the city column. So there are different cities from different parts of India. Then we have the state code, we have the state name, district code, we have the total population followed by male and female population. Next you can see we have the total literates from each city. Then we have the male and female literates. Next we have the sex ratio. Then we have the child sex ratio. Next we have total number of graduates. And finally you can see we have male and female graduates. So using this table we'll create several pivot tables. Now first of all, let's create a pivot table to find the total population for each state and sort it in descending order. So you can see here we have the problem statement. So our first pivot table will have the total population for each of the states in descending order. So to create a pivot table, you can click any cell in your data, go to the Insert tab, and here left you can see we have the option to create a pivot table. So let me select pivot table. Now my range is already selected, the entire table, and here I'll choose existing worksheet because I want to place my pivot table in the same worksheet, and I'll give my location, I'll point to cell Q5. Now let me click OK. You can see the pivot table fields appears here on the right. Now since we want to find the total population for each state, so what I'll do is I'll drag my state name onto rows. So here in our pivot table you can see we have the different state names listed. Now we want the total population for each of these states. So in the field list I'll search for total population, which is this one, and drag it under values. You can see we have a sum of total population for each of these states. By default, Excel will sum any numeric column. You can always change it to average, minimum, maximum, anything you want. Now we want to sort this column in descending order. So I right click, go to sort option and choose Z to A, that is largest to smallest. You can see here in 2011 Maharashtra had the highest number of population, or the total population in Maharashtra was the highest. Then it was Uttar Pradesh, we had Andhra Pradesh, and if I come down we have Nagaland and Andaman and Nicobar Islands towards the end. So this is a simple pivot table that we created. Now the next problem we have is we want to find the total sum of literates in each city belonging to a certain state. So let's see how to do it. I'll click on any cell, go to Insert, and here I can click on pivot table. My range is selected. I'll choose existing worksheet and give my location, which is Q5. I click on OK. Now here we want to find the total sum of literates. So what I'll do is first let me drag total literates column to values. You have the total sum of literates from all the states. Next, I want to see the sum of total literates based on states and cities. So let me first drag state name onto rows, and then we'll drag city onto rows. You can see here we have our pivot table ready. To the left of the pivot table you can see we have the state names and the cities per state, and on the right you can see the total number of literates from each city. If I scroll down we have Assam, then you can see we have Bihar, and if I keep scrolling we have all the states, Haryana, Himachal Pradesh, there's Jammu and Kashmir, which has now become a union territory. We have Jharkhand, Karnataka and other states as well. Moving on. Okay, so the next thing we want to see is what is the average sex ratio and the child sex ratio for each state. With that we also want to find the states that had the highest and lowest sex ratio in 2011. So let's create a pivot table for this. I'll click on any cell, go to Insert, choose pivot table, click on existing worksheet. I'll select cell Q5 and click on OK. Now since we want the average sex ratio and the child sex ratio, so first I'll drag those columns. Either you can manually scroll and drag it, or here you have the option to search for it. So if I look for child, you can see we have the same column listed. You can just drag it from there. Let me delete this. And I also want the sex ratio, so I'll place it on top of child sex ratio. Next, we want to see it based on different states. So what I'll do is I'll take state name and put it under rows. So here you can see we have our pivot table ready. On the left, you can see we have the different state names listed, and on the right, we have the values. Now we want to find the average. Now by default, Excel will sum the numeric columns. You can see it tells you sum of sex ratio and child sex ratio. So what you can do, you can click on this drop down and go to value field settings, and here summarize values by, you can choose average. You can see the custom name, it says average of sex ratio. Click on OK. Our entire column is now giving us the average sex ratio. Similarly, for this column, let me convert it into average. I'll again click on the drop down, go to value field settings, click on average and click OK. And you can see here we have the average of child sex ratio for each of the states. Now the next question says which states had the highest and lowest sex ratio. So we'll consider this column. So we'll sort it in any order you want. You can do it either ascending or descending. Let me sort it in descending order. You can see we have our column sorted now. So in 2011, Kerala had the highest sex ratio, and if I scroll down to the bottom, you can see Himachal Pradesh had the lowest, which is around 818. Up next, let's explore one more feature of pivot table. So suppose you want to see the top or bottom few rows of a pivot table, you can do that as well. So here we have a question at hand. We want to find the top 3 cities with the highest number of female graduates. So let's see from the entire pivot table how we can filter the top 3 cities. So I'll go to insert, click on the pivot table option, go to existing worksheet, click on Q5 and hit OK. Now since we want to find the top 3 cities, I'll drag city column onto rows, and then we want the female graduates. So in the search bar, I'll look for female and I'll choose this column, that is female graduates, and drag it here onto values. So I have the sum of female graduates for each of the cities. Now since we want to find the highest number of female graduates in the top 3 cities, so let me first sort this column. I'll sort it in descending order. Now we have it sorted. Now from this you can say that Delhi, Greater Mumbai and Bangalore are the top 3 cities, but it's displaying all the cities for us. So let's filter only the top 3. So what you can do is right click and go to filter. Under filter you have the option of top 10. I'll select this. Here I only want the top 3. So either you can go down like this, or you can directly type 3. Your column is already selected. Let me just click on OK. There you go. We have the required pivot table ready, and it only displays us the top 3 cities with the highest number of female graduates. Now the next thing we want to see is how to use a slicer in a pivot table. So we have a question here. What's the total population for all the cities in Rajasthan and Karnataka? So let's create a pivot table for this and see how you can use a slicer to filter the table. Click on existing. I'll click on a location, this time Q6. Click OK. Now since I want the total population, so I'll drag total population onto values, and then I'll select the city onto rows and then the state name also. I'll place it on top of city. So you have in the pivot table all the states and their cities, and on the right you can see the total population for each of these cities. But our question is we want to find only for Rajasthan and Karnataka. Now for that what you can do is go to insert and create a slicer. Either you can create from this option, or you can go to pivot table analyze option, and here you have the option to create or insert a slicer. I'll click on this, and since we want to slice the table based on state, that is Rajasthan and Karnataka, I'll choose state name as my slicer field. You can see this is my slicer here. Now you only want the data for Rajasthan and Karnataka, so I'll search for these two. So here we have Karnataka, so let me select Karnataka first, and I also want for Rajasthan, so let me select Rajasthan also. You can see in our pivot table we only have data for Rajasthan and Karnataka. So this pivot table shows you different cities from Karnataka and the total sum of population from each of the cities, and similarly we also have for Rajasthan. Moving ahead, now we will see another very interesting feature of pivot, that is how you can create percentage contribution of a table. For example, we have a question here: what's the percentage contribution of male and female literates from each state? Now we want to see in terms of percentage and not as sum or average. Let's do that. I'll create my pivot table, click on existing, and I'll select an empty cell. Okay. Now here, since we want to find the percentage contribution of male and female literates, so first I'll drag male literates onto values, followed by female literates onto values. By default it has summed up the male literates and female literates value. And also I want to drag state column to rows. So here you can see the sum of male literates and female literates per state. I want to convert this as percentage contribution. So what we can do is, I'll select any cell and I'll right click and I'll go to show value as, and here I have the option to select percentage of grand total. So I'll select this. You can see we have the percentage contribution of male literates to the total. Now if I sort this, you will get to know which state contributed or has the highest percentage contribution. So we have Maharashtra for male literates, then we had Uttar Pradesh in 2011. If I come down, we had Meghalaya, Nagaland and Andaman and Nicobar Islands as those states which had little or minimal contribution to male literates. Similarly, let's do it for female literates. I'll go to show value as and select percentage of grand total. So you can see here also Maharashtra, Uttar Pradesh, then Gujarat and all had the highest percentage contribution to female literates. So this is another good feature to convert your data and see it in terms of percentage. Now moving ahead, let's say we want to find the bottom 3 cities from each state that had the lowest female graduates. We can do that as well. I'll go to insert, click on pivot, go to existing worksheet, select an empty worksheet and click on OK. Now since I want to see based on states as well as cities, so let me drag the state name first onto rows and let's drag the city column onto rows. Next, we want female graduates, so let me look for female graduates in the field list. I'll drag it onto values. Now we have the list of states and their respective cities, and to the right of the pivot table you can see the sum of female graduates from each city. Now first I'll sort this column. I'll right click, go to sort and click on shortest to largest. Now we have sorted our female graduates from shortest or smallest to largest. Now since I want to find the bottom 3 cities from each state, I'll come to this cell, right click, go to filter and select top 10. Now I'll replace top 10 with bottom and I want the bottom 3 cities from each state. I have my column selected, that is sum of female graduates. If I click on OK, You can see here some of the states don't have 3 cities, so you can see Andaman and Nicobar Islands has only 1 city, that is Port Blair, while the remaining you can find the bottom 3 cities with the lowest number of female graduates. So Andhra Pradesh had these 3, in Assam we had Nagaon, then there was Dibrugarh and Silchar. Similarly, if I come down in Haryana, we have Palwal, Kathal and Zind. If I come further, here you can see for Karnataka, there's Gangavati, there's Rani Benur and there's Kolar. Similarly, you can see for Kerala as well. Now moving ahead, now in the next example, I'll tell you how you can create a calculated field or a calculated column in Excel with the help of a pivot table. So in a pivot table, you can create or use custom formulas to create calculated fields or items. Calculated fields are formulas that can refer to other fields in the pivot table. Calculated fields appear with other value fields in the pivot table. Like other value fields, a calculated field's name may precede with sum of followed by the field name. So here we have a sales table that has columns like the items, which has different fruits and vegetables, and those have been categorized as fruits and vegetables. We have the price per kg, and this is in terms of rupees, and we have the quantity that was sold. Now let's see, if you want to find the sales for each item in the table, you can create a calculated field. So your sales column is going to be the product of price per kg and quantity. So let me show you how you can do that with the help of a pivot table. I'll create a pivot table first. Click on an empty cell, hit OK. Now, if you see on the top, under Pivot Table Analyze and under Calculations, we have the option Fields, Items and Sets. If I click on this drop down, I get the option to create a calculated field or insert a calculated field. I click on this. I'll give my field name as Sales and I'll select my formula. I'll first click on Price per kg and hit Insert Field. I'll give a space, hit Shift 8 to give the product symbol, and then I'll double click on Quantity. Now this is my formula for sales, that is price per kg multiplied by quantity. I'll click on Add and I click on OK. If you see here, there's a calculated field that is present in the pivot table fields, which is sales, but it did not add it to our original table. Our original table is the same, but here we have added a calculated field which is present only in the pivot table list. Now we can use this. It has already taken it under values. Now let's say I want to find the sum of sales for each item under each category. You can see it here. We have our category fruit and we have our category vegetable, and under that we have different items like apple, apricot, banana. Similarly, in vegetables we have broccoli, the carrots, corn, eggplant and others. So this is how you can create a calculated field in a pivot table. Now there's one more good feature that Excel offers us in pivot table is to create a pivot chart. So you can use your pivot table and create different charts. So I'll show you how to do that. If I go to Insert, here I have the option of recommended charts. If I click on this, Excel gives me some default charts which you can use. Let's say I'll select this. Let me drag it a bit to the right. Here you can see I'll close this pivot field list. This is a nice bar chart that Excel has created. This is called a pivot chart. Now here you can see the category fruits and vegetables and the different fruits and vegetables or the items. In the y-axis you can see the total sales. If you see from the graph, guava made the highest amount of sales. Now if I sort this, let's sort this first. You can see it here, fruit guava made the highest amount of sales. Now since I sorted and changed my pivot table, the pivot chart also automatically gets updated. Similarly, there are other charts also that you can create. Let's go to the Insert tab and let's click on Recommended Charts again. Let's look for a pie chart. So this is a pie chart that you can create. Let me click on OK. So here is our pie chart, and each pie represents a certain item, and the pie that has the highest area represents it had the highest amount of sales. In this case, you can see it is guava, and similarly we have other items as well. This is fruit banana, that's corn, and we have spinach and others. Let's explore a few other charts. So first I'll click on my pivot table, go to insert, and under recommended charts, let's now select a line chart. If I hit OK, move it to the right. So this is a line chart. You can see it starts from guava, which had the highest amount of sales, then it drops, and in the x-axis you can see the different items. Similarly, when it starts with the vegetables, broccoli made the highest amount of sales with 2,800 rupees, and our lowest was eggplant at 900 rupees. For fruits, papaya sold the least at 700 rupees. Let's take another chart. I'll go to insert. Under recommended charts, let's see, this time we'll see a bar chart. Now this is a horizontal bar chart and not a vertical one. We just saw a vertical column chart like this. This is an horizontal bar chart. Now you can always increase and decrease the size of these charts. Let's explore a last chart. Let's take the area chart for now. So this is an area chart. Again, it looks similar to the line chart. It starts with guava, which had the highest amount of sales. Similarly, papaya under fruits had the lowest amount of sales. Under vegetables, it was broccoli, and finally eggplant made the lowest amount of sales under vegetable. Now let's go to our first sheet and summarize what we have done in this demo for pivot tables in Excel. So we had our data. This is 2011 census data from India. We had the different cities, the state names, and we had the total population, total literates, female literates, male literates. We had the sex ratio, total graduates, and other information. So we began by understanding how to create a simple pivot table where we calculated the total population for each state and sorted it in descending order. We found that Maharashtra, Uttar Pradesh had the total population in 2011. Then we saw another pivot table where we calculated the total sum of literates in each city belonging to a certain state. So you can see we had the different state names and the cities under each state. Then we saw another feature where you could calculate the average of a certain numerical column. So here we calculated the average sex ratio and the child sex ratio for each state and found out which one had the highest and lowest sex ratio. After that, we saw how you could find or filter tables. We saw how to find the top 3 cities with the highest number of female graduates. We found out that Delhi, Greater Mumbai, and Bangalore were the top cities with highest number of female graduates. Next, we saw how to use slicer in a pivot table. So we sliced our table based on Rajasthan and Karnataka state and saw the total population for all the cities in Rajasthan and Karnataka. In the next sheet, we explored another feature that was to find the percentage contribution of male and female literates from each state. Then here we saw how to find out the bottom 3 cities for each state having lowest female graduates. Now, one thing marked that some of the states did not have 3 cities. For example, Andaman had only 1 city, that was Port Blair, but the others we found out the bottom 3 cities that had the lowest female graduates. Finally, we looked at how to create a calculated field in a pivot table. So we saw how to create a calculated field called sales, and then we explored how to create different charts and graphs. So this was an area chart that we saw. There's a column chart. We also saw or looked at a bar chart, that was a horizontal bar chart. Similarly, we saw how to create a pie chart as well. In this video, we'll be creating two dashboards using a sample sales dataset. So if you want to get the data and the dashboard file that we'll be creating in this demo, then please put your email IDs in the comment section of the video. Our team will share the files via email. Now, let's begin by understanding what is a dashboard in Excel. A dashboard is a visual interface that provides an overview of key measures relevant to a particular objective with the help of charts and graphs. Dashboard reports allow managers to get a high-level overview of the business and help them make quick decisions. There are different types of dashboards such as strategic dashboards, analytical dashboards, and operational dashboards. An advantage of dashboards is the quick detection of outliers and correlations. With comprehensive data visualization, it is time-saving as compared to running multiple reports. With this understanding, let's jump into our demo. For creating our dashboards, we'll be using a sample sales dataset. Let me show you the dataset first. So here is the sales dataset that we'll be using for our demo. So this dataset was actually generated using a simulator and is completely random. It was not validated, though we have applied certain transformations to the data using Power Query features. So this data, as you can see, has 1000 rows. So using the simulator, we had generated 1000 rows of data. Similarly, if I go on top, you can see this dataset has 17 columns. Now let me give you a brief about each of the columns. So first we have the region column. So we have Middle East and North Africa, there's North America, Asia, Sub-Saharan Africa, and others. Similarly, we have the country names from which the item was ordered. The third column is the item type. So we have different items: cosmetics, vegetables, there's baby food, cereal, fruits, etc. Then we have the representative's name, or you can say this as the customer name who ordered the product. Then we have a sales channel column. So there are basically two channels, whether the item was sold offline or online. Next we have the order priority column. Now here C stands for critical. Then we have H, which is for high priority orders. Then we have M for medium priority orders, and finally we have L, which is for low priority orders. You can see the order date column. Then we have the order ID, the ship date. Next we have units sold, which is basically the total number of units sold for each item. Then we have the unit price column. This is the price at which each product was sold. Then we have the unit cost column, which is basically the production cost for each of the items. Next we have the total revenue. The total revenue is actually the product of units sold and unit price. Then we have the total cost column. Now the total cost column is actually the product of units sold and the unit cost. Similarly, we have the total profit column. So total profit is the difference between total revenue and the total cost. And finally, we have created two more columns, that is order year, and then we have order month. Now these two columns were actually generated using the Power Query features. So we used the order date column, which is this column, and extracted order year and order month. So first, we are going to create a revenue dashboard where we'll focus on generating reports for revenue by order year, revenue by year and region, revenue by order priority, and much more. We'll create separate pivot tables and pivot charts and format them to make them look more interesting and presentable. We'll add slices and timeline to our dashboards in order to filter it based on specific fields. Now let's create our first report to see the total revenue generated each year. So we need to create a pivot table for this. I'll click on a cell in my dataset, and then I'll go to the Insert tab. Here we have the option to select the pivot table. I click on this. You can see my table range is selected. Next, I want to place my pivot table in a new worksheet, and let's just click on OK. There you go. So we have a new sheet where I can place my pivot table. So first, I need to find the total revenue generated by each year. So what I'll do is, I'll drag my order year column under rows, and then I'll select the total revenue column under values. You can see I have my pivot chart ready. Now if you want, you can sort this. So from the data you can see we have order year from 2010 to 2017. Now based on this data, let's create our pivot chart. So I'll click on any cell, go to insert, and here you have the option to select recommended charts. I click on this. Now actually I want a line chart, so I'll click on line here and select OK. There you go. So we have successfully created our first pivot chart. Now let me show you how you can format this chart to make it more readable. So first let me delete these. So I'll right click and select hide all field buttons on the chart. So this will delete the buttons present on the chart. Now let me go ahead and edit the chart title. So the title I want is total revenue. I'll type it down by year. Alright. Next, let's do a few more transformations. So if I click on this plus sign, which is actually for chart elements, we have some options like to add axis, axis titles, chart title, data labels, this grid lines, legend and others. Okay, so let's remove the legend now. You can see the total legend is gone. Now let me add axis titles. So we'll label our x-axis and y-axis. So here under x-axis I can write it as year. Similarly on the y-axis I'll put revenue. Okay, now you can move a bit. Alright, now let me select this chart style option and go to colors first. Here I'll select yellow color. Okay, and then let me go back to style. Let's select a new style from this list. I want this style. Okay, now you can also add data labels. So I'll just click on data labels. You can see we have the revenue for each of the years. Now this is not readable at all, so we'll format this a bit. If I click on this arrow, here I have more options. If I scroll down, you can see we have something called as number here. I'll expand this, and under category I'll select custom. Now here we'll give a format code which is a bit different. So this is actually a kind of a formula. So I'll write if my revenue value is greater than, let's say, 9,99,000. Let me make sure there are 6 nines here. So 1, 2, 3, 4, 5 and 6. Okay, we are good to go. I'll close the bracket. I'll give a hash, give 2 commas. So if the revenue is greater than 9,99,000, I'll put it in the format of millions. So within double quotes I'll write M. I'll give a semicolon followed by another hash, and if the value is less than the desired number, it should be 0 million. Let me click on add. Alright, you can see how nicely we have formatted our data, and you see here we have added the new format which is in millions. Alright, now if you want, you can go ahead and adjust the boxes. Let me move this a bit up. I'll delete this. Now if you notice this line chart, you can make a few conclusions. For example, if you see here in 2010, the total revenue generated was nearly 175 million. Now this came down to 150 million in 2011. Then the revenue constantly grew from 2011 till 2014. It reached 195 million. And after 2014, 2014, it again came down to 180 million, and the revenue dropped significantly between 2016 and 2017. In 2017, the revenue was just 96 million. Now before moving ahead to my next chart, let me just rename this sheet. So I'll write it as revenue by year. Alright. Now let's analyze the revenue generated each year in different regions. So for this, we'll create another pivot table. Let me close this. I'll click on any cell, go to insert and select pivot table. I'll just click OK so that my pivot table is placed on a new sheet. Alright. Now this time we want the revenue by each year and region. So first of all, let's drag region to columns. Then let's drag the order year column under rows, and then I'll select total revenue onto values. So here you can see we have the pivot table ready. So for 2010, you can see in Asia, this was the revenue generated. Similarly, if you see for 2013, this was the total revenue generated in Europe, and we have for other years as well. Now let's create a line chart based on this pivot table. So I'll select any cell in the pivot table. I'll go to insert and I'll click on recommended charts. From this list, I'll select my line chart and click on OK. There you go. So we have our next pivot chart ready. So on the right, you see the different regions that are present in different colors. Let me just expand it so that you can see all the regions we have. So in total, we have 7 regions, and each of the regions have been represented in different colors. So if you notice this graph, for the Sub-Saharan African region, in 2012, Sub-Saharan Africa made the highest amount of sales. Now from the sample data, you can also tell that the revenue for North America has been significantly low compared to other regions. Similarly, if you see for Europe, this was the revenue trend between 2010 and 2017. So if you see here in 2011, the sales were at this level, then it significantly dropped in 2012. Then in 2013, there was a huge spike, and then again came down in 2015 and so on. So you can make your own conclusions by looking at these line charts. Now let's format this chart. So first of all, let's delete the field buttons present on the chart, and we'll also delete the legend. Alright, now let me just reduce the size of the chart. Next, we'll add a chart title. So we'll give the title as revenue by year and region. Okay. You can also format the y-axis in terms of millions. So I'll right click on this axis and I'll select format axis. I'll scroll down, and here we have the number drop down. Let me scroll again. Under category, I'll select custom, and we'll use this format that we created for our previous chart. There you go. You can see our axis labels have been changed in terms of millions now. So let's close this and let me save it. Now you can reduce the font size or increase the font size. Let me just show you. Suppose you want to increase the font size of the chart title, so you just select it, and from here you can either reduce or you can increase. You can see now it's 12. If you want, you can make it 16. Similarly, you can also edit the axis labels also. By selecting the chart title, you can also move it to left or right, or you can place it in the center as well. For the time being, let me just keep it to the left. Alright. Now we'll see the revenue and total cost by each region, and we'll create a combo chart for this. So let me show you how to do it. I'll go to my data sheet. I have my cell selected. I'll go to insert and click on pivot table. Let me just click on OK. Alright. So for this, I'll select my region onto rows, and then I'll have two columns under values. The first one is going to be total revenue, and the next column will be the total cost column. Alright, so here we have the pivot table ready. Now based on this pivot table, let's create our pivot chart. So I'll go to recommended charts, and if you see below at the bottom we have combo chart. So this is the preview of the combo chart. Alright, now let me just click on OK. There you go. So we have a nice combo chart ready here. Now the way to look at it is, the bars represent the total revenue, which is this column. Now the line represents the total cost. So let me go ahead and edit this chart a bit. So first of all, let's delete the field buttons. Alright, and let's also remove the legend from here. Next, we'll add data labels. So I'll click on data labels here. Okay, so these are the data labels for the bars or the revenue column. Now let's format the data labels in terms of millions. So I'll click on this arrow, go to more options. If I scroll down, I have number. From here I'll select custom, and I'll choose my type, that is in millions. Alright, so you can see we have formatted our data. Next thing, we'll add a chart title. So here I'll write as revenue by region. It's actually revenue and total cost by region. Before moving ahead, let me rename the sheets as well. I'll write revenue and total cost. Similarly, sheet 3 also I'm going to rename it as revenue by year and region. So this makes your sheet more readable. Alright, now moving ahead. Next, we are interested to get the revenue generated by order priority, and for this we are going to create a pie chart. So let's go to the data sheet and create our pivot table first. I click on OK. Now I'll select order priority under rows, and under values I'll select total revenue. So this is a very simple pivot table. So you have your order priority. So C is for critical, H is for high, L is for low, and M is for medium. Now based on this, let's create a pie chart. So I'll go to recommended charts, and here you have pie chart. I want to select this 3D type of pie chart, and I'll click on OK. Alright, so we have our pie chart ready. Let me just resize it, and from here I'll remove the field buttons, and I also don't need the legend, so I'll delete this as well. Alright, now let's give a chart title. So this is going to be revenue by order priority. Now let's add our data labels. I'll check this option. Okay, now let's again format this in terms of millions. So here I'll click on the last option. I'll go to numbers. Under category I'll select custom, and my type is going to be in terms of millions. There you go. Let me close this. I will just move this to the center. Alright. Now if you want, you can change the color of the text as well. So let's have it in white color and see how it looks. Okay, so this looks pretty decent. Cool. Now moving to our next report. So this time we are going to find the total revenue by countries. So we have multiple countries present in our data set. We want to visualize the revenue generated in each country. So for this we are going to create a horizontal bar chart. So let me show you how to do it. But before moving ahead, let me just rename this sheet. So I'll write revenue by, I'll just put OP, which stands for order priority. Alright. Now let's create our horizontal bar chart. I'll go to insert, click on pivot table and select OK. So I want my revenue based on different countries. So I'll select country and put it under rows, and then I'll choose total revenue and place it under values. So here you have the different country names. We have Afghanistan, there's Albania. Let me scroll down. You have Bangladesh. There are a number of countries. You have Czech Republic, there's Estonia, France, Gabon. Similarly, if you scroll down, we have India, there's Jamaica, Italy, and all the way to the bottom if you go, we have New Zealand, there's Netherlands, Philippines, Portugal. We also have Singapore, lots and lots of countries. We have the UAE, United States of America, Zimbabwe, and others. Alright, let me go up. So based on this pivot table, let's create our pivot chart. So I'll go to insert and select recommended charts. From here, I'm going to select the column chart. You can see the preview here, and let me click on OK. Alright, so here you can see the different country names at the bottom and the revenue for each of the countries. Let's go ahead and edit this chart. So first of all, I'll delete the field buttons. Okay, and let me also remove the legend. Here I'll write revenue by countries. This is going to be my chart title. Okay, let's format this chart a little more. So I'll click on this option and we'll select a new style. Let's say I'll select style 6. Okay, and let me now go under colors and we'll select the color of the bars. So let's choose this color. Okay, so you have a horizontal column chart ready, and at the bottom you can see the different country names and we have the revenue. Cool. Now let me go ahead and rename this sheet. So I'll write revenue by countries and hit enter. Okay, and finally we'll create another report which is going to be part of our revenue dashboard, and this is revenue by items. So we'll visualize our revenue for different items present in the table. So if you see this, we have cosmetics, vegetables, cereal, fruits, there's clothes, snacks, households, and other products as well. So let's check the revenue for each of these items. So we'll continue the same drill. I'll create my pivot table on a new worksheet, and this time I'm going to drag item type under rows and we'll have the total revenue under values. So here on the left of the table you can see we have the different item names and then we have the total revenue. So let me just sort this total revenue from largest to smallest. So you can see here office supplies made the highest amount of revenue, followed by household, then cosmetics, and fruits meet the lowest amount of revenue. I'll click on this, go to Insert and select Recommended Charts. This time I'm going to create a bar chart. So this is how my bar chart is going to look like. I'll select OK. Alright, now let's format this chart a bit. I'll delete the field buttons and I'll delete the legend as well. And let's edit the chart title. So this is going to be revenue by items. Cool. We also want to change the color of the bars. So I've selected all the bars. I'll go to my home tab and here let's say I want to select green color. Alright. I've edited my chart a bit. Now let's make it 14 and I'll remove the bold. Okay. Here if you want you can change the font also. Let's keep it in blue color. Alright. Finally, let's rename this sheet. So I'll write revenue by items. Cool. Finally, now it's time for us to merge all the charts that we have created to our dashboard. So let me show you how you can create the dashboard. I'll create a new sheet and first thing I'm going to do is I'll click on the View tab and uncheck grid lines. So this will remove the grid lines present in the worksheet. Next, I'm going to insert an image. So we'll have a background image on our dashboard. So the way to do is I'll go to the Insert tab and under Illustrations I have the option to select pictures or insert pictures. So I'm going to insert picture present on the device, that is my computer. I'll go to desktop and here I have a folder called Excel dashboard files and I'll select this dashboard background and hit insert. So this is going to insert an image. Now let me just drag this image so it covers a fair enough portion. So I'll hit shift and I'll drag it. Alright. So you can see I have successfully added a background image. If you want you can still expand this background image a bit to the right. Cool. Now the next thing is going to be the title of the dashboard. So I'll click on insert and here I have the option to select a text box. So I'll click on a text box and I'm going to place a text box in the middle and I'm going to name this text box as Excel Revenue Dashboard. On sales. I'll centerline it. Let's do some more formatting. So I'll select this text box. On the top you can see shape format. Here I'm going to expand this shape fill and I'll select no fill. So my text box is transparent now and I'll also remove the outline. Alright. Now let me just double click on the title of my dashboard and I'm going to select a font. You can select whichever font you want. Let me stick to Britannica Bold and I'll increase the size to let's say 30. Alright, I'll just drag the text box. I'll make the text as white instead of black. Alright, so we have our title of the dashboard ready. Now if you want you can also insert some icons to this dashboard. So I'll go to Insert and I'll click on Illustrations again and select Pictures. I'm going to add these two pictures, which is of a store and a cart, to make it look visually appealing. So I'll place the icons here, and similarly let me just copy it and I'll place the cart and the store to the right as well. Alright, next the idea is to bring in all the charts that we have created and place it on the dashboard. So let me copy each of the charts and place it on the dashboard. So I'll hit Ctrl V to paste it, and we'll resize this as well. Alright. Similarly, let me bring in all the other charts as well. Alright, so now you can see I have added all my charts and graphs to this dashboard. So you can see here we have our line charts, our column charts, the combo charts, the pie chart and others. Now let me go ahead and format these charts a little more. So you can see this looks a bit cluttered. So let's adjust the labels. Let me bring this down. Similarly, I'll bring 190 million a little below. Alright, this looks fine now. One more thing we are going to do is we'll remove the white background from each of the charts and make it transparent. So let me show you how to do it. So I'll select this chart, then I'll right click and go to Format Chart area. Here on the right you see we have an option called No Fill. So if I select No Fill, you can see the white background is gone now. Similarly, let me also remove the grid lines. So I'll select the grid lines and hit delete. So I've also removed the grid lines from here. Now let's also remove the white outline that we have. So I'll select this chart, go to Format, and here I'll go to Shape Outline and I'll select No Outline. You see this? So we have our total revenue by year, which is a line chart, and this is completely transparent now. Now what I'm going to do is I'll place this chart over a box. So I'll go to Insert, and in Insert we have the option to create a shape. So I'll click on Illustrations, and here I'll choose a shape and let me select a rectangle. So I'll just create a rectangle here. Alright, and now what I'll do is I'll select this and bring this to front. I'll right click and choose Bring to Front, and I'll place this shape below it. Alright, now the next thing is to edit the shape. So first I'll change the color of this box. So let me select this blue color and let me increase the transparency. So I'll right click and go to Format Shape. Here I'll increase the transparency. Let's keep it to 25%, or let's say 20%. Alright, next thing, we'll just convert all the font to white color, including the axis labels, the chart title. We'll also convert all the axis labels to white color so it looks better. Now we'll just adjust our chart over here. Next thing, let's just remove the outline. So I'll go to Shape Outline and I'll select No Outline. You see, we have now formatted our chart. Let's just pull this a little up. Alright, now we'll add this blue background to all the other charts. So we'll first add the background, make it transparent, and then we'll convert the font text to white color to make it more readable and visible. So for the time being, I'll just pause the video and come back again. Alright, so now you can see on your screens we have nicely formatted our dashboard. So I've added a few logos for each of the charts. You can see the logos here. So for revenue by countries, we have a globe. Then if you see here, this is kind of a map or a location. Similarly, we have all formatted the color of the bars. Then we have also formatted the labels in terms of millions. If you look on the y-axis, even the revenue for year and region are all formatted in terms of millions. If you want this, you can also format the total year by revenue in terms of millions. So the way to do is, you can select this graph, right click and go to format axis. Here if I scroll down, you have numbers, and under category I'll select custom. Then I'll select my type as this format, which is in millions, and you see here we have successfully formatted our y-axis labels. Alright, so the next thing is to add slicers and timelines to our dashboard. Now slicers are used to format your data based on a particular column. Suppose if you want to see revenue by certain items, you can add item as a slicer and you can view the entire dashboard. Similarly, for timelines you can add date columns. So if you want to see what was the amount of sales or revenue generated on a particular year or a particular month, you can do that using a timeline. So I'll select one of the charts, and then either you can go to the insert tab, and here you can see under filters we have slices and timeline, or if you go to the pivot chart analyze tab, here also you have insert slicer and timeline option. So I'll select insert slicer here first. Now it's giving me the list of fields present in the dataset. So I'll select country, region, and let's say we want to know by item type and sales channel. So these are going to be my 4 slicers. I'll click on OK. You can see it here. We have our 4 slicers here, and these are the list of values. So under region we have Asia, this Europe, North America and others. Similarly, we have the different country names for country slicers, and then for item type also we have all the items that were present in our dataset. Now moving ahead, we need to connect all the slicers to a dashboard. So what I'll do is I'll right click on this option and I'll go to report connections. Okay, so under report connections you have all the pivot tables that we created. You currently see only one of the pivot table is selected, so we need to select all the pivot tables. So let me check all the pivot tables present in this workbook and click on OK. Alright, now that we have connected one of our slicers, we'll now connect the other remaining slicers. So I'll right click on this, go to report connections, and I'll check all the pivot tables present in this worksheet. Click on OK. Similarly, let's do it for the country slicer. I'll go to report connections and let me select all the pivot tables. And finally, we have the item type. So I'll right click, go to report connections, and then I'll select all my pivot tables. And let's hit OK. Alright, now let me just organize this a bit. So I'll place my pivot tables to the right. I'll just reduce the size. Let me scroll down. Now I'll add my region slicer here. Similarly, I'll add my final slicer, that is sales channel. Now in our next dashboard, which is going to be the profit dashboard, I'll show you how to add a timeline. Alright, now I have arranged all my slicers. So let's say you want to find the revenue that was generated for an item type, let's say beverages. So you can just select beverages here, and all your charts show the respective revenues. So you have the total revenue by year for beverages only. Similarly, here you can see the revenue by year and region only for beverages item type. If I scroll down, now this chart represents the revenue that was generated in each of the countries only for item type beverages. Let me just uncheck it. Alright, let's say you want to see the revenue generated for a country like India. So I have selected India here, and now you can see my graph has changed only for country India. You can see here it is showing only for India now. Now similarly, you can also filter your revenues based on the different regions. Let's say you want to know the revenue generated based on sales channel. So we have two sales channel, that is offline and online. Suppose you want to know the revenue generated offline, so I'll just select offline. You can see the values have changed. So these were the revenues generated for each of the items only for offline. If you see here, now these were all the offline sales for the different regions. So this is our entire Excel revenue dashboard on sales. We created multiple charts and graphs, then we applied different formatting, we added different icons, then we formatted the labels also. Next we added slicers, and finally we saw how we could filter our data based on these slicers. Likewise, now we are going to create a profit dashboard based on the same data. So before moving ahead, let me rename this sheet as revenue dashboard. I'll write REV dashboard. Okay. Now we'll move to our data sheet and start creating our pivot tables and pivot charts for the profit dashboard. Alright, so let me go ahead and create my first pivot table. So I'll create a new worksheet. This time I'm going to create a line chart to visualize the profit for each year. So I'll drag my total profit column to values and my order year to rows. So here you can see we have our pivot table ready. Now you can sort this data to get an idea as to which year had the highest profit and which year had the lowest profit. So from this pivot table you can see, since I've sorted this data in descending order, so 2014 had the maximum amount of profit and 2017 had the least amount of profit. I'll just do Control Z to undo it. Alright, now based on this pivot table, let me go ahead and create my pivot chart. So I'll go to recommended charts and click on a line chart. So this is the preview of the chart. I'll click on OK. Let me close this. Similarly, we are going to edit this chart now. So first I'll hide all the field buttons present on the chart, and I'll rename the chart title as total profit by year. Next, I'm going to remove the legend, so I'll delete this. Let's do some more formatting. So I'll go to style, and this time I'm going to select my style type. Okay, and if you want, you can choose the colors as well. For the time being, let's have this yellow color. Next, let me add the data labels. So again, if you see here, this is not formatted properly. So let's go ahead and format the data labels. So I'll click on number and I'll select custom here, and the type I'm going to select is in millions, and I'll click on close. So here you can see we have our line chart ready which shows total profit by year. Let's rename this sheet as profit by year. Alright, now let's move back to our data sheet again. Next, we are going to show the total profit by countries. For this, I'm going to create a map. So let me first create my pivot table. So I'll go to insert and I'll click on pivot table. Let me click on OK. Since I want the country names, so I'll select country under rows, and then I have my total profit under values. The next thing I'm going to do is I'll just rename the row labels as countries, and then I'm going to delete the grand total which you can see at the bottom. So here we have the grand total. Let me just delete the grand total. So I'm going to select this pivot table, go to the design tab. Here we have subtotals and grand totals. I'll switch off the grand total. Let me just verify it again. I'll scroll down. You see the grand total has gone now. Alright, now we want to create a map out of this. The way to do is I'm going to select my data, copy it, I'll go on top and I'll paste it here. Using this data, I can create my field map now. So I'll go to insert. Here we have the option to create a field map. There you go. You can see we have our map ready. I can expand this. Now as you can see, our map has a color scale which comes from light gray color to dark blue color. So the countries that are in gray, or you can say light blue, have the lowest amount of profit, while the regions or the countries that have been shaded in dark color or dark blue color have highest amount of profit. I will go ahead and delete this scale. Okay. Next, we need to connect this map to the original data source. So what I'll do is I'll right click on this map and I'll go to select data. Here, instead of the previous range, I'll give my new range now. So my new range will be my original pivot table that I had created. I'll go on top and click on OK. So we have our map ready now. Now if you want, you can change the color of the shade. So I'll just go to colors and let's say we'll keep green color. So the countries that are shaded in dark green have the highest amount of profit, while those which are highlighted in light green color are the countries that made least amount of profit. Okay, now moving on. Next, we want to create a pivot table that will show us the profit by year and sales channel. So for this we are going to create another line chart. So I'll go to insert and click on pivot table. So I'll select new worksheet. Here, since I want to know the profit by year, first of all I'll drag my order year column to rows, and then I'll choose my total profit column under values. Next, I'm going to select my sales channel under columns. There you go. So we have our pivot table here. Based on this pivot table, let me create my pivot chart. So I'll go to recommended charts and I'm going to create a line chart. I close this. You see here, based on this chart, you can tell the profit generated with online sales were actually lower than that of offline. So here the blue line represents offline profit and the orange line represents online profit. If you mark clearly, in year 2012, the online profit was actually higher than the offline profit. So let me go ahead and edit this chart a bit. So we'll delete the field buttons. I'll also delete the legend for now. Let me go ahead and add a chart title. So I'll write profit by year and sales channel. Okay, so this is my second report. Before moving ahead, let me just rename this sheet. So I'll write profit by countries. Similarly, let me rename this sheet as profit by year and let's say SC for sales channel. Okay. Moving ahead, now I want to create a pie chart based on a pivot table that will show the profit by sales channel only. So this is going to be a simple pie chart. So I'll first go to insert, click on pivot table and click on OK. So I'll drag my sales channel under rows and then we'll have the total profit column under values. So this is my simple pivot table. Now let's create our pivot chart, which is going to be a pie chart. Let me explore the other types of pie charts we have. Okay, so I'm going to select a donut chart here. I'll click on OK. Let's edit this chart. I'll remove the field buttons. Let me now remove the legend as well. I'll just resize it. And this is going to be profit by sales channel. Okay. Let's also add data labels. And here again, I'm going to format this label. I'll select the category as custom and my type will be in millions. Okay. Let me just move this to the left and this to the right. Okay. Let's also delete the lines. Cool. Now let me just rename this sheet. So I'll write profit by, let's say SC, which stands for sales channel. Cool. Finally, I'm going to create a report that will show the revenue and profit by items. So I'll go ahead and create my pivot table first. This time I'll choose my total profit under values and we'll also have the revenue column. So I'll put my revenue at the top. Then I'm going to select item type under rows. So here is my pivot table. Based on this pivot table, let me now create a combo chart. So you can see the preview of the chart. The blue bars represent the total revenue and the orange line represents the total profit. I'll click on OK. Let me close this. First, let's remove the field buttons. Let's also remove the legend here. Then we'll add a chart title. I'll name it as revenue and profit by items. Okay. If you want, you can also go ahead and change the color of the bars. So let me just select one of these colors. Okay. All right. So we have our 5 reports ready that we are going to use for our profit dashboard. Next, let's create a new sheet and we'll get started with building our dashboard. So I'll click on a new sheet. Let me just rename this as profit dashboard. All right. We'll continue with the previous drill. So first of all, let's go to the view tab and remove the grid lines. Now we'll insert a background image like we did for our revenue dashboard. So I'll go to insert, Under illustrations, I'll click on pictures and select this device. I'm going to have the same background. I'll click on insert. Alright, so you can see we have a picture of a company, or you can say an organization. Let's just drag this a bit to the right. We'll adjust the size also. Alright. Now let's copy the title of my profit dashboard. So here you can see I have brought my revenue dashboard, and I'll copy the title and the logos that we used for the revenue dashboard. I'll paste it on my new dashboard. Let's just align it in the center. Alright, the next step, let me now go ahead and edit the title. So this is actually going to be Excel profit dashboard instead of revenue. Now we'll copy each of the charts that we just created. For example, the revenue and profit by items, then we had profit by sales channel. All this we are going to copy one by one and put it on the profit dashboard. So let me just copy a few now. I'll paste it here, and later on we can make the adjustment. I'll copy this as well. Similarly, I'll bring the other 3 charts onto my sales dashboard. Okay, so here on my profit dashboard I have added all the charts and have aligned and reshaped it so that it looks good. I have also made some formatting. For example, I have reduced the size of the chart title. Now let me go ahead and show you a few more formatting that we also did for the revenue dashboard. First, let's remove the white background from all the charts. So I'll select the first chart, I'll right click and I'll click on format chart area. Here under fill, I'll select no fill. Next, I'm going to remove the grid lines, so I'll just delete it. Let me close this. Now we also have a outline, so I'll go to design, actually format, and I'll remove the outline. Next, I'm going to add a blue box at the back like how we did for the revenue dashboard. So let me select a blue box from here and I'm going to paste it here. Okay, now let me just select the chart and I'll bring this to front and I'll move this to the back. Next, I'm going to change the font color all to white so that it's clearly visible and it's more readable. I'll do it for the x-axis as well. Okay, so here I have my first chart ready. The same I'm going to do for the rest of the charts. Okay, so now you can see here I have formatted all my charts. I have also added a blue background. You see here I have also formatted the Y labels in terms of millions, which is actually the profit. Similarly, here I have added the data labels. This is for revenue. Some of the charts also have the data legends. So here you can see the blue color represents offline and the red represents online. Similarly, here you have the legends. I have also formatted the map as well. Okay, now the next thing is to make this dashboard more interactive. So we'll add our slicers as well as timeline. First, let me show you how to add a timeline. So I'll select one of the charts and I'll go to insert. Under insert, I have the option to create a timeline. So I'll just click on timelines. So timeline is actually based on date columns. So since in our dataset we only have 2 date columns, one is order date and one is ship date. So Excel has only shown us 2 columns. So I'm going to create my timeline based on order date. So I'll select my order date column and I'll click on OK. You can see here, this is called a timeline. I can expand this. Now this timeline is based on months now. And if I scroll this timeline, you can see here I have my order year 2010 and I have all the 12 months. Similarly, we have for 2011, then we have for 2012, all the way till 2017. Now you can filter this in terms of years, quarters, months or days. Let me just select year now. So I have years from 2010 till 2017. Let me just squeeze this and I'll place it somewhere here on the right. Now let me go ahead and create a few slicers for my profit dashboard. So I have selected one of the charts. Under insert, I'll click on slicer. You can see it gives me the list of columns from which I want to create slicers. So I'll create a region. Let me also select country. Let's say I want the representative's name or the customer's name, and I'll click on OK. So here I have created 3 slicers. Let me first resize it and I'll place it on the right. Similarly, I'll place the country column also. Then we have the region slicer. I'll resize this and I'll bring it here. Okay. The next thing we need to do is I have to connect all the slicers and the timeline to the pivot tables for the profit dashboard. So I'm going to click on the multiple select option and go to report connections. Here I'm going to select all the pivot tables that are related to profit. So here I have selected 4 and I need one more, which is pivot table number 10. I click on OK. Similarly, let's create or connect my region filter to all the pivot tables. So I right click, go to report connections. Here I'll choose all my pivot tables which are based on profit. I'll click on OK. Let's do it for the country slicer as well. I click on OK, and similarly I'll connect my timeline as well. I'll go to report connections and I'll select all the pivot tables related to profit. Then I'll click on OK. Let me now go ahead and create another slicer based on sales channel. So I'm selecting one of the pivot charts. I'll go to insert, click on slicer, and I'll select sales channel and hit OK. So I have my sales channel slicer. Now let me connect it to all the respective pivot tables that are based on profit. Click on OK. Now let me just bring it here. Alright. The next thing I want to show is how are we going to use the timeline first. So you see we have all the years here from 2010 till 2017. Now suppose you want to know the profit that was generated in the year 2012. So I'll just click on this range and now you can see our charts only show information for 2012. So this dot represents there was 51 million profit in the year 2012. Similarly, you can see here the profit by sales channel for 2012. From the map you can see the different countries and the profit each of these countries made in 2012. If I scroll down, you can see the revenue and profit by items. Now if I select another year, let's say 2013, I can just drag this to the right and now you can see our profit by year and sales channel for offline and online. You can see the map or the line chart for total profit by year. So in 2012 it was 51 million and then it went up to 54 million in 2013. Similarly, our map has also changed. Now this is a sort of an information that we have. You can click on this and check the information that Excel has prompted. Alright, so this is how you can use a timeline. Now, as I said, we checked by years. You can also see it for months and quarters as well. Let me just uncheck it. I'll send it back to the place where it was and I'll reduce the size. Okay. Now suppose you want to check the profit made by different representatives. You can select them one by one. Let's say Adam Churchill. This is the profit generated by Adam Churchill. Similarly, you can select multiple persons as well. Now suppose you want to see the profit by different countries, so you can use the country slicer. Let me just bring this to the middle and let's expand our chart a bit. Okay, so here you have the profit by different countries chart. I'll just bring this to the front so that you can see it clearly. Okay, now here suppose you want to see the profit generated in, let's say, United Kingdom. You can select United Kingdom. So this is the map of United Kingdom and it tells you the total profit that was generated in United Kingdom, and below you can see the revenue and profit for all the items that was sold in United Kingdom. So you had beverages, clothes, household, office supplies. So you can see clearly office supplies item made the highest amount of profit in United Kingdom. Now you can also select multiple countries. Let's say I want to know for France as well. So my map will change accordingly. So now I have United Kingdom and France selected, and the other charts present in my dashboard change accordingly. Now I have my country selected as India. You can see the map of India here, and these were the respective profit values. Now one thing to note here is this is actually not millions. That should be in K, that is thousands. So please mark this as 1000 and not in millions. Even for this is actually K and not million. Alright, so we have successfully created our second dashboard, that is on profit. Let me just resize this a bit and we'll place it where it was earlier. Cool. So we saw how to create different pivot tables and pivot charts, and then we formatted our pivot charts based on our requirement. We saw how to edit the colors. Now let me show you one more thing. You can also change the look and feel of the dashboard by going to the page layout tab. Under page layout you have themes. So here you can select different themes. Currently we are with the office theme. Now let me just select another theme, let's say Facet. You see the colors have changed and it looks really beautiful. Similarly, let me try out another theme, let's say Organic. You see our chart has changed. Let me just delete this. Okay, so now once you change the theme, the text also change a bit. You can see the slicers are in a different font. Let me explore one more theme. Let's say this time I'm going to choose Depth, and this is more of a green type of color. You can play around and select whatever theme suits the best. Alright. Now let me just move back to my revenue dashboard and see how it looks. There you go. So since we changed our theme, even our revenue dashboard is also impacted. So this is how it looks now. You can always go ahead and play with different themes, colors, fonts and effects. Alright, so in this demo we saw how to create a revenue dashboard. So we created line charts, this combo chart, pie chart, horizontal and vertical bar charts, and then we learned how to add slicers and connect it to different pivot tables, and we filtered our data to see revenue as well as profit by items, by countries, by different regions, sales channel. We learned how to create a map and lots more.
Welcome to Simplilearn. In this video, we are focusing on ChatGPT and its groundbreaking role in data analytics. In a world where data is the new gold, understanding and analyzing this wealth of information is crucial. But as the volume of data grows exponentially, traditional analysis methods are being pushed to their limits. Enter ChatGPT, a revolutionary AI developed by OpenAI that's transforming how we approach data analytics. But what makes ChatGPT stand out in the crowded field of data analytics tools? How can it not only streamline complex processes, but also uncover insights that were previously hidden in plain sight? Stay tuned as we unravel the capabilities of ChatGPT, share real-world applications, and show you how it's being used by analysts and businesses alike to make smarter, data-driven decisions. And whether you are a data scientist, a business professional, or just a tech enthusiast curious about the future of AI in data analytics, this video is for you. So let's dive in and discover how ChatGPT is not just revolutionizing data analytics, but also how we understand and interact with the vast universe of data. And don't forget to hit that like button, subscribe, and ring the bell to stay updated on all our future explorations into the fascinating world of technology. Now let's get started and unlock the potential of ChatGPT for data analytics together. So guys, an Excel data analyst always looks for ways to improve their efficiency and gain deeper insights from the data. That's where ChatGPT comes in handy. So ChatGPT is an AI-powered language model that can assist you in various tasks, including Excel-based data analysis. And for that data analysis, let's dive into some demos to see how it works. So guys, as you can see, this is the ChatGPT 4, and you could see this has the support of DALL-E, browsing and analysis, and usage limits may apply. Like we have the version that has some usage limits. And for the data, I have downloaded the data from the Kaggle. I will provide you the link in the description. If you want to download the same data, you can. And I have that in my downloads. So this is the data that we'll be using. So the first thing we'll be doing is data cleaning and preparation. So firstly, let's explore data cleaning and preparation. Before diving into analysis, it's essential to ensure our data is clean and ready for processing. So for that, we will write a prompt in ChatGPT and ask him to clean the data. ChatGPT has the feature to insert the files, provide the Excel file to the ChatGPT, and we'll ask him that can you help me identify and remove duplicates in this Excel spreadsheet. So let's ask him, can you help me identify and remove duplicates? Duplicates from this Excel spreadsheet from the provided Excel spreadsheet. So you could see that ChatGPT has started generating the response, and he is telling us that he can definitely help us with that, and he is analyzing that. So you could see that ChatGPT has provided us the response. So let's first go to our spreadsheet. So this is the spreadsheet. Order number, quantity ordered, price of each quantity, and order lines. So you could see that first ChatGPT has encountered an error, and that is with the character and coding mismatch. And then he has loaded the spreadsheet successfully with the second attempt, and you could see that he has provided like the smaller or the briefer version of the spreadsheet. That is, the dataset consists of sales data with columns such as order number, quantity order, price each, order line, sales, order date, status. So he's asking us, could you specify how you would like to identify duplicates? For example, should we consider a row a duplicate if all its values match another row exactly, or are there specifically columns we should focus on to determine duplicates? So we should, or here we'll be focusing on the column section. So here we want to identify column section. So it's asking which columns they should identify duplicates. So we want the duplicates in order number. So the ChatGPT has started analyzing the spreadsheet. So you could see that ChatGPT has produced the response that they have identified a total of 2,807 rows in the spreadsheet that have duplicates based on the order number column. So this indicates that multiple rows share the same order number, suggesting there might be different items or transactions within the same order. So would you like to proceed by removing these duplicates while keeping either the first or last occurrence of each order number, or do you have another approach in mind for handling these duplicates? So before identifying the duplicates, what we'll do is we will first get rid of the extra spaces. So we'll ask ChatGPT that first find the extra spaces in the spreadsheet and help us remove them. So you could see that it has started analyzing it. So he is asking us that would you like to proceed with any further cleaning or data manipulation? Yes, we want to proceed further with data cleaning only. And now we will treat all the blank cells if there are any. Now treat all the blank cells if there are any. So the spreadsheet contains blank cells in the following columns with the respective counts of blank entries. That is, address line 2 has 2521 blank cells, then the state. So depending on your preference or the requirements of your data analysis, we can treat these blank cells in several ways, such as filling them with a placeholder value that is not provided using a specific value that makes sense for data. That is, example, a default state or territory, but potentially leaving them as if blanks carry meaningful information in the context of your data. So what we will do, we will provide a placeholder. Provide a placeholder instead, that is not provided or not applicable. Okay. So you would see that ChatGPT has responded that it has replaced the blank cells in the columns, that is address line 2, state, postal code and territory, with the placeholder not provided. So you could see there's a verification sample showing the updates. So this is how you could clean the data. And now with ChatGPT, you can quickly identify and eliminate duplicates in your Excel spreadsheet using built-in functions and formulas, saving your time and effort. So that would be done by the ChatGPT, and you can download the Excel file from the ChatGPT only. After that, you can just ask him that provide me the output or the resulted spreadsheet. So if we talk about now data analysis and visualization, let's delve into that. So Excel offers powerful tools for analyzing and visualizing data, and ChatGPT can help you make the most of them. So for this also we'll write a prompt to the ChatGPT, and we'll write, for example, we'll write, please create a pivot table and a corresponding chart to analyze sales performance by region. So let's see, like this prompt, what output does ChatGPT show to us? So let's ask him, please create a pivot table and a corresponding chart to analyze sales performance by region. So you could see that ChatGPT has started analyzing the data and the spreadsheet, and you could see that the pivot table below shows the sales performance by region or the territory. So this table indicates that the EMEA region has the highest sales performance, followed by regions where the territory was not provided, then APAC, and finally Japan. So now let's create a chart to visually represent this sales performance by region. You could see that it has provided a chart, that is a bar chart illustrating the sales performance by territory. So you could see the guys that
it has provided us the analysis, and ChatGPT can guide you through the process of creating pivot tables, charts, and other visualizations in Excel, enabling you to gain valuable insights from your data with ease. So let's move to advanced analysis and automation. So lastly, we will explore advanced analysis and automation. So Excel capabilities extend beyond basic functions, and ChatGPT can help you leverage its full potential. And for this also, we'll write a prompt to the ChatGPT that can you assist me in building a forecasting model to predict future sales based on historical data present in the spreadsheet. So let's see what ChatGPT respond to us. So let's ask him, can you assist me in building a forecasting model to predict future sales based on historical data? So let's see what ChatGPT respond to us. So you could see that building a forecasting model to predict future sales based on historical data involves several steps. So for this, you have to prepare the data, select a model, train the model, evaluate the model, and make predictions. So let's start by preparing the data. We'll aggregate sales by order date to create a time series of total daily sales. Then we'll choose a model based on data's characteristics. So we will grant the permission to ChatGPT to proceed with the steps. So we have started analyzing the data. So you could see that the data has been prepared into a time series of total daily sales. And before choosing a forecasting model, it's helpful to visualize the sales time series to understand its characteristics such as trend and seasonality. So ChatGPT has plotted a daily sales data, and then he has given the visual trends and the possible seasonal patterns. And the next steps would include testing for stationarity, model selection and parameter tuning, model training, and then forecasting. So you could follow all these steps with the help of ChatGPT and could create a forecasting model. If you want, we can move to the next step. So you could provide a prompt to the ChatGPT that move to or proceed with next step. So step by step, ChatGPT will provide you a forecasting model, or it will help you create a forecasting model. As you can see, it has started analyzing it. So the augmented Dickey-Fuller, that is ADF test, gives up a p-value of approximately 0.0033. Since this p-value is less than the common significance level of 0.05, we can reject the null hypothesis that the time series has a unit root, meaning the time series is stationary. So you could see that he is asking us, shall we proceed with the SARIMA model parameter selection? Yes, here is the model parameter selection. So you could select any based on the trends and the bar graphs plotted by the ChatGPT. So you could see, guys, that the ChatGPT has analyzed the spreadsheet and provided the response that the grid search for the optimal SARIMA parameters based on the lower ACALI information criterion, such as the best fit model uses the parameter 011 and for ARIMA and 01112, that is for the seasonal component. So you could see that it has provided the model and the parameters. Now it's asking us, shall we move on to forecasting future sales with this model? Yes, proceed with that. So you could see that with ChatGPT's assistance, you can build complex forecasting models in Excel, allowing you to make informed decisions and plan for the future effectively. So ChatGPT is a valuable tool for Excel users and data analysis, offering assistance in data cleaning, analysis, visualization, and automation. And by integrating ChatGPT in your Excel workflows, you can enhance your productivity and uncover new insights from your data. So you can try ChatGPT for Excel data analytics today and take your Excel skills to the new level. And you could see that there's an error in the analyzing, and he has encountered an error while trying to plot the forecast with its confidence intervals. So this type of error can occur due to data type issues, particularly when handling data indices and forecast. And despite this hiccup, the forecasting process using the Cinema model was completed and we were able to generate forecast for the next 12 months. Unfortunately, due to the plotting issue, we couldn't visually display it. So we'll ask him, can you try once again? So you could see that this time ChatGPT has provided us the forecast for the next 12 months. That is, the forecast have been successfully plotted along with the historical daily data. So here we have our forecast model, and with the ChatGPT's assistance, we can move with other analysis also.
Welcome to Simplilearn. Today, we will learn data analytics with AI. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Let's get started with the main topic of today's session, which is data analytics with AI. So, before proceeding with data analytics with AI, let's understand what exactly is data analytics. So, data analytics is not just a step where you just give your data to AI and it will be done, right? So, it's a stage-by-stage process. Let's understand all the stages, one after the other. Firstly, you might have different sources. So, before we go ahead with the sources, let's understand the situation. You might be dealing with your client. You might be working with the company as a data analyst. So before you begin with the data analysis, you might have to have a conversation with your client or the company. You might have to go through something called as requirement gathering, right? So requirement gathering will let you know from where exactly you're getting the data. Is it in the form of a PDF? Is it in the form of an Excel spreadsheet? Or is it going to be cloud or anything like that, right? So you'll be understanding what the source exactly is. And followed by that, you will understand what is the request of your client, what he's looking for, what he wants you to give him, right? The insights of the data, which part of the business he wants you to focus on, and which part of the business he wants to improve, right? And followed by that, you will come up with a time span. Within that time span, you need to use that data, build some insights, and give it to the client or your business owner so that he comes up with a business decision, right? So that's the first requirement gathering step. Once you have the source, you come up with the next step of the data analytics, which is cleaning the data and transforming the data. So it's really obvious for any beginner or an expert who is a data analyst. It is cleaning and transformation what makes or what adds value to your data. Once you clean your data and transform it. So what exactly you mean by clean and transform? So let's say you might have some blank entries, or might be some wrong data type, or there might be some places where you might have to split the data. For example, if there is a customer and customer ID mixed up together, let's say customer ID 1345 hyphen the name of the customer, right? You wanted to split the customer ID and split the customer name. Then comes the data split option. Apart from that, if you want to categorize the data into buckets, let's say you might have a column for customer age. There might be customers starting from 10 and all the way end up to 80, right? In those scenarios, you might want to split the data into buckets. Let's say 10 to 20 are teenagers, and above 20 to 30 are youth, and above 30 to under 50 or under 60, let's say like 59 are adults, and after that maybe senior citizens, right? Then you have a smaller window so that you can capture which category of the age group is bringing you the most of the revenue, right? So these are the parts of cleaning the data and transforming the data. And once you're comfortable with it, then you can choose a platform where you want to analyze your data, which can be Tableau, which can be Power BI, ClickView, or Excel, or any of the tools that you might want to prefer. In our scenario, we want to go with AI, right? So AI can be anything. You can go with the Microsoft's Copilot. You can go with the OpenAI's ChatGPT. You can go with Google's Gemini, or any of the AIs which can perform data analytics. There are some AI tools out there which are dedicated for AI data analytics, right? And once you're done with it, and the final stage is analyzing the outcomes and reporting that to your business owner or client. So I hope I made myself clear with these stages of data analytics and reporting. Now let's look at an example to explain this a little better. So I have the dataset in Excel for now. This is our source, the first part of data analytics. Let's expand the columns. So there you go. I said something about data type. So here you can see we have some different data type which we don't want, which is in general. So we will change this data type to short date to make a little more meaning out of it. And after that, here we have customer ID, right? So what we will do is use data split here. Go to text to columns, delimited. Next. So we have other. So here's the preview. So you will be receiving it in this form. And if you want to format the data as you like, you can go ahead. So I'll leave it as general for now and finalize the data type after the split is finished. So what you can do is add a column, new column here, so that you can get an empty column here to split the data. Go to text to columns once again. Select delimited. Select next. And we have the input other. Next and finish. There you go. You have customer ID and you have customer name, the respective customer name here itself. So proceeding ahead, we have quantity, the quantity of product ordered, and we have traffics, leads, orders, and revenue, right? Cost to company and delivery status. So in case if you wanted to kind of calculate profit, what you can do is add a new column, profit, and here you can do a mathematical calculation equals to revenue minus cost to company, and you can extend this particular column all the way to the end so that you have the profit numbers. And here you can also change the data type to currency and go to home, and here the data type from general to currency, and there you go. And if you want it in rupees, you can go with rupees, or if you want it in dollar, you can also have dollars, right? So that's how you do it. I would like to go with dollars, so more, and here go to currency, and in currency symbol, I'll go with the dollar. Then okay, there you go. You can quickly save it. If you want to add some borders to the data, you can also do that. There you go. So far, so good. So we are now good data. Now comes the next step, which is loading the data and analyzing it, right? So currently we choose the platform as Excel. So you can do this on Excel, Power BI, and ChatGPT as well. So let's go with the first one, which is Excel's AI. So here you can see analyze data, or also people call it the co-pilot of Excel, right? Now you can just click all the data and click on analyze. Basically what you can do is insert and go to the pivot table option, and here you can insert a pivot table, and after that you can find out the requirements what you want, the sales from the central region, south region, and which category of the products have been sold the highest, and what's the highest grossing product, what are the number of leads, and you can estimate the performance of traffic on a month-on-month basis, right? You can do that all, but if you want to reduce the time, basically I would like to tell you, go to that particular part first. Understand manual process, and after that, go to the analyze data option, which is the automated or AI generated report, right? It will now read your data and it will give you some insights from the data given. Right here you can see the cost to company by order status, and here you can see you can set a pivot table for that, and here you can see you can insert some graphs and charts here, bar graph, and here you have another one. Now you can see that it has all 24 results, all the insights. Now if I can ask, give me a pie chart of sales and category. Here you go. Here you have so basically what Copilot did is it created a pivot table of sales and category, and out of that pivot table it extracted the pie chart and generated one for you. In this way you can create multiple options. Let's say I want to create a line graph month on month. Enter. Now here it again created a pivot table, and here it generated a line graph on month basis and how many number of traffic or how many number of visitors your website had. Right? In this way you can create a long list of all the required charts and graphs for your website and or the client, and create a dashboard out of it, which is completely interactive. Now this was the Excel's AI. Now if we go to another one, which is Power BI, so here you can see a completely prepared dashboard in Power BI, and we can create this once again, or you can at least understand how it was done, right? Now let's get the data from Excel workbook. So my workbook or my data set is somewhere here, sales data. I would like to go with orders data. Only one file is enough for 2024, and your data will be shortly loaded. Select spreadsheet 1 and load the data. Since we already transformed it, there is no need for transforming it once again. So the data is being loaded successfully. It's going to take some time. 2000 rows loaded. Sheet 1. So we are going to work with sheet 1. Now you can select the visualization you want. Like I want to create a line graph here. Repeat. Like I want to create a line graph here. Select. And for this particular line graph, you will have fields, x-axis and y-axis. Now what I'll do is I'll drag and drop date to x-axis field and traffic to y-axis field. Now here in x-axis, I would eliminate year, I would eliminate quarter, I would eliminate date. I just want month on month, right? Here you have a clear month on month traffic line graph. Right now let's quickly delete it. We don't want this now. And remove it. Now, what if I tell you there is an option where you can just double click and or right click and you will get an option. Here you can query, right? You can just write down the query, line graph, type of graph you require, traffic, write the spellings correctly, month on month. And enter, you will get the graph you are looking for. There you go. Right? So apart from this, let's put the month on month graph here. Apart from this, let's double click once again and category wise sales. Category sale, pie chart. There you go. And now region wise, double click once again. Region wise sales, bar graph. Select the first one, and there you go. I think there is a small mistake in the selection, spelling. Select the first one once again, and there you go. You will have a bar graph in region wise basis. Or we can also go with similarly, we can also go with the map chart for states and revenue. Select the first option, and you will have all the American states and their revenue details here, right? So in such way, you can use the artificial intelligence of Power BI and create a completely interactive graph just like this one. So if I select the standard shipment mode, what are the sales reports? And if I select the entire shipment modes, what are the reports? And if I select the home category, what are the sales reports and which part of the nation and and what are the sales and order per month, traffic and everything details here, right? In one go. It is completely interactive. Now, let's move on to the next part of our session for today. So we will be using ChatGPT for our data analytics. So here you go. Now, let's load the data. Before that, let's write a prompt. Some data on sales or sales report visualization. And now load the data. Upload from computer, and we have the sales data here, the orders data. Select the orders data file and open. The data will be loaded shortly, and since it's loaded, you can just push the command or prompt. It'll first review the contents and understand what exactly is present in your content and the data type along with the data type, right? It has 2000 entries, 17 columns. Here's the brief overview of all the columns. So it's asking you, would you like an overall summary or a specific aspect? So let's go with the specific aspect instead of overall summary. I want region-wise sales as a bar graph. Okay, we didn't have a column as bar sales. It's in turn taking revenue. Yes, there you go. Sales revenue by region as a bar graph. Now, pie chart for category revenue. Okay, so there is some limit for analysis. Okay, that's not a problem. We can change the account and try to do it once again, or I should have chosen the overall summary, right? But if you go to the ChatGPT Plus edition, you can get that. Let's try the Plus edition once. So we are on the Plus edition now. So it generated some visualizations, which is completely downloadable here. You can go with that as well. So the prompt is still running. Let's wait for a couple of more minutes and see what exactly ChatGPT is up to. So here we have a profit by category, which was our second request, which did not get successfully authorized because we didn't have a plus one. So now we can see revenue versus cost to company in top 10 products. So which are the top 10 products which are giving the maximum revenue? And here is a detailed report. And if you would like to continue with a few more reports like we did before in PowerBI and Excel, like traffic versus month on month is a line graph. Let's try that. There you go. So we have a line graph of traffic on a month-on-month basis. So that's how you can conduct some data analytics using different AIs on different platforms. So there are many number of platforms: Tableau, Power BI, ClickView, Excel, SQL, ChatGPT, Gemini, and a few more dedicated artificial intelligence tools which are for AI data analytics. And that brings us to the next part of data analytics with AI. So how does data analytics and AI work? So first, basically, once you load the data, AI will start preparing and processing your data, right? So the transformations, what you do, are also can be possible in AI as well. If you request AI to do the transformations, it can do itself. But I would recommend you perform the transformations because you know where the exact requirements are. Once your data is completely transformed, you can load it and get the reports. The next part of it is pattern recognition. As you've already seen, ChatGPT recognizes each and every aspect of the data, from the data type to the minute details like currency and everything. It understands the data first, and then it will request you. It will ask you if you want a complete summary or if you are looking for a particular aspect, right? Machine learning algorithms can identify patterns, trends, and relationships that may not be apparent to human analysts. And there is a possibility that ChatGPT can even identify a few more insights that you never expected to have, right? And moving on to the next part, predictive analytics. AI can also perform some predictive analytics and give you the forecast of what exactly is going to happen in the upcoming future in your business. That may or may not happen. If you find something is about to go down, you can prevent it by taking some predictive steps or measurable steps which can avoid that loss, right? And automated insights and reports. You can also request ChatGPT, right? In Excel, there is something called as Power Query. It acts like a macro or Excel VBA where it stores each and every transformation step you apply. In a similar way, each and every transformation or step that you apply to modify or try to add value to your data and teach that to your AI so that it can also understand that particular automated transformation steps and report to you on a month-on-month basis, right? So this will stop your month-on-month activity of cleaning your data, transforming your data, loading your data, analyzing, extracting some insights, and then creating a strategy. So all these steps will be eliminated because ChatGPT or any other AI will take care of it, and you can focus on implementing some business strategies. And we have decision making. So AI can also help you with some critical business strategies and also help you in decision making. AI algorithms can optimize complex processes and decision making by evaluating multiple variables and multiple scenarios. Now, last but not least, continuous learning. So AI is capable to adapt and learn new things in your business, like how it processes, how it functions, and what's the data source, and most of the aspects in which are involved in business and data analytics. AI systems have the ability to continuously learn and adapt based on the new data and feedback.
In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here. The name of the player is Daniel. He is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as Data Control Language (DCL), helps protect your database from unauthorized access.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product, and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single-valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contains multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data. The order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies. Order table and the product table. No partial dependency in the order table quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency. The instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency. Student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a super key, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So in order to achieve 4NF, we separate the skills and the projects into different tables, the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables, the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
So, what exactly is a CTE, you ask? Now, if you are a beginner in SQL, let's say you wanted to club 2 different tables or more different tables, maybe 3 or 4, right? So you will be using one keyword, which is join, right? And let's say you may have to create a query in such a way that you have to club different tables and you have to extract the results from one table into another and finally create a output table, right? So this might be sounding a little too complex. So basically what CTE does is it acts as a temporary table, right? Now you can write a query and save it as a CTE, right? And that particular resultant table from CTE will not be created, but will be in the memory as a temporary data or an intermediate resultant data, right? Now, whenever you want to use a join or whenever you want to use the same query inside a bracket or inside something in your query, you can just simply use the name of the CTE and then the data you require, the columns you require, and done. You will get the data. Now, this might be a little too complicated to understand in just mere words. Now, let's just go through the formal definition of what exactly is the CTE and what it does, and then let's quickly. So, it's a little too complicated to understand it just with mere words. So, let's get started with the practical examples. But before that, let's understand a formal definition of what exactly is a CTE in SQL. So, CTE, also known as or also called as the common table expression, or some people also are used to call it as a with expression. So the keyword is with. So a common table expression in SQL is a temporary result set that you can define within a query. As I said, it helps to break down the complex queries, make the code more readable, and allows you to reuse the result set multiple times within the same query. Just you need to use the name of the CTE in the places where you want in your query, and it reduces the code length as well as the execution time. Now, CTEs are defined using the with keyword as we discussed before, followed by the CTE name, right? So for every column name or anything in your dataset, you give a name, right? Similarly, when you are using CTEs in SQL, you also need to give a name to the CTE, and that particular name will be used in your subquery positions that will reduce the query length and execution time. So you should be giving a name and the query that generates the result set. The CTE is available only during the execution of that particular query or specific query, right? So as I said, the CTE table, the resultant table which is created while you are using the CTE, will not be created as a permanent table in the database, right? It will be a temporary or intermediate result which will be active as long as your current query which is using the CTE is active. Now, let's go to the demonstration mode where we will try to create some simple queries, right? And we will understand how exactly a CTE can be beneficial in those situations. Now, let's go to the MySQL workbench. This is my MySQL workbench. So I have a lot of tables here. We have the credit card dataset, we have the Sakila dataset, SLP dataset, says Superstore World, etc. Right? So we will be using the Superstore dataset. The database. So firstly, we need to write in the query, which means that I am going to use the Superstore database, right? Sorry, Superstore. So I prefer using smaller case or lowercase for database names and column names, and uppercase for the keywords. For example, here use is uppercase and Superstore is the name of the keyword, right? So that is for identifying or easy readability, which is a keyword and which is a name, right? So let's execute this query and have access to the Superstore dataset. And in Superstore dataset, I have one table called as Excel data. Now let's quickly check what we have in Excel data. Select star from Excel data. Here we have row ID, order date, ship mode, customer care, everything, right? So we have region, we have sales, quantity, discount, profit rate. So we have a number of possibilities, a number of reports that we can generate. But let's try to keep it simple. Let's try to find out unique regions, right? Select unique of regions, right? Or just regions, Excel data. Group by regions. So let's quickly execute this statement and see the output, or maybe we can make some modifications to it, right? Instead of that, you might want to use distinct function so that you don't get all 10,000 plus rows. So basically, this particular dataset has about 10,000 or more rows in it, and it's not real, it's completely made up report using artificial intelligence. So we use ChatGPT to create 10,000 rows of data for 30 years, maybe from 2000 or 2001 to up to 2030 or 31, right? So we don't want all those 10,000 plus columns, rows. So let's use a distinct here and try to execute this statement so that we get 5 of the regions what we have. So there you go. We have 5 regions as expected: Northeast, Southwest, and Central. Now you can also select a kind of maybe average of sales, maximum of sales, and total sales. So this is bringing us somewhere we can try to find out region-wise sales, right? So region-wise sales grouped by years, like 30 years. What was the sale happened in the year 2001, right? We begin from 2000 or 2001 to all the way up to 2030 or 2031, right? So we can see if there is an increase in the year-on-year sales or decrease in the year-on-year sales. We can identify the best performing year, the worst performing year, right? So this sounds like a good use case. Now let's go to the code where I've written it as a CTE and understand the workflow. So here I have named my CTE as sales CTE. So I'm starting it with the keyword with, right? So with sales CTE as. Now this is our query, right? What am I doing? I'm extracting. So according to the dataset, we have the date, right? So the date is year, month, and date of that particular day, right? But we want just the year. So we're using the year function to extract the year from the date as sales year, region, sum of sales, right? We wanted to find out the total sales happened in that particular year as total sales from the data set, Excel data, and group by year, right? We wanted it in increasing order. So 2000 to all the way up to 230 or 2031, correct? So that's how it is. And I'm saving all this as a CTE named as sales CTE. Now, I want to select some parts of that particular CTE. So we want to select sales area, region, total sales from sales CTE, which is right over here, and order it in form of sales and region, right? Now let's try to copy this code and run this in our workbench. Right now, let me close this quickly so that we have a complete view of the code, right? So let's now select all the code. So now we have selected this particular code. Let's try to run this and see the output. There you go. We have the output, but there is something wrong. We did not get the years, right? So all the 30 years of data, here it is grouped by region, which is fine. Okay, we don't want region, we want to group it by year. That's okay. And the thing is, we need to fix this particular year. So maybe there is something wrong with the order date, right? So I think the database has saved this particular. Oh, okay. Since this is generated by ChatGPT, maybe the data type of the date is other than data, right? Other than data type. It may be string. Now, we might have to do some typecasting to change the data type of the order date, and let's quickly do that. So now we have updated the year. So what we have done is just cast here, right? So we have changed the string type of date to the normal date, which follows by year, month, and date. So this is a simple typecasting that you can do, and rest everything. And we've also added a where condition. So where date is not added or date is equals to null, then you can just ignore that. And now let's try to execute this query, and we have also removed that region thing, right? Group by region or order by region. So we want that to be ordered according to the year, which should start with 2001 or the first ever year to the last ever year according to the dataset. Now let's select the entire CTE query and run that and check our outputs. So there you go. So you have the year-on-year sales from 2001 to all the way up to the year 2030 and 2031, right? So that's how the CTE or common table expressions in SQL or the with query in SQL can be used. Today, we will learn Python exploratory data analytics. In this tutorial, we will be going through the fundamentals of data analysis with Python that covers the data analysis libraries, data visualizations, and much more. For better understanding, let's go through a simple use case on analyzing student performance so that we can come up with a report to assess improvisation in their academic performance. So here's the context. Let's imagine our client from the educational institute who runs a couple of schools in the city. He and his school administration identified a growing concern about the overall development of their students, realizing that academic focus alone was not yielding in the desired results. To address this issue, they hired a data analyst to investigate key factors influencing student success. The analyst highlighted critical parameters like physical fitness, parental education, rest and recovery, and access to resources as contributors to students' performance. Based on these findings, the school recognized that a holistic approach is needed. They decided to invest in programs that promote overall development by focusing on key areas targeted by the analyst. The school now successfully enhances both academic performance and overall development of their students. The key to this success was Python's exploratory data analysis, using which the analyst deep dived into data about critical aspects of a student's day-to-day schedule. Now, let's go through a similar approach through our demonstration on Python's exploratory data analysis. But before that, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Now, without further delay, let's get started with our Python exploratory data analysis. But before getting started with the demonstration, let's have a brief understanding of exactly what is exploratory analysis. Is this anything different from regular data analysis? Yeah, that's exactly what we're going to discuss. Now, types of data analysis. So basically there are two different types of data analysis: initial data analysis and exploratory data analysis. Now, what is initial data analysis and what is exploratory data analysis? Let's understand a little briefing about these both. First, let's get started with initial data analysis. So what exactly do you mean by initial data analysis? So data can be in any form. It can be an Excel file, it can be a SQL file, it can be a PDF, it can be an XML, it can be even a website. Whatever it is data. If you have some information in this which can be used to extract some valuable information, then it is data. So initial data analysis is a process of inspecting the data and screening the data that takes place after data collection and before statistical analysis. So before you conduct any statistical formulas and analysis on the data and squeeze the data to extract some valuable insights, the process which you perform is called as initial data analysis. Like taking the data from the source, cleaning the data, transforming the data into a readable format, and using that readable data to build some basic charts. What exactly is happening with this particular company, brand, or anything. Let's say I give you some data from the company, then you get some insights of it. How many number of traffic you received, how many number of orders you received, what's the sale that you made in a specific month, specific quarter, or specific year, and what was the profit. So basic information which you convert from the data and create a dashboard, right? That is called as initial data analysis. So a step beyond initial data analysis is known as the exploratory data analysis. This is where you perform some statistics and probability and predict the future, right? So let's dive deep and learn what exactly is exploratory data analysis. So a simple definition for exploratory data analysis is as follows. Exploratory data analysis is a key step in data analysis process that helps you identify patterns, outliers, and relationships between variables before making assumptions. It is not like you just create a dashboard out of the initial data analysis and you can predict the future. No, it's not like that. You might have to you might have to go through some permutations and combinations. You might have to check the seasons. You might have to check the possibilities, right? During some particular seasons in the year, let's say it's Christmas, then you can expect some good sales. Let's say it's some festival, it's some special occasion, you can expect some good sales on the product, right? And maybe a part of the year, maybe a part of 10 years, a decade, right? In a certain period of time, there might be some reason due to which the sales of a certain product were high. So to make sure that your assumptions, to make sure that your projection of the sales is 100% accurate, or at least 90 to 95% accurate, then you might have to go through the exploratory data analysis, where you make use of statistics in your data analysis. Now, there are certain steps that you might have to follow while going through exploratory data analysis. So following are the steps. So first few steps might be slightly relevant to initial data analysis, like connecting data, cleaning it, transforming it, and loading it. After that, you will import certain libraries from Python. And after that, you read the data, what exactly you have in your data, the number of columns, the number of rows, and if there are any null values, if there are any entries which are invalid, you might have to check that, read that, and you might have to check for duplicate entries. It is possible that one entry might have been entered by two different people, right? There might be a duplication, so you might have to eliminate those duplications. You might have to check for some missing values. You might have to calculate the total number of missing values from the dataset and try to eliminate them from the calculation during your exploratory data analysis. Followed by that, you have to do some model engineering. Followed by that, you might have to do some feature engineering, creating features, and then you will get started with exploratory data analysis. And at the end, you will generate a projection or a prediction or give your assumption that this might happen in the future, and you might have to take action to avoid it, or you might have to take action to improvise it, right? So this is how the steps in exploratory data analysis take part. Now let's proceed and start with our demo on Python's exploratory data analysis. And in this session, we will be using the use case that we discussed before, which happens to be the student's performance dataset. So in this particular dataset, we will be having some columns based on physical activity, the distance from home, parental education, the subjects, the marks they have scored in the previous exam, the marks that they have scored in the previous exam, and if they have any disabilities, if they are having any resources that they require to write the exams, right? So a few parameters, the important parameters that we will be discussing in this session, and followed by that, we will project the future, that how they will, improve in their exams, and if there is a problem and if there is a solution to that, then we can implement that solution and help students to gain better marks in their exam. So that's the overall use case for this demonstration. Now let's get started with our Jupyter notebook. Now we are on Jupyter notebook. Now let's get started. So I would like to have a title for my notebook. So I'll write an HTML code for that. So HTML code, and I have 3 apostrophes. And here I would like to write something in H1, so I want my title to be in H1. So style will be background color, color name will be dark blue. So let's proceed with the Simplilearn's background, which will be dark blue usually. And the color of text will be orange. And I also want to have the font. Let me give the font size as 30. And in the next line, I'd like to have border radius. I can get the border radius as 20 pixels. And padding to be 16 pixels. Text alignment, I'd like to keep it center. There you go. Let's close the H1. Now let's code the background color or border color. So B style. So what we can do is we can basically have this code here, and what we will do is we will reuse this particular code segment, because we will be having multiple HTML codes in this particular workbook, which will explain the results of the analysis that we are doing. So the way we just run the code, and after that we will be getting some visualizations, and I will be writing some textual content in HTML page, so that it will be easier for the people to understand what exactly is happening here, right? So the color will be light blue, and now comes the text. We will close this, and here we will write the text as Python exploratory data analysis, and we will break here for student performance. And here we will close the H1. And lastly, we will display this in HTML code. So basically we missed this library. So we will be importing from IPython display import HTML to display this particular code. So without this particular library, we cannot display any HTML codes in our notebook. So we will quickly run that, and we have a title over here. Now let's proceed with the next part. Now we will use some libraries like CatBoost and LightBGM. So for that we might have to install these libraries. So we will be using pip install here, pip install cat boost, and control enter to run this particular code segment, or you can also use run, and it's installed. And after that we will also install light BGM, sorry, not BGM. So it's already installed. Now we will start importing the libraries that we need. So we will be needing NumPy, Pandas, Seaborn, Matplotlib, and we will also import another special library which is for ignoring warnings. So we will import warnings, and after that we will be importing that warnings from IPython display import clear output. And after that we will tell the Jupyter notebook to import if there are any warnings. So that code will be warning.filter warnings, and in the brackets we will write ignore. So the basic libraries which we will be needing are as follows: import NumPy as np. Let's quickly copy this and proceed, enter. And now we will be needing Pandas as pd, enter. And now we will be needing Seaborn SNS, and we will also use matplotlib.pyplot as plt, and after that we will import warnings from ipython.display import clear output warnings dot filter warnings ignore. Now we'll just quickly run this query, run, and now we will proceed with feature engineering. So you can use a hashtag to ignore that particular line from execution for Jupyter Notebook. And here we will be importing import re from sklearn.impute import simple imputer from sklearn.model selection import kfold. There you go. Now let's quickly run this query. There you go. Now we will proceed with modeling and model evaluation. Once we are done with this, then we will directly import the data into our notebook. So for modeling the data, we will again use a hash code so that this particular line will not execute, and import some libraries ligt gbm as lgb from light gbm library, import lgbm regressor from cat boost, import cat boost regressor. There you go. Let's quickly run this command. There you go. Now lastly, we have one more task before importing the data, that is model evaluation. Once that is done, we can proceed with importing the data. There you go. Let's quickly run it. And now, so far so good, we have done the basic library imports, and feature engineering is done, modeling is done, and model evaluation is also done. Now we can begin with importing the data. So let's also add the HTML code where we have done this importing. So here I will try to add another segment, and I will import the HTML code here which displays a similar HTML format which explains what exactly is happening here. Just a moment, I have the code ready. I'll just paste it here. There you go. Let's quickly run this so that we have a HTML code here, page here which explains what exactly is happening here. So we are importing libraries and also student data. Now let's import the student data. For that, let's write the query. So we are importing the data as data frame, and after that we will write pandas read CSV, right? And here we will add the location of the file, right? So the file is located in my downloads section. So let's quickly copy that location and paste it here. So this is the location of my file. Let's quickly run it. So there might be some error. It's okay, we can resolve it. So in such scenarios, you don't have to worry. Either you can add an R, but even if that doesn't work, you might have to change. In this case, it worked, but in case if it doesn't work, what you can do is you can eliminate the R, and you can just change this from forward slash to backslash. This will also help. So this could be worth it. So this can also work. So these are the situations where you can use this. Now let's proceed with some more interesting facts. Let's try to understand what's going on with our data set, right? So what you can do is, now the data is stored in df variable as a data frame. So what you can do is read this particular data, df dot shape, so that you can understand what's happening with this data, right? So it can tell you that there are 6,607 rows and 20 columns. Now let's add another query part, and here you can try to see the head, right? What head means? Basically, head means the column headers. So what you can do is just write df dot head and run. Now you have the column headers and couple of sample columns, couple of sample rows. Now let's proceed with checking the duplicates and identifying the total number of duplicate entries in this particular data set. So you can write down df dot duplicated dot sum, and you will get the number of duplicates present in this particular file. So we have 0 duplicate entries. Now let's see if there are any null elements in this particular data frame. So df dot is null dot sum. So these are all functions. Control enter. There you go. So in the column teacher quality, there are 78 null entries, and in parental educational level there are 90 null entries, and distance from home there are 67 null entries. Now what we can do is from df shape we can add a new cell here, and we can write a HTML code so that the viewer can understand that we are trying to understand our data. So let's write a quick code for that. So let's not waste much time in just writing the HTML code. So I've got that HTML code written in a notepad already. So I'll just paste it over here, and let's quickly run it so that we have a HTML visibility here. So this was supposed to be the result, so we will add it here. So what we will do is quickly edit this particular content. We'll just quickly copy this code and paste it over here. Change the content from importing libraries to reading student data, and we will cut this code from here and we will paste it in here so that it will give us some information. Let's also run this particular code segment so that we have reading student data. There you go. Now the next part of this session will be about creating a target variable. So overall target of this particular data analysis is about exam score, right? So we can name our target variable as exam score, and let's understand the distribution of this particular exam score with the variables we have. Now let's write down plot dot figure size should be around 15,9 equals to, let's add a bracket here, 15,9, or let's keep it as 6. No, 9 would be a little bigger. Now enter. Now we'll use cbound library here, sns dot count plot x is equals to data frame cleaned target. Okay, before cleaned target, we might have to run a few more. Okay, we did not perform data cleaning so far, right? So let's proceed with data cleaning so far. So we found some empty entries, right? Null entries. And we also found some, so here we have 299 rows which have missing values. So we will have to remove that. For that, we might have to create a new column which has to be named as not assigned, right? df data frame not assigned, which is equals to df dot drop na. So we will be dropping the null values here. It's a function, and here let's print the values. Print df dot df underscore hyphen underscore na dot shape. So how many number of rows and columns we have, right? And after that, let's also try to eliminate the null values as well. Dot is null. So we don't have null values, but we have some illegal entries, maybe some. There you go. Now let's quickly run this query. So there you go. So the new data is about 678, 20. So there is some, okay, we did some mistake here. So we are supposed to add it as null, null. Now quickly run this. So we should not get any errors this time. There you go, no errors. So far so good. Now let's describe the new data set. df na dot describe. So these are the new columns and the rows that we have, and we have mean, standard variation, standard deviation, minimum, maximum. So the scores are split into 25%, 50%, and 75%, which could be based on hours studied, which could be based on attendance, sleep hours, previous scores, tutoring sessions, everything. So minimum sleep hours, maximum sleep hours, 25% of that, 50% of that, 75% of that. So that is supposed to be the describe. Now what we will do is we have a target variable which is exam score, right? Now we will do some changes to it. We already know in an exam there will be a threshold value. It can be 25 marks per exam, it can be 50 marks per exam, and it can be 100 marks per exam, right? In our situation, let's consider the threshold value is 100 marks, right? If there is a situation where marks is entered in a wrong way, right? It can, if they wanted to add 11, but by mistake if they added another one, right, triple one, it's not a right entry, right? So we will try to eliminate those kind of data. So we will create a new data frame here, which is data frame cleaned is equals to data frame underscore not null. So we have eliminated the null values, df underscore na. Now we will add our target variable, which is exam score should be. So let's come out of this, and here we will add it as should be less than or equal to 100, but not more than 100. Let's use square brackets. Here we also, the format is square brackets actually. Now enter, and we will describe this particular data set. Instead of dfna, we will copy paste this here. Now let's run this. Okay, exam score is not identified. Let's quickly check the error and resolve it. Yeah, so we missed out to add colons here. It's okay, not a problem. So this was supposed to be how it is. Now let's run this, and we will have the answer over here. So we have the output. Now let's check the head of this particular cleaned data set. So we can make use of the same code here and paste it right here. And instead of describe, let's write head, so that we have the header of this particular data set. So we have our study and everything normal, and we will categorize the data, right? So we will make use of 3 columns: hours studied, attendance, and previous scores. And after that, we will also make use of other columns in this particular data set, which happens to be the parental involvement, access to resources, sleep hours, tutoring sessions, etc. And now our target will be the exam score that we created over here, right? This exam score will be our target. And using this particular exam score target, we will categorize the data. Okay, we will categorize the data in terms of let's say first class, second class, and pass or something like that, right? So if a student is scoring below 64, and that is a separate category. If the student is scoring equals to or above 65, that is a different category. And if the student is scoring beyond 70, that's a different category. And before we proceed with that, let's try to add a HTML code before this particular data set so that we have an understanding of what exactly happened here. So I'll just quickly copy paste this particular code here. So we will run it. And now next we will check the data type, column separate and everything, and we will create data type category variables. Right, and now so far so good. Now we will create the categories. So num call equals to hours studied, comma, attendance. So let's quickly add the data. Previous exam scores. Just a minute, let's quickly add the columns. Let me take a while. So there you go, I've added the columns. So we are considering 3 different columns. Hours studied, attendance, and previous scores. For num call and cat call, we are considering the other columns apart from the first 3, and our target value is exam score. Let's quickly run this. There you go. And now we will try to build some visualizations. And before that, let's try to add some data from in HTML. Let's try to create a, okay, what we can do is simply copy this particular HTML file here. We can take this and add it here so that we will understand what exactly is happening next. And in place of reading student data, we will write data visualization for student data. And we will keep the colors same, dark blue background, and the color for data visualization will be light blue, and student data will be orange. Let's quickly run, and there we have it. Now our target variable is exam score, right? Now we will compare this particular target variable with 3 other parameters. So our parameters will be the following, as we discussed, creating the segregation in dataset, right? So first will be distribution of target variable with other parameters. So we will create another HTML file for that right here. Just a minute while I paste the code for HTML. Quickly run this. There you go. So distribution of target variable exam score against some parameters. Now we will write the plot for that. Plot.figure. So we are going to consider the size equals to 15,6. Fig size is equals to 15,6. The same one that we considered before. And we will be using cbon SNS dot count plot, open bracket, this is a function, x is equals to df cleaned. Okay, what we can do is just quickly take the column name so that we don't create any mistakes here, and we will paste it over here instead of df. There you go, of target. So our target is exam score, comma, and we will use the palette as green, and the plot title will be distribution of target variable exam score. We can copy this. Okay, just a minute. Before that, plt dot title should be, let's use double quotes. Now copy this and paste it here. I think semicolons went off. Okay, not a problem. It's right here. Let's add a dot as a full stop, and the next line. If you need, you can add the full stop. If not, you can ignore. plt dot grid true, which equals to major, comma, axis is equals to y, comma, line style equals to So I want lines to be hyphen hyphen. In this way I want the lines, and comma, line width, let's say 0.5 or 0.7. Let's go with 0.7. Line width equals to 0.9 mm. There you go. Now let's quickly run this query. There you go, done. And we have the first visualization. So here you can see there are some students which are scoring 58, 59, and you can see maximum number of students are already scoring good marks, which is under 65 and which is under 70 and above 65. And there is a good number of students which are also scoring above 65 as well, right? So 70 as well. So we have now less than or equal to 70, 71, and highest scorer in some situations there is also 100. If you can see, there is slight growth here. There are a few students, toppers maybe, which have already scored 100 as well. Now we have the list here. Now what we need to do is we need to segregate. That is part 1, which is less than or equal to 64, which falls under 65, and another category which falls in between 65 to 70 and above 70. So we need to categorize these three datas and segregate them as bottom 65, top which is above 70, and mid between 70 to 65, right? Now before that, if you want to add an HTML document segment here which explains about the distribution of target, you can also do that. It's already added here. Now let's continue. But in case if you want to add some data which explains that we are trying to segregate, you can also do that. I would like to do that. Let's quickly add that HTML code here. So what this particular code will do is it will tell the percentage of students which are scoring less than 65, number of percentage of students scoring in between 65 and 70, and the percent of students which are scoring beyond 70. Right, let's run this, and here we have the result. Bottom 21.81% scores under 64, while 24% scores over 70, and 50% are in between 65 to 69. Right, now let's continue with the segregation part of the data. So for segregation, we will create three different variables, A, B, C. So first, A is equals to length of df cleaned. So let's copy the column name, data frame name. Length of df cleaned. Inside the square brackets, we'll again add df cleaned of target variable, which is exam score. Let's also add single quotes here. Who are scoring in between or less than. Let's start with less than or equal to 64. We'll not consider 65, we'll consider 64, divided by len of df cleaned target variable exam score, single quotes, into 100, which will give us the percentage. Now similarly, let's just copy and paste this 3 more times for B and C. So here instead of minus, I was supposed to add equals to, and another one. So here equals to, and instead of A, I will write B, and the last one is C. And instead of 64, we will add 70 here for top, and here we will make some changes. It should be greater than or equal to 65. So this is the third category, A, B, C, and then we will proceed with printing the files. So print the bottom for the first one, which is f of A is to dot to f, and we will add the percentage symbol over here, R under 64. Now we can copy paste the same here, and we can change the variables. So here we will be adding under over 70. Lastly, in between, the ones in between, 65 and 70. There you go. Here we will change the values from A to B, and here A to C. There you go, and we can quickly run this query. So it's not 70, it was supposed to be 69. There you go. So we forgot to mention this particular one. Now let's run this. There you go. So we have 21% of people who are scoring under 64, 24% over 70, and 53% are in between average. So I think the school is focusing on improving this particular percentage, reducing this particular percentage, and increasing this particular percentage, and try to eliminate, if possible, this particular one which are under 64. So that is the overall motto, I guess. Now, so far so good. Let's now try to remove infinite values from HTML. Right, so before that, let's add this particular HTML code here, so which explains what we are trying to do. So we will first implement the code that prevents warning about infinite values during data visualization. And now let's add the code which will try to eliminate the infinite values. Let's copy this particular data frame cleaned data frame name here. Now df cleaned dot replace square brackets np dot info comma minus np dot info out of these square brackets dot np dot na non-na values. We're trying to eliminate na values. In place of those values, you can write true. And after that, we will try to eliminate the null. So if it is null, dot sum, give me the total number of null values after this, right? So let's try to execute that. There you go. So all the null entries have been removed here. Now let's see the distribution of numerical values here. So before that, let's add the HTML code for that. So let's quickly run this. So distribution of numerical values. So we will be considering these three parameters. So if you go back, here you can see hours studied, attendance, and previous course. So we will be considering these three values or these three columns and check the distribution of these variables against the exam score. So is it making any kind of variation if the attendance is high? If the attendance is high, is the exam score high? And apart from that, we have if our studies is high, is the mark score is high, and if the previous scores are high, is there a chance to get better scores in this particular exam? So what we are trying to do is we are trying to see if there is any direct involvement of number of study hours and number of days attended and number of or the number of marks they received in their previous course, and we'll try to build a visualization on that front. So let's go and build that. So we'll try to write the code here. Figure axis equals to ELT dot subplots. So we will be having three different plots here since we're considering three different categories, and the fixed size should be equal to 12,4. There you go. Now access is equals to access dot variable for idx comma call in enumerate call, and we will try to import the cbound library here. We will try to create histoplots here, histograms here, histoplot. So line style, we will be selecting this one, and comma line width will be 0.7. There you go. Next will be access idx dot set title. So for this we will be setting the title as distribution of columns. So the columns will be the three ones: attendance, hours studied, and what was the third one that we considered? Previous course, right? So instead of mentioning them specifically, what we can do is we can just write columns here, COL, and close. There you go. And lastly, plt.height, and show the plot. There you go. Let's quickly run this query. Run, and now we will be having the visualizations here. So you can directly see the involvement of these three parameters here if they are trying to help. If the number of hours are increased, then you can see if there is a better improvement in scores. If the attendance is increased, if there is a betterment in scores, or if the previous scores are helping, then you can find it out how it is. There you go. Now we can write a result here in the form of HTML page, and if we run this, it will give you the result. The breaks or gaps in the hours studied variable may be due to the respondents answering appropriately. The variables attendance and previous scores, which exhibit a uniform distribution, have a normal impact on exam scores variable, which is our target variable. Now, let's proceed with another part of this session, which will be about the relationship between the numerical values and the target variables. Now, we will copy paste the same code and make some minute changes to it. So the only change that we did to it is we're trying to build a scatter plot. So we will be getting a scatter plot here. But before that, let's try to add another column here and try to add an HTML code which explains why we are doing it. There you go. A scatter plot. So basically these two are one and the same. Here we use some column graphs. So here we did the same using the scatter plot, which will help for a better understanding. Now we will try to build some correlations. So basically, a list is called correlation is created containing the names of the columns for which you want to calculate the correlation. So here in our situation, it is the df.corr, which is a data frame, and it is created by selecting only these columns for df clean data frame, effectively created a new data frame containing only the specified columns. Now the second one, which is the corr, which is a calculate correlation. So this method computes the correlation matrix for selected columns, which is in df.corr. The 1 indicates perfect positive correlation, -1 indicates the perfect negative correlation, and 0 indicates no correlation. And lastly, the setup of plot. This line sets up the figure size of the plot. In this particular situation, we are choosing 5 and 4. Right, now let's quickly try to execute this query and see the answer. And we will also add the HTML code for this so that we have a better understanding for this. So we will be adding that HTML box here, which will explain what exactly happened here. So this is our plot and this is the correlation. Now let's try to add that HTML code right here. So the result of this particular data visualization will be maintained here. So the hours studied and attendance shows a positive correlation with the target variable, which is exams hour. However, previous course appears to have no or little relationship with the target variable. Right, now let's continue with our next part of this session. So now we will try to identify the relationship between studies, hours, and attendance and extracurricular scores. Right, so we have other columns to consider, which is extracurricular activities. So there is a belief that extracurricular activities will also help students to study better. So we will find if there is a relation between the target variable and these extracurricular activities, attendance and study hours. Now let's quickly add the code here. Now let's quickly execute the code. Now we have the visualization which explains the relationship between the number of hours studied, extracurricular activities, etc. So here it is. And now let's add an HTML code which explains about this result. I think this particular code was supposed to be added here. So this is the resultant column here. Now here it explains about the influences that it performs. So the extracurricular activities, parental income, and extra things that influence the scores. And there you go. Now let us also consider other columns, right? The other parameters like resources are available or not, parental education, and other things which also might have influenced the exam scores of students. So for that, let's add an HTML code so that we have an HTML page here which explains what is the next procedure that we are following, right? Now let's add the query here. So here we are considering the other parameters like family income, peer influence, motivation level, gender, parental involvement, parental educational level, and extracurricular activities. And we are considering them against the target variable, which is exam score. And now let's execute this query. There you go. Now we have generated a graph which explains about this particular parameters against the target variable. And now let's add the HTML page here which explains about these results. Let's quickly run it, and there you go. So when certain factors affect Q1 and Q2 but not Q2, it can be understood that individual has overcome challenges through personal effort, right? So if government policies and corporate social contributors are focused on addressing these aspects, it seems that we could create a dynamic country with greater social mobility and open opportunities for all, right? So if extracurricular activities can outweigh the influence of other variables in academic performance, then we should foster that kind of an environment, right? So this is how you can extract some statistical analysis on this particular data set. Now let's quickly rename this Python EDA students performance, and you can quickly rename and save it.
Hello and welcome to Data Analytics Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the cells stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. It is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our discover it. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection. Data cleaning, number 3. 4, data exploration analysis. And 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then average the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within 1 standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. The next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining two tables from the same database or two or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from two or more different sources. Combining the Oracle table with the SQL server, or two sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket, and it doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, directory, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible and Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used. And the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array, and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2,5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list. So you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the Read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your Read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive. Where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive. What can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set. Population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population. just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things the group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example, there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP order by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the data set. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample Superstore dataset. Load the orders sheet from the sample Superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample Superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the sales made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select percentage of grand total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total sale. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table, find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, two separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as sales. And then we have our pp.product ID from production product as pp interjoin, sales.sales order detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare our variable at n of integer as begin. And then we're going to declare the sum of integer. Set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then, of course, we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers, sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstore dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top Tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np random arrangement equals np.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplot library. Plot a sine graph using NumPy and Matplot library in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplot library PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplot library inline, that little percentage sign Matplot library inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupByCompany. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
Thank you for joining the Data Analytics full course by Simplilearn. By completing this course, you have taken a significant step toward a rewarding career in data analytics. With high demand for data experts, you are now well prepared to land a top job in the field and enjoy a lucrative salary. So thank you for watching and keep learning from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.